Good afternoon and a very, very good, great, awesome new year for all of you. Welcome aboard, my dear, lovely, amazing, and talented warriors, because this year, 2026, you're going to crack your JEE examination. Remember, 2 years, 1 year, or even 3 years back, you were targeting this particular year, you're targeting this examination, and finally, that moment is close by. So it's time that we do things which we have not been doing before, like conducting this marathon. Yeah, because all this while you were in small classes, maybe 4 hours max or 5 hours max. Now it's time to push yourselves to the maximum limit, stretch yourself like an elastic body, and be flexible for anything and everything, because this exam is your examination, right? And I'm here to help you out with anything and everything, guys. Welcome aboard for the complete physics marathon in most likely 11 to 12 hours or maybe 13 hours. Okay. And the target is we start right now at 1 o'clock. By around 6, 7 o'clock, we try to finish the 11th syllabus. And post that, after dinner break, we try to cover up the 12th standard syllabus. 11th syllabus, weightage wise, is almost 45 to 50% in your JEE Mains exam. But syllabus wise, the theory content wise is more than the 12th syllabus, and you would have noticed that when you moved from 11 to 12th, your 12th standard got over faster, not because you are more punctual or more serious, but because genuinely the syllabus is slightly less as compared to the 11th standard. That's what you will see. All right, so it's useful for everyone. Vishnu, yep. Will it be helpful for my pre-board exam? Bro, this is JEE. Okay, but yes, for your pre-board exam, at least the numerical part, the concept part, you will revise completely. Okay, so it's time that you mark your attendance by liking this video right away, right now. And if you have not yet subscribed, subscribe to the #1 JEE English channel, which is Vedantu JEE English. All right, that's my quick introduction. Captain Shreyas, your physics master teacher, guys. And we are going to start off with units and measurement. And let me just see and say hello to all of you right from here, because you would love to see your name on this big particular video. Yeah, on this amazing day. Nice to see all of you guys. Mark the attendance right away right now. And good afternoon from Tamil Nadu. Hi soldier, welcome aboard. Can I get at least 30 marks? Please, I feel you will get more than 30 marks only. Okay, so good afternoon, Sri. Yes, smash the like button. Thank you so much, Surya. Sir, should I practice or just listen? Just listen. But whenever numericals come, try to keep a rough page or a book and try to practice with me. But it's okay if you're not able to follow that speed. It's fine to watch it later on to do the problem again. But as much as possible, listen only during problems, practice or write it down. Okay? Yeah, my first class of 2026. Yes, Pritija, mine too. Okay. Welcome, Senthil. Hi, Kalyani. We are all excited. Let's begin then. Yeah, thank you so much, guys. Let's start the session. Let's start the session. Just one second. I'll just close this because it will take off a lot of bandwidth today, and I don't want any problems. Okay, perfect. Let's begin. All right. Now, here is the flow of the class. We'll start with chapter 1, chapter 2, chapter 3 sequentially. Like I said, by evening, we'll complete 11th, and after evening, we'll start with 12th. Number 2, we'll do concept of a chapter and we'll try to, take up problems on that. But if you have any specific concern on that particular concept, I will make up a numerical on the spot and make it, understand. Okay, so don't worry about it. That's why you're attending the class live. So, in the first part of the chapter of units and measurement, we talk about the different physical quantities and units, okay, and the system of units. A physical quantity is something which can be measured, and anything like temperature or volume or area or force, these quantities can be measured, whereas happiness, sadness, excitedness cannot be measured, so they are not called physical quantities. Now, these physical quantities are now categorized into two things: independent and cannot be derived, or basically fundamental. Sometimes instead of independent, they also call it as fundamental quantity. That is also one of the name given, fundamental quantities which are independent. Okay, that is, I think, already written over here, and they cannot be derived. Whereas the other one is basically derived quantity, which is dependent or it is obtained from these fundamental quantities. Example, length. You cannot derive it from something else. You can directly measure it. Mass, you can directly measure it. Time, all these quantities are directly measurable. They are independent of the other things. So they are basically fundamental or elementary or basic quantities. Whereas velocity, force and density, or momentum or moment of inertia or angular momentum, or even flux or electric field, or all these complex quantities, they depend on the basic quantities like length, mass, time, current, etc. So that is why they are called as derived quantities. One of the most epic questions over here is the confusion which happens between charge and current. So guys, out of charge and current, who is dependent, or basically who is fundamental then? Yeah, a lot of people make this mistake. Many people think charge is fundamental, current is dependent quantity. It's actually the opposite. Current is the fundamental quantity and charge is the dependent quantity. Charge by time is current. So charge is, so remember, charge by the time is current. So charge is nothing but current multiplied by the time value. So charge, it depends on current as well as the time. So charge is the dependent quantity, current is the independent fundamental quantity. Very good. Yeah. Next, once we understood, okay, there are some basic quantities and many other quantities are dependent on that. So we focus complete attention on those basic fundamental quantities. And there are only 7 quantities which you need to know and which are there, fundamental. So which are those fundamental quantities? Which are those basically fundamental quantities, guys? Yeah. Length, mass, time, current, temperature, amount of substance, and luminous intensity. So these are the 7 quantities which are fundamental. Anything and everything in physics is a combination of these quantities, either multiplication, division, addition, something like that. So length, mass, time, temperature, electric current, okay, and amount of substance and luminous intensity. We do not focus on luminous intensity. It is never there in our JEE syllabus, but you should just know it is a quantity, that's all. In 12th standard, you focus on basically current and maybe sometimes on amount of substance towards the end of 11th standard along with temperature. But most of the time, the questions are on length, mass and time. In only 11th and 12th standard syllabus, you will see these 3 additional quantities coming in. This will never come in your entire JEE syllabus. Got it? Now, when you have these quantities, you always have to measure it in something. Yeah, you will always measure it in terms of something, that is basically unit. So unit is a standard measurement which can be then compared so that we estimate how big or small that measurement is. For example, when I say my mass is 5 kg, instead of just saying just 5, my mass is 5 means what? It doesn't make sense. So when I say 5 kg, then you understand what a kg is, or you know what a kg is. So if you take 1 kg and if you take 5 such kgs, it becomes 5 kilos. So essentially, this kg is nothing but your unit and this is nothing but your magnitude. So this was your physical quantity. This was your physical quantity. Is that right? So you will see that all the physical quantities are expressed. I think we don't have it here. Yeah. So any kind of physical quantity will be n times of u, where u is basically the unit, n is basically the magnitude, n is basically the magnitude, and p is nothing but your physical quantity. Is that right? Now, if you change the unit, what will happen is the magnitude will change. So this will become n prime, this will become u prime. It kind of makes sense. Like, for example, saying my 1 kilometer, it's a different unit, is nothing but 1000 meters. So it's not that 1000 meters is more than 1, because 1000 looks bigger number, but also remember, meter is a smaller unit as compared to kilometer. So that's how the conversion works. N1 U1 is N2 U2. Is that right? So this is how you convert the units. Perfecto, guys. Yeah. Awesome. Yeah, you will be getting notes by one day. It will take some time to process all these notes, but it will come within a day. Okay. So by tomorrow evening or something, you should get the notes. Next is when you make that, you know, magnitude calculation, you measure it. Never will you see that it is actually close, or you can never measure the actual value. There is nothing like actual value. It is always a measured value. So any measurement that you do, whether it is in meters, kilograms, seconds, ampere, Kelvin, mole, or candela. Now, what are these units, by the way? These are your standard units, which I call it as SI units. It's a system of standard. So, most of our measurements around us will happen in for mass in kilograms, for time in seconds, for length in meters, current in ampere, temperature in Kelvin, not in Celsius, and amount in mole, and luminous in candela. Okay, although you have other system of units like British foot pound system or CGS system, where length is measured in centimeters, mass is measured in grams, and time anyways is in seconds. Whereas the Britishers used imperial system where length was measured in feet, mass was measured in pounds, and time was measured in seconds. But we do not deal with that because it is very unnecessary, lengthy in calculations. This makes more sense because everything is in powers of 10, which we also call as the metric system. All right. Now, whenever you make a measurement, it is never really very close. It might be close to the real value, but it is never really known what that true value is, because you always have some or the other kind of error in the process of measuring it. So that is why there are also concepts of errors in the measurement, and these errors come because of many reasons, and you cannot avoid them no matter what you do. So you need to accept it by full heart. One is instrumental errors, meaning the instrument itself has some fault, or the manner in which it has been designed will cause some error. Zero error means before starting the measurement, you did not check whether it was showing zero. Just like when you fill petrol or fuel in the fuel pump, what do they say? Ensure that there is zero on that reading. If you don't, then gone. Whatever reading you are getting is a completely faulty measurement. Getting it? So that is basically zero error. How many of you check zero before filling the fuel? Sir, I don't drive car, I don't drive bike. Maybe you might have seen your mom and dad filling up the petrol and they show zero, right, before filling the petrol. So that is basically zero error. Environmental errors, meaning the wind blew, because of which, the device started shaking and the pointer moved here and there. So you got a different reading. Or maybe, there was a lot of heat around. So everything started expanding, and because of which you got a different value than what you are supposed to get. So these are all environmental errors. Sometimes even random errors can happen. Randomly out of nowhere, something happened. You thought of something. Instead of seeing straight, you saw from here, and because of which you saw the pointer to be on that side. Or I don't know, something happened. Your friend pushed you and you got carried away. Instead of writing 2, you wrote 3. So these are all random errors. So these are basically your errors in measurement. And whenever you take a measurement, it can be accurate, it can be precise, and either accurate or precise or a combination of both. There is a small difference between these two. See, when I say accurate, that means it is close to the true value. Say I want to measure something, and I know the most likely reading is 5, and the student ends up measuring 5.03, whereas another student measures it as 5.7. Then I know this reading is more accurate than this reading, because this is closer to the true value as compared to this. So that is the meaning of accuracy. Precision means you tell the student, no boss, you have gone wrong. So this student again does the same experiment, and next time he gets the answer as 5.72. Next time he gets it as 5.69. Next time he gets it as again 5.7. So consistently he is getting the same answer, close to same answer repeatedly. But yeah, it is nowhere accurate. But yeah, you are maintaining that consistency. Even if you are doing it wrong, correct, doesn't matter. So that is the meaning of precision, consistency of the measurement. Is that clear? But what you would ideally want, the reading should be accurate, and it should be also precise, meaning every time you do that, you should get close to that value. It's not like, sir, once I did it, I got it accurately. Sir, next time I did it, I got some 100. Next time I'm getting it as 1. So that is not meaningful. I want always the measurements to be precise and accurate. That's the very important thing. Yeah, great. So last thing over here before we move on to problems. So any physical quantity which you measure, all right, will have the most likely values, let's say m plus or minus delta m. Delta m is called as the absolute error. This is the difference between the true value and the measured value, whatever error you are getting. So this is your error. This is the most likely value, that is m. So mean value is basically your m. This is basically your delta m. Relative error is basically the error divided by the most likely value. That means it is delta m divided by m. And percentage error is basically your delta m, whatever is your error, divided by the most likely value multiplied by 100. You will get it in terms of percentage. As simple as that. Okay. So these calculations might be needed at times. Next important thing, significant figures. All zeros which are, all non-zero digits are significant, which makes sense. So for example, if I write 787, these numbers are all significant. So three significant digits are present. But if I write 007, then these two zeros are not significant, whereas the number 7 is significant. So leading zeros are not significant. Yeah, basically these zeros are not significant. These numbers are definitely significant. Leading zeros are not significant. Okay, zeros between the digits are significant, meaning if I write 708007, the moment these zeros are between non-zero numbers or significant numbers, they automatically become significant. But the same zeros towards the left side, they never are significant. Trailing zeros depend on the decimal point. So basically, the logic is, say for example, I write 787.00, then the moment I put a decimal, they become significant. If I write 508.0, let's say just like this much, this is significant. The moment it is after the decimal, it becomes significant. Now, the moment these zeros are trapped between significant digits, they automatically become significant. Similarly, let's say 0, 5, 9, 0, 0, 0, 2, 0. The moment I write the numbers like this, these zeros are never significant. This is significant, this is significant, this is significant. Any number which is after decimal becomes significant. So all these zeros then become significant. So that's how you calculate the significant digits. Okay, everyone. Now there are rules for adding the significant figures. There are rules for adding the significant figures for addition and subtraction, the least of the decimal places. Meaning something like this. Say you want to add two numbers and there are some decimal places. For example, 2.000 plus 3.0. Then the answer is 5.0, the least of the two decimal places. This has one decimal place, this has three. So the least is single decimal place. So final answer will have single decimal place. That's for addition and subtraction. Keep that in mind. For addition and subtraction. Whereas when you have multiplication or division, the least significant figures is considered. For example, I take the number say 28 and zero 0 and I divide it by, let's say for example, 7.0000. Chumma, I'm taking this. Okay. So when I divide 28 by 7, I know the numeric answer should be 4. But now the significant figures. This has 1, 2, 3. This has 1, 2, 3, 4, 5. So 3 is smaller than 5. So this should finally have 3 significant figures. So I'll put 4.00. Got it? So the least of the significant figures for multiplication division, for addition subtraction, it is always decimal place or which is the least. Keep that in mind. All right. So it's time now to do some questions based on this. And also, finally, for any quantity which is expressed as power. So P is some constant, let's say into physical quantity 1 raised to x into some other physical quantity raised to y into like that, then the relative error in that physical quantity is, forget the constant, take the physical quantity 1, the error in it, divided by the mean value, take that x but mod of it, always mod of it, plus take the relative error in the second physical quantity by the mean value, then you take the power and always take the modulus and keep doing it depending on how many other quantities are there. You will get the relative total error in that final quantity. That's all. Okay. So for example, we are going to see some questions coming up on your screen. Here is the first one. What does it say? In an experiment, the length of an object is measured to be 6.50 centimeters. This measured value can be written as 0.0650 meters. The number of significant figures in 0.0650 meters is how much? Come on, guys. Okay. Come on. Think. Yeah. This is for whole of physics ASO official, both 11th and 12th considered together. Okay. Both 11th and 12th. Yeah. Now, many people I know what they do is they take all the digits over here. Sir, this 0 is after the decimal. This 5 and 6 are anyway significant. This 0 is after the decimal. Okay. And then they say that, sir, there are 4 significant figures. Sir, this 0 is also there. So they'll say 5 significant figures. I've seen many people saying the answer to be 4 or 5 like that. Guys, that is incorrect because the context in which the measurement is done is by converting it. This is being converted. 6.50 centimeters is 0.0650 meters is actually wrong because you cannot write it like that with more significant figures. In the first case, this has 3 significant figures. Final answer should also have 3 significant figures, even if it means you're writing it in meters, kilometers, doesn't matter. So actually speaking, you should not write it like that. You should write it with 3 significant figures. Maybe you can write it as 6.50 into 10 to the power minus 2 meters. Or if you want, you can also write it as 65 into 10 to the power minus 3 meters. This is all fine, but in this problem, this has only 2 significant figures, so that will not be okay. So I will have to put maybe one single decimal, something like this, 65.0 into 10 to the power minus 3 meters. All this is okay. So this is fine, this is fine, this is not fine. So this has 1, 2, 3 or 1, 2, 3 significant figures. So final answer will have 3 significant figures, guys. So when you do unit conversion, significant figures should not change. The number of significant figures will remain constant. Got it? So this is very, very important that you rewrite it because this is not the right way. Keep that in mind. Okay? Many people, I bet, would not know about this. Moving on to the next one. The percentage error in A, B, C, D are given. Then the relative error in Z is how much? Okay, in terms of whatever. Come on, think about it. Clear, very good, Dharan. Awesome. Figure this bit out. Okay, give the answer in percentage only because the final options are again in percentage. So think about it. So first of all, delta Z by Z is the first quantity is A with a power of 4. So 4 comes outside and put a relative percentage error of A plus next quantity B has a power of 3. So delta B by B again in percentage. Next quantity C, it has a power of -1 but becomes 1. So into delta C by C in percentage. D's power is 3 by 2. Even though it is negative, always make positive. Remember, always mod value. So delta D by D again in percentage. So this is how you use this formula which I gave it to you over here. Okay, always take the modulus of power into relative or percentage errors. So now over here, this will become 4 into percentage error of A is nothing but 4. Then percentage error of B is nothing but 2. Then percentage error of C is nothing but 3 and percentage error of D is nothing but 1. So 1 multiplied by 3 by 2. So 3 by 2 multiplied by 1. Come on, my dear warriors, how much is it coming out to be? How much is it coming out to be? Come on. 16 plus 16 plus 2 by 3 plus 3 plus 3 by 2. Everybody saying option B or C. Pakka. C for Captain Shreyas or B? 127 by 6%. Just check this out. 127 by 6%, not 5. Yes, 127 by 6%, not 5. Just check it out. C for Captain Shreyas. Yeah, perfecto. BD Harni. Awesome. Hansika. Very good. Shri. Awesomeness. C for Captain Shreyas. Yes, Kalyani. Perfecto. Somakshi. Ritik. It is not B, bro. No problems. But I hope you guys got it. Okay. Let's move to the next question on your screen. The resistance is given by R is V by I, voltage is given and current is given. The percentage error in resistance is how much? See, the moment resistance is written down like that, you can write it in terms of power as voltage raised to 1 multiplied by current raised to minus 1. So therefore, the relative error in R will be power is 1 into relative error in the voltage plus power is negative 1, always take the mod value into relative error of that particular current. Now we have to find in percentage, so we'll eventually multiply it by 100. That's okay. First, error in the voltage is 0.4. The mean value of the voltage or most probable value is 25 plus what is error in current? It is 3, and what is the mean value? It is basically 200. Now this is just relative error. If I want percentage error in the resistance, you just take these numbers. 0.4 is nothing but 4 by 10. So this will be 4 by 10, which is nothing but 250 then, plus 3 by 200. And this whole thing multiplied by 100 so that you get the answer in terms of percentage. Yeah. So just check this out. How much is it coming out to be, guys? 0, 0 will cancel. It will become 3 by 2 over here. Then this 0 will cancel and 10 is there and 25 is there. You can cancel these things off. Yeah, how much are you getting it? 3.1%. Is that so? Option C. Just check it out. Yes, 0.031, which comes out to be 3.1%. Very good, guys. The answer is C option. Thank you for all the love. Rishabh Raj. Thank you so much. Rishib Raj. All right. Very good, guys. So these kind of questions you can definitely get. Now, another major set of questions comes on the dimensional analysis and dimensional, derivations part, where you need to know what are dimensions, how to convert it, and how to derive any expression. For example, take this. Dimensions are basically you take a fundamental quantity and express it with some powers so that you get the derived quantity. So that expression is called the dimensional formula. Okay, and for example, say velocity. I know velocity can be calculated by measuring how much displacement you have done upon how much time you have taken. Time taken is basically the fundamental quantity of time. Displacement at the end of the day is nothing but length. So it is nothing but length by time. So if you take capital L and put t raised to -1 in square brackets, that's called as the dimensions or dimensional formula of velocity. Always dimensional formulas are written down in square brackets with capital letters and all the quantities in the numerator, even though it means writing negative power. Same way, acceleration, we know it is meters per second square at the end of the day. So meters is in length. So length raised to 1 per second square is the unit. So per second square means time raised to -2. So it is actually easy if you know the units, then you can directly write down the dimensional formula. Say for example, I tell you there is some physical quantity whose unit is kg square into meter cube divided by second. Then I know quickly that the dimensional formula will be kg means mass, so mass power is raised to 2. Then length is meter, so length is raised to 3. Time is below, so t raised to -1. So immediately I can write down the dimensional formula if you know the units. So it's beneficial. All right. Now you can also find out the dimension if you know the regular formulas like for velocity, acceleration, force, displacement, whatever, flux, anything. If you know the formula, quickly you can get the dimensional expression. Like for example, they ask you what is the dimensional formula for say flux. Okay, flux, electric flux. Then it is nothing but electric field multiplied by area, and electric field is nothing but expressed in terms of volt per meter, and area is basically meter square. So this will become basically volt multiplied by meter, but volt is nothing but how much joules you take per coulomb. Joules you take per coulomb, and then you multiply it by meter. And joules is nothing but a Newton multiplied by meter, and a coulomb is nothing but current multiplied by the time. Current multiplied by the time. So from this you have got the final unit Newton meter square. So it becomes Newton meter square by ampere into second. By ampere into second. So from this you can quickly figure out what is the dimensional formula. Like for example, for Newton, it is mass into acceleration. So m1 l1 t raised to minus 2. Meter is there, so length raised to 2. Ampere is there, so just put ampere over here. And seconds, that means time is there over here. So finally it will become m raised to 1. Length is becoming power 3. Times power is minus 3. And ampere is coming on the top, so ampere raised to minus 1. So that's how you can find the dimensional formula. If you know other formulas, I know flux is field into area. I know field is volts per meter. I know definition of a volt is joules per coulomb. So you should know all these things. I know joules is work is Newton into meter. So these other formulas from physics, if you know, it becomes very easily. Okay, very good, Navnish, amazing. So, having said that, you can use dimensions to check whether LHS and RHS dimensions are matching. If they don't, then it is a wrong equation. It should always be the same. You can also use it for converting units. You can also use it for deriving some expressions by checking dimensions on both sides and figuring out the powers. Okay. But please keep in mind, dimensions cannot be used to determine constants like gravitational constant, Coulomb's constant, all those things, or in time period formula 2 pi. You cannot figure it out. You can also not use it for exponential, trigonometric, logarithmic formulas, right? You can also get very weird or unique equations which has plus, minus and all of that. You cannot use it in such situations. Simple expressions, it is definitely useful, not for complex trigonometric exponential formulas. So let's have a look at this particular question coming up on your screen. The velocity of a particle at any instant is given by v is at plus bt square. Then the dimensions of b is how much? Then the dimension of b is literally how much? Yeah, come on. Hello, so ma, welcome. Come on, perfecto. Okay, Sabri. Come on, think. Good afternoon, everyone. Yeah, what the velocity of the particle is given by some expression, then the dimension of b. See, dimensional consistency, guys. So the dimensions of velocity must be the dimensions of at, and whatever you add and subtract should also be the same. So dimensions of bt square. So dimensions of velocity is length raised to 1, t raised to minus 1. I don't worry about this. I'll directly go over here. So dimension of b and dimension of t square. So that is time raised to 2. So take it on the other side. So dimensions of b will be length raised to 1, t raised to minus 1 is there, and this will become t raised to minus 2. So it will become length raised to 1, t raised to minus 3. L raised to 1, t raised to minus 3, which is obviously your D option. Yeah. D for IT Delhi, guys. Perfecto. Amazingo. Kudos to all of you. Yes, D for Capto, guys. Don't ask me how, but it is D for Capto. A for Capto, B for Capto, C for definitely Capto. Good. Moving on to the next one. Two physical quantities are there having same dimensions of m1 l raised to minus 1 t raised to minus 2. What do you think they are representing? Thrust, strain, moment of force, thrust, stress and pressure, work and thrust. So I can see the words thrust, pressure most of the time. So I would be focusing on that. Only then we can probably get it. Thrust is there, force is there, pressure is there, all these things. So m1 l1 t raised to minus 2, guys, this is negative 1, so it can't be force for sure. It can't be work also for sure, because I know work has m1 l raised to 2. So work is definitely out. Force is also out, and force and thrust have the same dimensions. So thrust is out from here. Okay, I can get it directly. So even this is out. So it has to be C option even without checking. So because I know thrust, this thrust is same like force, and force dimensional formula is m1 l1 t raised to minus 2, and I know work dimensional formula is m1 l raised to 2 t raised to minus 2. So it can't be either of the two. So automatically 3 options go off. Hence the option C should be right. So even without actually doing the question, I got it. But say for example, we had to do it, then you can say stress and pressure actually mean have the same formula. Stress, okay, stress is force per unit area, which is also pressure. So that's why dimensional formula should be the same, number one. And if you take force dimension, which is m raised to 1, L raised to 1, T raised to minus 2, divided by area, which is length raised to 2, what you will get is m raised to 1, L raised to minus 1, T raised to minus 2, which is exactly this one. Got it? Yeah, that's how you do this particular question. Very nice. So these were some of the things. Sometimes you might be also asked to derive certain expressions. Say for example, it is being told to you, say for example, it is being told to you that the thrust depends on the force and, or let's say they tell you something else only. Say for example, they tell you the the stress depends on the stress depends density on density and speed. Density and speed. Can you figure out the formula? Can you figure out the formula for the same? Okay. So imagine this kind of question comes. Options are there, but you cannot sit and verify each and every option because it is going to be extremely painful and lengthy. So instead, what you do, stress, right? What is the dimensional formula for stress? Okay. It is nothing but force per unit area. So m raised to 1, L raised to 1, T raised to minus 2 divided by area, that means L raised to 2. So it will become basically m raised to 1, L raised to minus 1, T raised to minus 2. Density, that is mass per unit volume. Mass is m raised to 1. Volume is length cube in the denominator. And speed is nothing but length per unit time. So T raised to minus 1, that's it. So these are the dimensional formulas for density and for speed and obviously for stress. Now let's assume one thing. Let's say that our stress is some constant into density raised to some value into speed raised to some other value, x and y I do not know. How do we find it out? So because this expression holds true, so therefore even the dimensional formula of stress should be equal to dimensional formula of density raised to x into dimensional formula of velocity raised to y. Dimensional formula of density, this is by consistency. LHS and RHS dimensionally should be consistent. So it will become m raised to 1, L raised to minus 1, T raised to minus 2 is equal to density, which is m raised to 1, L raised to minus 3, whole thing raised to x. Velocity, which is L raised to 1, T raised to minus 1, the whole thing raised to y. Do this. Mass is there only one single time, so raised to x. Length is there here also and here also, so minus 3x plus y. And time is there only here, so raised to minus y. And on the left hand side, we have m raised to 1, L raised to minus 1, T raised to minus 2. Now just compare the powers. For specifically mass, 1 is equal to x. For time, minus 2 is equal to minus y. Therefore, y is equal to 2. So from this, we get our final expression. So it means from here, my stress should be some constant into density raised to 1 and velocity raised to basically 2. So basically, it is nothing but C rho V square. So that is the formula. So whichever expression says some number constant into rho V square, that option you will mark it as right. Rho V square. Got it? Very good. Excellent. So this is how you use it. Moving on now to motion in a straight line, guys. Let's go to motion in a straight line. So these were the major things on which dimensional formulas or dimensional consistency or errors or measurement related questions come from that chapter. So let's do motion in a straight line. Position tells me where you are. It is expressed in meters, like coordinates, like that. Distance is the length of the path traveled. Displacement is the shortest line joining the initial point to the current location. And it is always that the distance is going to be more than or equal to the displacement which you travel. Displacement is a vector quantity. Distance is a scalar quantity. That is another thing which you should be aware of. Speed and velocity also goes like distance and displacement. So speed is a scalar, velocity is a vector. Speed is distance by time, whereas velocity is displacement by time. Most of our problems we usually deal with velocity, not speeds. Yes, the magnitude of the velocity is the speed. Keep that in mind. So if you take velocity instantaneous and if you take the modulus of it, you will definitely get speed. Remember, this is a scalar quantity. This is a scalar quantity, and velocity is a vector quantity which depends on displacement. Okay, we are talking about instantaneous values. Yeah, we are talking about instantaneous values. Yeah, we'll do that in the end. Don't worry. Instruments part we can do it in the end, not an issue. All right. Yeah. Now, velocity, displacement by time, speed, distance by time. Average velocity is total displacement by total time. Now, basically, you will see that most of the times this is how it works. One second, not this one. See, if you want instantaneous value, it will be just nothing but dr by dt. But if you want average value, it will be nothing but delta R by delta T. Delta R is nothing but your final position minus initial position, and this is nothing but the time taken. Keep in mind, this is only called as displacement. Displacement. R is your position vector. This is the rate of change of it. Same way, you can also write acceleration as instantaneous value will be dv by dt. But if you are talking about average acceleration, then it is obviously final velocity minus, or basically you can say delta v by delta t, which is nothing but final minus initial velocity upon the time taken. This quantity is called as change in the velocity. This is called as change in your velocity. Velocity. Because acceleration is dv by dt, we can also write it as derivative of position. So d by dt square of d square x. Yes. So d square x by dt square, the second derivative of position. Instead of r, I put the x. Sorry guys. So I'll put the same variable. So d square r. So second derivative of position will give me acceleration. Keep that in mind. Okay. So if you go back over here, now, whenever acceleration is constant, very important, that is called as uniform motion or uniformly accelerated motion, constant acceleration. So, this keyword is very important. So, only when acceleration is constant, then these equations of kinematics are valid. Velocity finally is initial plus acceleration into time. Displacement is ut plus half at square. V square is u square plus 2s, and displacement is average velocity multiplied by time. This is also valid. So some of you might not know this thing. Yeah, this is nothing but your average velocity. Average velocity. And one more thing, displacement in the nth second is nothing but initial velocity plus acceleration by 2 into 2n minus 1. So this equation also useful for nth second displacement problems. Okay, fair enough, guys. Now, there are graphical considerations also, which we'll talk about, specifically the slope, area, and all of it. Instead of going into it in this text format, I will give you a simple chart for you guys to remember. And the chart will make sense. So, whenever you have position, let's say x, and you want to figure out velocity, and maybe from that, you might want to figure out acceleration, which is basically a. So, to go downwards, you basically go find the slope. So, slope of position versus time graph if you want to do graphically. But derivatives wise, it is nothing but dx by dt. That gives you velocity. From velocity, if you want to go down, you find the slope of velocity versus time graph, which is dv by dt. That will give you acceleration. And if you directly want to jump from here to here, you already know the simple way is the second derivative, but there is no such second derivative formula, you have to take the derivative two times, obviously. But yes, you can also reach acceleration by another formula, and that is A is dv by dt. But the dv by dt, I can write it as dv by dx into dx by dt. This dx by dt happens to be your velocity, so it becomes v times dv by dx. So this formula is also very useful at times where you use chain rule and you are not differentiating with time, you are differentiating it with respect to x. So whenever time is not involved in the derivatives, use this formula. You can go the exact reverse way. So for example, if you want to go from velocity to position, you write x is basically um, x is basically integration of velocity with respect to time plus some constant of integration. But keep in mind, if you find the area under the graph, area under velocity versus time graph, you are not going to get x, rather you will get delta x, which is nothing but displacement, Same way, here also, if you integrate acceleration, you will get velocity. Integrate acceleration with respect to time plus some constant of integration. Yes, you are going to land up with the velocity. But if you do the definite integration, which is nothing but under area under acceleration versus time graph, that will not give you velocity, rather it will give you change in the velocity. So keep these things in mind. Yeah, is that clear? All right. Yeah, very good. I hope this is absolutely clear. Very nice. Okay. Now, uh, after this kinematic equations, I think we should just directly do some questions. Yeah, there are some standard formulas for stone which is thrown up and all of that. So, for example, if you take a projectile and you throw it up, it goes up and comes down. So, the time of flight is given by 2u by g, and this time is 2 times the time taken to go up, which is also 2 times the time taken to come down, which is the same. Also, the maximum height reached is nothing but u square by 2g. Yes, keep that in mind that at this topmost point, velocity is going to be 0. Same way, if you take a stone and you drop it from some height, it comes down and acquires some velocity. That velocity which it acquires is root 2 gh. The time which it takes to come down is nothing but a root of 2h divided by g. Okay, so these two special cases, direct formulas, it is better that you remember it. All right, let's do some questions. The distance traveled by an object in straight line with time t is given by this. The initial velocity is how much? So displacement is given, velocity is asked. What will you do? Yeah, that was helpful. That chart and graph. Okay, so glad, man. Okay, so what will you do? Just take the velocity, which is nothing but the derivative of displacement with respect to time. So the derivative of 3 is 0, minus 4 is outside. Just the derivative of t will come over here, plus 5 is going to be outside, and derivative of t square will come over here. Okay, so this will become minus 4 dt by dt is 1 plus 5 into dt square by dt is nothing but 2t. So this will become minus 4 plus 10t is velocity, but initial velocity means time should be 0. So minus 4 plus 10 multiplied by 0. So hence it will be minus 4. That will be your initial velocity, which is option D, minus 4 units. Is that okay? So D is the right answer. Perfect. No, no, not C. With the sign you have to give, do not give plus 4. Yeah, some of you missed the minus sign, I guess. So that's why C option is there for all those people who made that silly mistake. Cool. Okay, okay. Happens. All right. Let's do one more question coming up on your screen, and let me show this to you. Say, for example, it is given, V is equal to x cube. Okay, x cube. Find acceleration. How do we do this question? But the answer will be in terms of x only. Well, we know that acceleration is dv by dt, but I will not use this formula because I cannot differentiate it with time. Rather, I will use acceleration is v times dv by dx. This is a better formula because everything is in terms of x. So what is velocity? Velocity itself is x cube. Okay, what is this derivative? Okay, we'll figure it out. First, let me put the value of velocity, which was x cube. Okay, I've just substituted v as x cube in this formula. So x cube is as it is. Derivative of x cube is nothing but 3x square. That's it. So this will become 3 times of x raised to 5 is the acceleration. So that's how you can do some questions on chain rule. Got it? These are questions on chain rule. Awesome. Moving on now to the next question on your screen. A particle moves along a straight line, covers the first half distance with the speed of 3. The other half distances are covered in two equal time intervals, 4.5 and 7.5 respectively. Then the average speed of the particle is how much? So, in such kind of problems, it has covered the first half of the distance. So, you assume the first half of the distance to be x. Okay, it has covered at what speed? 3 meters per second. Let's say the time taken for this particular part, time is distance by speed. So distance is x, speed is 3. Then for the next part, the other half of the distance is covered in two equal intervals of time. So I don't know how much. So I'll just take it like this and like this. But I know this total, if this is x1 and this is x2, say for example, I take this as x1, okay, and this as x2. I know x1 plus x2 totally is nothing but x. This totally is x because this is the second half of the distance. But out of that, x1 is covered at 4.5 meters per second and x2 is covered at 7.5 meters per second. Time wise, they are equal. So this time and this time are equal. So if I have to write the equation of time for this, time will be distance by speed, and here also time will be distance divided by speed. So from this, if I take x1, which is 4.5t, which is 4.5t, and here x2, which is 7.5t as it is. If you want, you can add them and you will see that both of them will add up to give you x. So over here, we know that x is nothing but 3 times of t1. X is nothing but 3 times of t1. So if I add both of them, x1 plus x2, which is 4.5t plus 7.5t, what should I get? I should get on the left hand side x, which is nothing but 3 times of t1. So 3 times of t1 will be equal to how much? 4 plus 7 is 11. So this will become 12 times of t. So we get that from this, my t1 value is nothing but 4 times of t. That's it. So once I know this, I can find out the average speed very easily. So in order to find out the average speed of the particle, which is total distance, which is x plus x upon total time, which is t1 plus whatever, t plus t. So it will basically become 2x divided by, we just got to know that t1 is 4 times of t. So this will be nothing but 4t plus t, which is 2x divided by 6 times of t, 6 times of t, which is x divided by 3t. So x by t, how much will it be? X by t, how much will it be? If you get to know, that's it. We know that t is t1 by 4. We know that t is nothing but t1 by 4. So take 4 on the top, let 3 be here. What is x by t1? If you notice from here, x by t1 is basically nothing but the number 3. Yeah, if you want, I can just leave it as it is, x by t1. So this x by t1 is basically that number 3. So 3 cancels, the answer is 4, which is nothing but option number A. Got it, guys? Yeah, everyone? Yeah. So it is nothing but yes, 4 meters per second. So multiple ways of doing the same question, up to you how you want to do it. Yeah. Welcome. Yes. Very good, Anjali. Amazing. Yeah. Very nice. Let's move to the next question on your screen coming up. A stone is thrown vertically upwards from a bridge with an initial velocity of 5, strikes the water below it in a time of 3. Then the height of the bridge above the water surface is how much? Okay, let's draw the diagram. So a stone is thrown vertically up from a bridge. Okay, so maybe this was that particular bridge. This is that water below. Okay, and that stone is thrown from here like this upwards with what speed? 5 meters per second. So it's going to go up and it is going to fall into the water at 3 seconds. Okay. Acceleration due to gravity is downwards. Okay. So G is standard 10 meters per second square given to me. Question is, how much is this height? So this was the initial location. This was the final location. So the displacement which is happening is downwards. So I can say H displacement is happening downwards. So this is the displacement. This is nothing but your displacement, which is happening downwards, guys. Okay, from initial to final. So best thing to do is using second kinematic equation, which is nothing but S is ut plus half at square. Displacement is negative h. Initial velocity is positive. Time taken is 3. Acceleration is downward, so negative, so minus 10. Time taken is 3, so 3 square. So this will become 15 minus 10 by 2 is 5. 3 square is 9. So it will become 15 minus 9 5 is 45. So it will become minus 30, which is minus h. So h will become 30 meters. So 30 meters means, yeah, option number C is the right answer. Okay. A lot of people are now going to, question or maybe were thinking before, but sir, why did I do it directly? Can't I just first find this much height, then take this much time, and then subtract the two? Yeah, you can do that, but it will be lengthy. The purpose of showing you this is that throughout the motion, acceleration was constant. So there is nobody who can stop me from using kinematic equation. It is not like for upward and downward motion, accelerations changed. It's the same. So as long as that happens, you can continuously use kinematic equations. Nobody can stop you. But be careful about the signs. Upwards have taken positive, downwards have taken negative. So displacement was actually negative. Yeah, got it? Very nice. Very nice. Amazing. Amazing. Moving on now to the next question coming up on your screen, but that is on motion in a plane. Here it is. Okay, motion in a plane. Guys, let's do some questions. But before that, some quick revision of theory. Whenever you have a vector, it's resolved into two components, and that is useful for motion in a 2D because motion in a plane or motion in a 2D, the object's x coordinate and even the y coordinate will change. So the velocity, accelerations might be in some weird direction. So it is usually split into x separately and y separately and solved also usually separately. X, whatever happens, will be because of x acceleration. Y, whatever happens, will be because of y force, y acceleration, y velocity, everything. So deal with them differently. But if you want to find the total quantity, it is the x component square plus y component square. If z is there, plus z square, the whole thing under the root. Okay. I cap, j cap, k cap, standard, everything's you know. If you combine both the components, you will get the resultant. Okay, standard things. Vector subtraction is basically vector addition, but with a negative vector, as simple as that. So when you want to add vectors, so you have vector A and you have vector B, and then you can just say, okay, the resultant is given by this particular vector by triangle law. But whenever you want to add a negative vector, say for example, A minus B. So if A vector was like this, negative B vector will be like this, and then this would be the resultant. So this will be your A vector minus B vector. This was A plus B vector. Okay. Now, when do you need vector addition versus when do you need vector subtraction? Vector addition you need when you need to find the net force, when you need to find the net field, or when you need to find the net, momentum, because whatever. So, whenever vectors are being combined together, that's when you will see vector addition. When will you see vector subtraction? Like displacement, which is final minus initial, change in velocity, final minus initial. Usually during the change in any quantity, you will see vector subtraction. You want to find the combined net quantity, or okay, then you will see vector addition. That's what the general rule is. Even during relative velocity, you are going to see vector subtraction. All right. Now, same thing what you learned in 1D is also applicable over here. So average velocity, average acceleration, all right, all the same definitions are still valid over here. Just that you put a bar because things are now happening in 2 dimensions. So let's have a look at some questions so that we get an idea of it. By the way, kinematic equations are still valid. Okay. Kinematics are still valid even in 2D. Kinematics kinematics are valid only if the net acceleration is a constant. Keep that in mind. If it is not, then you cannot use kinematics. You have to use derivatives. Okay. Okay. Great. Great. Oh, Quaro, if you've practiced these kind of models and if you go through the theory revision, then I'm pretty sure 45 is not even a target. It should be much higher than that. All right. Let's have a look at the question coming up on your screen. If a body is moving with some velocity towards east, after 10 seconds, its velocity becomes 40 meters per second towards the north, then the average acceleration of the body is how much? Think about it. Come on, guys, don't discuss a Ronaldo or Messi fan. Now is not the day. Today is the day where you solve questions. Okay? Yeah, let's do. A body is moving with some velocity towards the east. After 10 moves towards the north, find the average acceleration. So if I take east direction as I cap, then the north direction will be, let's say, j cap. So then my average acceleration by definition is change in the velocity, final minus initial, divided by the time taken, right? Now, what is final velocity? You are moving with 40 towards the north, so it will be 40 times of j cap. What is initial velocity? Initial velocity is 30, but towards the east direction, right? So 30 basically I cap. How much time you took? 10 seconds. So put 10 over here. So 4 j cap and 3 I cap will come. So negative 3 I cap plus 4 j cap. That's your acceleration in meters per second square. But might be the magnitude is asked. So if the magnitude of that average acceleration is asked, so then it will be nothing but root of minus 3 square plus 4 square. So that is nothing but 9 plus 16, which is 25. Root of 25 is 5. So 5 meters per second square. So that is the answer. Plain and simple. Yeah, cool. Let's go do the next question. This was asked during the COVID era. So you have a particle which starts from the origin with an initial velocity of 3 I cap from the origin and moves in the xy plane with a constant acceleration. The x coordinate of the particle at the instant when its y coordinate is 32 meters is how many meters? Interesting question. How much is the x coordinate when the y coordinate is so and so? So I think first we need to figure out when is actually y coordinate 32. Then we can use the time for finding the x coordinate. So let's focus only on the y coordinate first. So we have to find y coordinate is 32 meters. So y acceleration is 4 j cap. Initial velocity is 3 I cap. So as you can see, there is no velocity in the j cap direction. So actually speaking, in y direction, initial velocity is 0, acceleration is 4, displacement is 32. So we can use Sy is uyt plus half ayt square. Second kinematic equations in y direction. Displacement is 32, so put 32. Initial velocity is 0, acceleration 4, time I do not. So 4 by 2 is 2. 2 goes over here. So this will become 16 is t square. So time will be 4 seconds. Once I get that, let's focus only on x. Question is finding the x coordinate. Initial velocity is there. So if you look at it in x direction, initial velocity in x direction is 3. Acceleration in the x direction is 6. And time is given. So the displacement will be uxt plus half axt square. Initial velocity 3, time taken 4 plus acceleration is 6 multiplied by t square, which is 4 square. So 3 fours are basically 12. 6 by 2 is 3, 4 square is 16, 48 and 12 guys, how much is the answer going to be? Yes, it is going to be 60 meters. So 60 meters is option A, which is absolutely right. Option A. Very nice. Yes, they were entire 11th and 12th. Perfecto. Amazing, 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 amazing. Keep it up, keep it up. Very good. Okay. Let's go to the next set of questions. So these kind of questions, guys, that's what I said. You can use all the knowledge of vectors, whether it is addition, subtraction, or components and resolution. And also the same things what you learned in 1D are applicable in 2D. Kinematics are also applicable. Okay. As long as acceleration is constant. So it's nothing different that you need to deal with. Yes, motion under projectile. So you throw a body with some velocity, it goes like this, falls with the same speed over here. All right, making this angle. Okay, so this is your range, this is your maximum height. At the topmost point, the speed is not zero, it is u cos theta. Yeah, and in such motions, you will see the horizontal motion which is there will be uniform motion. Yeah, there is no acceleration, no acceleration. Therefore, velocity will be constant in x direction. Therefore, velocity will be constant in x direction. But in vertical motion, there is acceleration. Acceleration is there. Therefore, velocity in the y direction is not going to be a constant. You will see y velocity will keep changing, x velocity will remain the same. So this x velocity, no matter where you go, even at the topmost point, even over here, will be the same. It's the y component which keeps changing. Like you can see over here, it is too much. Here it will become less. Here it will become 0. Here it will become downwards. Here it will become even more downwards. So that's what it means. So in horizontal motion, you can say x coordinate is u cos theta, horizontal speed into time, whereas in y direction, use ut plus half at square. U is u sine theta and acceleration is negative g. So that's why this expressions work as like you should use kinematic equations. But just that here no acceleration, here acceleration is negative g. Keep that in mind. From that you get your height, range and equation of trajectory formulas. Height is u square sine square theta by 2g. Time of flight is 2u sine theta by g. Range is u square sine 2 theta by g. And you should know the trajectory equation. That means how will the y coordinate and x coordinate be related, which is x tan theta minus gx square by 2u square cos square theta. Couple of things over here. This is also 2 times the time taken to just go up, which is also 2 times the time taken to go down. Second thing, the time of flight is maximum when theta is 90 degree. This height is also maximum when theta is 90 degree. That means you throw it vertically up. This range is maximum when theta is 45 degree. Also keep in mind, for complementary angles, for complementary angles, the range is same, like 30 degrees, 60 degrees, 37 degrees, 53 degrees, 20 degrees, 70 degrees. The range value will be the same. Okay. Here you use sine to theta, but you can also rewrite it as, 2 times u square sine theta cos theta by using double angle formula, whole thing divided by g. This equation of trajectory also you can rewrite it in different ways. Like this one is the first way, x tan theta minus gx square by 2u square cos square theta, which is also x tan theta and 1 minus x divided by this range. You can put it over here. You can clearly see, because this is a quadratic equation, the graph, the path will be a parabola. Yeah, because there is a square term over here. Yeah, keep that in mind. Yes, perfect. So having said that, let's solve some questions based on this. If the velocity at the maximum height of a projectile projected at some angle 45 degrees is 20, then the maximum height reached by the projectile is how much? Let's see. Come on. Yashwa, what else do you want me to do during the revision phase? Tell me. Come on. The break will come at around 4 o'clock. not before that. 3 hours first will be continuous. So around 4 o'clock, we'll have a break, first break. We'll try to complete mechanics as much as possible. And then after the break, we'll try to take up thermal fluids, waves, all of that, gravitation. Okay. The velocity at the maximum height is 20. We know that means the value of u cos theta is given to me as 20 and cos of basically 45. Cos 45 is 1 by root 2. So therefore u is 20 times of root. Yeah. So u is 20 root 2. Maximum height reached by the projectile. Maximum height formula, guys, is u square sine square theta divided by 2g. So u is 20 root 2 square it. Sine theta means sine 45 divided by 2 multiplied by 10. So 20 square is 400, root 2 square is 2, sine 45 is 1 by root 2, and 2 tens are nothing but 20. So yeah, that's what you should get. Check it out. How much is the rough answer? 400 by 20 is 20. So 20 into 20 into 2 into root 2. Sorry, 2 divided by root 2, it will become 20 root 2. So answer should be 20 root 2 meters. But I think root 2 was missing in most of the options. So I'll just add maybe root 2 over here. Okay. Then option B will be correct. Okay. Only then. Oh, sorry. I forgot one thing, guys. It was sine square 45. I'm so sorry. This was so sorry. What did I do over here? Let me just correct it. This was sine square 45. The sine square was there. I missed that. So then this will also not be there. Yeah. So sine square 45. So sine square 45 means 1 by 2. Okay. Then 2 cancels 40 and 20. Yes. So that will become 20 meters. So the answer should be B. Yes. B option is the right answer. Perfect. Yes. Oh, awesome. 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 Shall we go to the next one on your screen? Here it comes. If the height of a projectile at a time of 2 seconds from the beginning of the motion is 60 meters, then the time of flight of the entire projectile is how much? The height of the projectile means what? Basically, you have thrown it and it is going like this, but they have told after 2 seconds it has reached somewhere here. It's not necessarily maximum height and it is 60 meters, and this is at t is equal to 2 seconds. It's still going up. Okay, it might not be the maximum height. So best way to solve this part is consider y displacement, which is uy into t plus half ay t square. Displacement is 60. Uy I do not know. Time is 2 plus acceleration is negative 10 and 2 square. So this will become 2 times of uy minus 2 cancels. So minus 20. So 2 times of uy will be 20 plus 60, which is 80. So therefore uy will be nothing but 40 meters per second. Once I get uy, we can figure out what's the time of flight. Remember, it was 2u sine theta by g. What actually is u sine theta? It is nothing but initial velocity in the y direction, because u cos is ux, uy is u sine theta. So 2 divided by g, which is 10. Uy is nothing but 40. 0, 0 cancels. 2 4s are 8. So 8 seconds should be the correct answer. Perfect. This is the right answer. Got it, guys? Simple? Yeah. Very nice. Very nice. Proud of you. Ramana, Harni, Ritik. Yes, sir. Yes, Aditya, Mr. Nobody we squared it. Very good, Kalyani. Awesome, awesome, awesome. Let's go to the next question on your screen, and here it comes. Projectile is fired at 30 degrees to the ground, and it is observed to be at the same height when the time is 3 seconds also and 5 seconds also. The speed of the projectile is how much? Very interesting question. The speed of the projectile is how much? So let's visualize it. You are throwing it at some angle of 30 degrees from the ground, and it goes up like this and comes down over here, and it is at the same height, let's say this height and maybe this height, at 3 seconds also and 5 seconds also. So the speed is asked of projection. I'll tell you one thing. If it is at the same height at 3 seconds and 5 seconds, it will be at the maximum height at the exact midway time. So that will be between 3 and 5, it will be 4 seconds. So if this is 4 seconds, this will be further 4 seconds. So this will be 8 seconds, which is the total time of flight. My job is done now. My total time of flight is 2u sine theta divided by g. Time of flight is 8. Initial speed I do not know. Sine of 30 will come and g is basically 10. So this will become 8 multiplied by 10 divided by 2. U is u only. Sine theta is half. Okay, half cancels. So u will be basically 80 meters per second. So 80 meters per second is the right answer. So the logic used was the motion is symmetric. What happens while going up and going down will be the same. So if it is at the same height at 3 and 5, somewhere exactly in the middle, it will be, at the maximum height. Makes sense? Because this and this midpoint is here, maximum height. This and this midpoint, it will be at maximum height. This and this midpoint, it will be at maximum height. So motion has to be symmetric. So you go midway, that's maximum height. So that is half the total time. So total time will be double of it, which will be 8 seconds. Got it? So this logic was very, very crucial, guys. Very good. Let's go to the next question on your screen. There is a body of mass m which is thrown horizontally with some velocity from the top of a tower of height h, touches the ground at a distance of 100 meters. And then what happens is there is another body which is thrown with half the speed, but from a tower of 4h, then where will it land? That's the question. Now, for such type of questions, see, whenever you have a hill and you throw a body like this and it goes down over here and falls here, this is the range, this is the height, this is the speed. The time of flight is just root of 2h by g. The range is that horizontal speed u multiplied by that time of flight, which means u into root of 2h by g. That's the range. Now, if you notice, mass has no significance here. Whether mass is double, triple, doesn't matter because g is going to be the same. So ignore that mass. It's Shumma given to confuse you. So now what you will do is just go to the next part where the speed is half, height is 4h. So the new range will be speed is half, so u by 2. Range is 4h, so 2 into 4h rather. So 2 multiplied by 4h divided by j. So this will become u divided by 2. Root of 4 is 2. So into root of 2h by g. 2 to cancel. So it will become u into root of 2h by g. But this is exactly the same. That means the new range is same as the old range. So the old range was 100. So this will be also 100 meters. So answer for this question is obviously going to be 100 meters. Yeah, it is not going to change in this particular case by coincidence, not like every time, because of the values which we have chosen over here. Okay, this was a JEE mains question. Yeah, very good. So these are the kind of formula applications which you will need in projectile motion. In relative motion, which is there in 1D, 2D, the main concept is that anytime you want to look at it from others' perspective, you consider relative motion. Specifically, say for example, rain is falling. You are in a moving bus or a car or you are running. So from your perspective, the rain will fall at a different angle. Or let's say you are in water swimming. So for you, you might not realize that the water is moving, but for an outside observer, that person knows that the water is flowing. So your speed will be added to the river's speed to find out the resultant velocity. Similarly, maybe you are in a car, somebody is in a bike, and they both are moving in different directions. So, for an outside observer, the car and bike might be moving at some angle, some degrees, some speed. But for the car, the bike might appear to be moving at a different speed. For the bike, the car might be moving at a different velocity. So, these considerations require you the concept of relative motion. When will the two objects meet? When will this guy catch the other guy? When will the police car reach the thief's car? When will this bus and car meet? Or when will the bird flying over the train cross the train? All these problems are based on relative motion. So, main thing is whenever you have to find relative velocity of A with respect to B, then it is velocity of A minus velocity of B. Minus velocity of B. When I say velocity of A with respect to B, understand In such scenarios, A is being observed, and B is nothing but the observer, is nothing but the observer. Also, this quantity is negative of VBA, which makes sense. So if I see A moving with respect to me like this, for A, B will appear to move exactly opposite. So that's why the negative sign. Magnitude wise same, but direction wise, relatively, they will be moving in the opposite direction. Even in these things, you can also use kinematic equations. Kinematic equations are still valid, but only if the relative acceleration should be constant. That's the only condition which has to be met. Other than that, everything is valid. Okay, so velocity, even for acceleration, you can use this equation, guys. For example, acceleration of A with respect to B will be acceleration of A minus acceleration of B, which is negative of acceleration of B with respect to A. Same thing even for displacement. SAB will be SA minus SB, and it will be negative of SBA. But do not use this for force, momentum, and all of that. This is not valid. This is only valid for displacement, velocity, and acceleration. Never, there is no such term as relative force or relative torque. No, don't use it. Only for these three quantities. All right. So let's see some questions based on that. If there is a bird which is flying north with a velocity of 40 and train is moving with a velocity of 40 towards east, what is the velocity of the bird noted by the man in the train? Interesting. So bird is flying north, so velocity of the bird, north means j cap, I will write it as 40 j cap. Train is moving with a velocity of 40 towards east, so velocity of the train is 40 I cap. What is the velocity of the bird by the man, or basically by the train? Okay, so velocity of the bird with respect to the person in the train is VBT. So by definition, VBT should be first, well, alphabet is B, so VB. Next alphabet is train, so VT. VB minus VT. So VB is nothing but 40 J cap. VT is nothing but 40 I cap. Usually put I cap first, so minus 40 I cap plus 40 J cap. So if you see it vectorially, minus 40 I cap means like this, plus 40 J cap means like this. So my resultant vector will be like this. So this will be velocity of bird with respect to the train. Now obviously this is the north direction, this is your west direction. So it's in the northwest direction. Is that right? It is in the northwest direction, as you can see over here. Is that clear, everyone? But what about the magnitude? We can just take the modulus. So VBT mod magnitude will be 40 square plus 40 square, which is 40 root 2, which is also right over here. So option C will be the right answer. So such questions can come directly where you have to find the relative velocity. Option C. Yeah. Okay. Very good. Very good. Let's go to the next question. Guys, don't worry about you solving it right now, because if I wait for that, then this will not be 11-hour marathon. This will be 40-hour marathon. Okay. But obviously, I cannot do that. So that's why I will be doing the problems. That's why I said, please focus on the class. You can keep a rough sheet. You can try solving as I solve, uh, at least the main points, but I'm not expecting you to get the final answer. If you get it, I will be very happy. But if you don't get it, still don't worry. Okay, because we have to complete all the chapters, try to solve as many questions, try to cover as many concepts in this marathon. Okay, because this is the best marathon that you can get on the internet. Good to go. All right. Moving on. Next question on your screen. A car is traveling with a speed of 40. Raindrops are falling at a constant speed vertically. Traces of the rain on the side of the window can make an angle of 30 degree. The magnitude of the velocity of the rain. Okay. So let's understand this. Rain is falling vertically down. So velocity of the rain is like this. A car is traveling at a speed of 40. So this is the velocity of the car, which is, let's say, 40. when the rain falls, it makes an angle of 30 degrees on the window. That is the relative velocity basically, because how the car will perceive the rain, accordingly only the rain's angles will be made. Okay. So if I want to find the velocity of the rain with respect to the car, by definition, it will be VR minus VC. Is this something which I remember? No. I just know that relative velocity concept, which I just told you right over here. Where did it go? Yeah. VAB will be VA minus VB. So I'm just thinking relative motion, if I have to consider, it will be obviously of the rain with respect to the car. So VR minus VC. So VR is there, VC is there. So negative VC I will need. So VR vector will be like this. Negative VC vector will be like this. This will be negative VC vector. Magnitude wise, it is still going to be 40 only, no doubt. But the resultant will be like this. This will be your velocity of rain with respect to car, and it is making an angle of 30 degrees with the vertical. That means this angle is 30 degrees. Perfect. Question is find the velocity of the rain. It's a pure geometrical problem. Opposite side, this is adjacent side, you have to find VR. So guys, tan 30 I believe. So tan 30 will be opposite side, which is 40, divided by adjacent side, which is VR. Tan 30 is 1 by root 3. So therefore, if I write VR, 40 will be there on the top, root 3 will go on the top. So 40 root 3. So 40 root 3, which is option A, is the right answer. Okay. Not, no, this is wrong. They have not marked the answer correctly. This should be the correct answer. But this is VR. Over here, what have they asked? The magnitude of the velocity of the rain. But with respect to the car, they have asked. Okay, they have asked what is VRC. So if they ask VRC, then the answer will be maybe 80. We'll see. So if VRC is asked, this is adjacent side. This is your hypotenuse. So we can use the ratio of basically cos value. Yeah, you can use cos value, right? So, or you can use sine value also if you already knew VC. So if you use sine value, which is sine 30, which is opposite side by your hypotenuse, which is VRC. Sine 30 is half. So this will be 40 divided by VRC. So VRC will be 40 and the 2 comes on the top, which will make it 80. So since they have asked magnitude of the velocity of the rain with respect to the car, so that's why the answer will be option C. If they had asked directly VR, then the answer will be 40 root 3. Is that okay? Very good. So it's basically a pure trigonometric problem. You just have to use either sine, cos or tan depending on your convenience. Okay, it's not like you have to remember some specific formula for Rainman problems. There is no formula for Rainman problems. Let me be very, very clear. Okay, it is just you need to always use relative velocity of the rain with respect to the person or relative to the car, bus, whatever it is. Next, there is a river which is flowing from west to east and the direction is the speed is 9. If a boat is capable of moving at maximum speed of 27 and it is in still water and it crosses the river in half a minute while moving with maximum speed at an angle of 150 degrees, then the width of the river is. So a lot of things are there. So let's try to analyze this situation. So first we have this river. Okay. Then you are moving at 150 degrees with respect to the river flow, meaning what happens is you are going like this. The river is trying to pull you like this. So your velocity is like this, river velocity is like this. So resultant velocity will be like this. But I do not know whether it is shortest distance or not. So right now I will not do anything. I'll just not even write anything as such. I'll just make sure only my this velocity is written. And it is mentioned that the boat is capable of moving or at 27 in still water. This 27 in still water means what? Forgetting the river's velocity. If you just look at the person inside that still water, then the speed is 27. But if the river moves, an additional river velocity will be added. So right now, this particular vector lengthwise is 27 and 150 degrees from the flow. That means this is 150 degrees because the flow is in this direction. This is the direction of the flow. Now this is 150 degrees. It's quite obvious that this is 30 degrees. So now this has two components, right? So one component is like this. The other component is like this. So this is 27 cos 30, which is 27 by 2 into root 3. This is 27 sine 30, which is basically 27 by 2. Okay, everyone till this point absolutely clear? These are the two components of the velocities. Now what will we do? Now what will we do, guys? Yeah. Okay, come on, think. This reverse velocity is given and also the time taken to cross is given. The person crosses the river in half a minute. See, even if the river is moving like this at 9 kilometers per hour, how will it affect how much time I will take to cross? Because for crossing, only this velocity is helping me reach the other side. It is not literally this component or even this component which is helping me. This is making me move left and right, but not really cross the river. So this is the speed which is of importance. The width of the river is not known. So I can say, just like distance is speed into time, the width of the river is the vertical velocity multiplied by the time taken to cross. Distance is speed into time. Vertical velocity is only 27 by 2. Time taken to cross in half a minute. Half a minute means basically 30 seconds. So just put 30 seconds over here. So guys, 27 multiplied by 3, that's 81 divided by 2, and this is 810 divided by 2. Is that right? Everyone, till this point, absolutely clear? So what is the final answer then? What is the final answer? Oh, but there is a catch. But there is a catch. This was in kilometers per hour. This was in kilometers per hour. So we need to convert it into meters per second. So I need to multiply it by 5 by 18. So I'll multiply by 5 and also divide it by 18. Is that fine now? That makes more sense because obviously meters per second has to be converted into, kilometers per hour has to be converted into meters per second. So do the math and tell me what is the final answer that you are getting. Come on. Yes, option A, 112.5. 112.5. Many people are saying option A. Let's find out. Yes, it is absolutely right, guys. Yeah. Yes. Amazing. Amazing. Radha Radhe, this is entire physics, no? I hope you saw the title, the thumbnail. This is entire physics, class 11th and 12th, both of them together. So this is entire physics. This is not only 12th standard. Okay? Yes, amazing. Very good, Dhar. So if drift was asked, then what will you do? If, for example, drift was asked in such a question, then what will you do? Then keep in mind the drift will be the horizontal velocity multiplied by the time taken to cross. Now be careful, the horizontal velocity is neither this, neither 9. 9 is taking you forward, 27 by 2 root 3 is taking you backwards. So the difference of the two is the real horizontal speed because this component is taking you backwards like this. So 27 root 3 by 2 minus 9 is the real horizontal speed. Time taken to cross is 30, obviously converting it into meters per second. So multiplied by 5 by 18. That's how you can find out the drift. Got it? Yeah. Awesome. Next, let's go to laws of motion. Okay, welcome. Even if you are new to the channel, but I hope you read the title. That's mentioned clearly. Complete physics. And I want the Josh to be high, guys. Come on. Yeah. Keep up the Josh, keep up the energy. Yeah. Everyone. Perfecto capto. Yes, Sabri. Welcome, everyone. Yeah, join in. And if you've forgotten to smash the like button, please do that right away, right? Okay. I hope this revision it's helping you. I hope this revision is making you recollect those forgotten days. I hope this revision will also help you for the mock tests. By the way, on this channel only, we'll be taking up 11th standard mock test part test in the next few days, then only 12th standard syllabus and then the combined syllabus. Are you ready for that also? Yeah. Are you ready for that? Let me know. Very good. Okay. Laws of motion. If you think about it casually, then it is very simple, just three laws, but the applications are vast. So the first law is all about, inertia, where if something is at rest or something is moving, it keeps moving or stays at rest unless it is disturbed by some kind of an unbalanced force. So the first law actually defines what inertia is and also defines what balance versus unbalance is. A balanced force is where all the forces vector sum is zero. Unbalanced is where all the forces vector sum is not zero. As simple as that. So this is what the definition is. Net force is not zero, meaning unbalanced, whereas net force cancels out and becomes zero. It is said to be balanced force. So as long as the net force is zero, the object maintains its state of rest or of uniform motion. Okay, so that's what it says. So it also defines something called as a inertial frame, then inertial frame or inertial body. An inertial body, an inertial body is such a body who's not experiencing any force. So if you have an inertial body, you will see whatever forces are there on it, whatever forces are there on it, they will cancel out. Yeah, all the forces will cancel out. It will be balanced. So such a body will always appear to move with constant velocity and will have no acceleration. No acceleration. It will not have any acceleration. Now on such a body, if you take if you take your observer and you call that as your frame of reference, xyz axis, so this is your then called inertial frame of reference, inertial frame of reference. And in such inertial frame of references, you will see that your Newton's laws are valid. Example of inertial frame of reference: Earth. Earth is approximately an inertial frame, or a tree, because it is on the earth, it is an inertial frame, or basically a car with constant speed. A car with constant speed is also an inertial frame. Non-inertial frames are those which are accelerated bodies, like an accelerated lift, an accelerated car, a train which is braking. All these are non-inertial bodies, and the observers then will call themselves as non-inertial frames. Frame is basically a point of view. It's a hypothetical quantity, a hypothetical thing. It's a point of view of seeing things. Yeah, makes sense, everyone? Very good. A bus also, yeah, correct. Now, what happens when the forces are not balanced? That is given by your Newton's second law, which is the net force acting on the body is mass into acceleration. Actually, this is the end result. The real law happens to be the net unbalanced force. Okay, the net unbalanced force is just the rate of change of momentum. And when you write momentum as mass into velocity, you will get m into dv by dt over here plus v into dm v into dm by dt. Now, it so happens that most of the times this rate of change of mass is not there. So that's why you will get only m dv by dt, which is ma. So usually that is our equation, which is mass is constant. But if mass is changing, then you need to consider v dm by dt, which is that additional term which you get because of variable mass. But that is very rare and very laddu questions come on it. It's not like you will get rocket science questions on it. Okay. So don't worry and stress so much. All right. Also, having said that, if the force is at an angle or the force is in some weird direction, keep in mind you can split the force into three quantities: x, y, and z. The x force will give x acceleration, y force will give y acceleration, z force will give z acceleration. A simple example of that is when you throw a body due to the gravitational pull, the gravitational force is down, so the acceleration is also down. Because there is no force horizontally, there is no acceleration also horizontally. So, that is a very simple example of how they all mind their own business. So, whatever force is in x will affect only x, it will not affect anything in Y or Z. The same thing is true for others. Yeah. Okay. Then comes the third law, which is all about action and reaction, which talks about, if you apply a force on a body, the body also applies a force on you, but they are not acting on the same body. Like you are applying on the body is applying on you. So that's why they do not cancel each other. You can call any one of them action, the other one automatically becomes a reaction. So basically, forces always exist in pairs, action and reaction, which are equal and opposite, but do not cancel each other. So that's your Newton's third law. So lastly, you have some standard problems which you can get. One is this question where you have one mass here. There is this thing like this, and this is m2. This will go down. This will go up. How much is the acceleration? Okay, how much is this acceleration? Acceleration is bigger mass, let's say it is m2, minus the smaller mass by the total mass, which is m1 plus m2 into g. The tension in the string is given by 2 times m1 m2 divided by m1 plus m2 into g. Lastly, there is a reaction over here. See guys, this rope will have tension in itself, but over here there will be a reaction from the top, and that reaction force is 2 times of this tension. So sometimes question might be asked on that. Next, this system where you might have just one block over here, it is connected over a pulley to another block like this. Let's say this is m2, let's say this is m1, this will go here, this will go down like this. So this acceleration is just this weight divided by the total mass. That's all. And the tension is nothing but just m1, m2, exactly half of this, g divided by m1 plus m. The next system which you need to remember is a simple thing where you have a block and this is theta and it goes down. So the acceleration is simply g sine theta if it is smooth, but if it is rough, it is g sine theta minus mu cos theta if it is rough. Okay, keep this in mind. So this is the formulas which you will most often use in many of the problems. Okay, keep these things in mind. Next, frictional force, weight force, all these forces we'll just quickly discuss. Yeah, weight force will always act down. Okay, and this weight is mass times g. Spring force, spring force is basically your elastic force, and that spring force magnitude wise, only be interested in the magnitude, is k into x. K is called as the spring constant. Direction is very obvious. If you pull it, it will try to pull you back. If you compress it, it will try to push you away from it. It's simple. So remember the magnitude. Direction, you can show it on the force body diagram, FBD, or on the object itself. So don't stress so much on the direction. Direction itself is very obvious. Then you also have, after spring force and weight, you have the normal force. The normal force, which is always perpendicular to the contact surface, So if you have something kept on a surface, it could be even at an angle, doesn't really matter. So just the perpendicular, that's where the normal is. Friction will always try to oppose the motion. So if this particular body is going like this is the direction of the motion, then the frictional force will always try to oppose it. And the combination of these two, the combination of normal and friction, that is called as the contact force. That is called as the contact force, which is the simple vector combination of the normal force and the frictional force. As simple as it. The simple combination of normal force and the frictional force. Okay, keep that in mind. All right. Frictional force. There are of two types, static friction and kinetic friction. Static friction will act when the two surfaces are not sliding, but they have a tendency to slide. So the static friction will always oppose the tendency. There is a limit till which it can increase, and that limit is called Fs max. After you reach the adjustment which is maximum possible, which is Fs max, then the surfaces begin to slide and the friction becomes kinetic in nature, and that kinetic friction is constant, and it is called Fk. So in fact, there is also a simple graph for it, which looks like this, how the friction changes. It increases till a limit. After that, it drops down suddenly like this. After that, it drops down suddenly like this. This is basically your Fk, kinetic. This is your maximum limiting friction. And this Fs max is coefficient of friction into normal reaction, and kinetic friction is coefficient of friction again into normal reaction, but this is mu s, this is mu k. Coefficient of static. Have a surface and you place an object. So the angle after which the body begins to slide down is called as the angle of repose. So if theta is more than alpha, it is going to slide, and if theta is less than or equal to alpha, it stays, and this angle of repose, which is basically alpha, so that tan of alpha is going to be given by mu s. So this formula also you should definitely remember. Okay. Lastly, you have pseudo force. Pseudo force. This is only in non-inertial frames. Only in non-inertial frames. So say for example, we have a frame of reference like this, and that frame of reference itself is accelerating maybe in this direction like this. Okay. Then imagine there is an observer in this frame. It could be lift, it could be a bus, it could be an accelerating car, it could be a braking train, whatever. And that observer is looking at some body. Yeah, there are those regular forces, whatever you will still show, no doubt about it. But apart from that, you will show one additional force this time, and that is pseudo force, that will always act opposite to the direction of the acceleration. So wherever the acceleration is exactly opposite to that, your pseudo force will come, whose value will be given by, let's say this mass of the body is m. So it will be nothing but the mass of the body multiplied by the acceleration of the observer. So that completes your free body diagram. Okay, force body diagram or FBD. So one additional force, pseudo force, always acts opposite to the observer acceleration, not the body's acceleration. After this, the body might individually have its own acceleration, whatever this is A. So then you will say your regular forces, F1, F2, like that, whatever regular forces were there, Fn, plus that extra pseudo force, Fp, that will be equal to mass multiplied by the acceleration. That's the only difference. Only then Newton's laws are valid. So this correction needs to be done, because remember in first law I told you, otherwise Newton's laws are only valid in inertial frames. So to make it valid in a non-inertial frame, which is an accelerated frame, you need to account for the pseudo forces. All right. So best use cases is of the lift. So in the lift, which is going up, the apparent weight or the normal force will be m into g plus a, whereas the same lift which is accelerating down, the apparent weight will be m into g minus a. So many questions will be there on that as well. Okay, cool. So let's do some questions. Here is the first one coming up on your screen. Come on, guys. Yeah. Let's see if you guys can do this. Tell me the answer quickly. Just drink some water. Yeah. What do you think, guys? A block of mass, yeah, horizontal coefficient of friction, horizontal force is acting, then the acceleration of the block is. So the force is of 60. The frictional force will be opposite, and it will be nothing but mu into normal. Mu is given to be 0.5. Normal force will be the weight, which is 5 times of g. So g is 10, so it will become 5. 5 5 is a 25 Newton. So therefore, 60 minus 25, which will be the net force, will be the mass, which is 5 into acceleration. So what I have done over here is this is net force. It is equal to m into a. That's all. So that's it. You will get the answer. 60 minus 25 is 35 is 5a. So a will be nothing but 7. So 7 should be the answer. Yes. There you go. Perfect. Amazing. Uh, Screw gauge and micrometer. Yeah, one question at max might come, but there is no guarantee it will come. But yeah, if it comes, one question maximum. Okay, not more than that. Let's do the next one. There's a block of metal, 4 kilo. It is at rest on a smooth surface. It was targeted by a jet releasing water at 2 kgs per second at a speed of 10. Then the acceleration of the block is how much? So I'll tell you what, the force because of that jet, which is also called as the thrust force, you can now use the term V into dm by dt. This is the concept over here. V into dm by dt. Yeah, V into dm by dt. Amazing, amazing. V into dm by dt. So what is the velocity of the body? What is the velocity of the body? It is basically 10. dm by dt is how much mass is being thrown per unit time, which is nothing but 2. So that is nothing but 20 Newton. That is nothing but 20 Newton. Is that okay, everyone? So this is that concept which you have to use in these variable mass problems. I told you, remember sometime back, there will be some questions where the mass will continuously change. So this is one such question. So this thrust force is falling on that box or body, and therefore, because of this particular force, there will be some kind of acceleration. So just use mass into acceleration is force. Mass is 4. Acceleration is how much? So it will be basically 5. So answer is option D, which is 5 meters per second square. Very simple and straightforward. Okay, so such questions may come in your exam. Moving on to the next one. There is a mass which is suspended by a rope from a rigid support at point A, and another rope is tied at end B and it is pulled horizontally with that force F. If the rope AB makes an angle theta with the vertical in equilibrium, then the tension in the string AB is how much? Then the tension in the string AB is literally how much? Okay, come on. Now, in such type of questions, always focus on the joint. And remember that joint is a massless term, so the joint will never experience any net force. So the net force on the joint will be zero. That is the fundamental concept in all these rope problems. So now what happens is, over here, this force is here, this weight is here. Question is, how much is the tension here? Show the FBD or force body diagram. How much there is a tension here. There will be a weight which is nothing but M into G acting here. This force is anyways present. Now this tension can be split into two components. One component like this and one component like this. This is theta, so this is theta. So this will be T cos theta. This will be nothing but T sine of theta. Because all the forces should balance, I should say, in the horizontal direction, T sine theta will be F. Next is T cos theta will be mg. Now, if you divide both of them, what you will get? If you divide both of them, what will you get? Yes, T will get cancelled. So you will get sine theta by cos theta. And here F divided by mg. So you will get tan theta is basically F by mg. So you can find out the force, which will be nothing but mg into tan theta. This is one thing. But they have asked what is the tension. So tension you can use it here only. So guys, just use this equation. So tension into sine theta is F. F is nothing but mg. What is it? Tan theta. Mg tan theta. So tension will be sine theta will cancel. So mg divided by cos theta. So that is one way of writing it. But since if you look at the options, it's everything written down in terms of F. Everything is written down in terms of F. So we have no other choice but just put T sine theta is nothing but F. Therefore, T is nothing but F divided by sine theta. So technically speaking, we didn't have to do all these things, but I just showed you because sometimes they might ask, what is the force F? This is how you'll find it. What is tan theta? It will be F by mg. What is tension? F by sine theta. F value you might be asked to substitute. So any type of question like this, you solve it by either division of x and y, and sometimes you might not even need additional equations, directly only you can give the correct answer. Okay, so F divided by sine theta, which is option C. Okay, clear, my dear warriors? Very good, very good, very good. Amazing, amazing. Perfect. Let's move to the next one on your screen. There is a dynamometer D, which is attached to two bodies, 6 kilos and 4 kilos, force of 20 Newton and 10 Newton are applied on the masses the dynamometer reads. Now, don't get scared when you read the word dynamometer. It's basically a device which measures the force. For you, you just have to think about spring force. So, it's just a simple way of analyzing where you figure out how much is the spring force. That is exactly the reading of the dynamometer. Even in the exam, don't get scared when you find such new terms. Just look at the options. What are the units? Oh, Newton. Dynamometer is D. That means they're asking for that spring, how much is the force? That's all. So always read between the lines and rephrase the question yourself. Okay. So let's see. How do we do this? First of all, over here 6 kilo and 4 kilo is given. Force of 20 and 10 Newton is applied to the masses as shown. So because of this, let's see, maybe over here, I can say this is 20 Newton and here maybe this is some spring force. I will just call it as, let's say, X. I do not know how much that X is. That same X will also be over here. This is how much? Small f, which is 10 Newton. Okay. Now, because of these forces, they might obviously accelerate and all of that. Okay, so maybe this might accelerate like this. This might accelerate, I don't know, maybe like this. Okay. Now, finally, okay. Now the problem is I do not know A1, I do not know A2, I do not know X3 variables are there. Interesting. So can we do something about them? Okay. Is it moving as a system? That is also not given. Unless they were moving as a system, that would be easier. Okay, so it is not really mentioned what exactly is happening to these masses, whether they were at rest or they are in motion or anything like that. So even if you take the worst case scenario, this would how it would look like, that there will be two accelerations and one extension. So three variables in total, which means I will need three equations. But if you think about it, I can only make two equations as of now. First is this one, where net force will be 20 minus x is mass. How much is the mass? 6 into a1. For this, it will be 10 minus x, which is mass, which is how much? 4 kilos into basically a2. So apart from these two equations, we do not have any third equation. So the only possible option then could have been that they are telling that, listen, bro, the entire system is moving, uniformly, and the spring is already stretched. That's the only possible way you can then approach this particular question. Okay, so I'll just rephrase that question, and I will say that over here, the entire system as a whole, the entire system, the entire system as a whole is uniformly, let's say, being accelerated like this. It's the only possible way we can, probably think of solving it. Then it makes sense that, okay, I can say 20 minus x is 6 multiplied by a. 20 minus x is this mass into a, and over here x minus 10 is 4 times of a. Now, as you can see, we can either find out a first or x first, completely up to you. But, let's say we just add both of them. So it will become 20 minus 10 is 6a plus 4a, which is 10a, which is 10. So a will be 1. So if I substitute that value of a over here, we'll get the value of x. So 20 minus x is 6 multiplied by 1. So x will be 20 minus 6. So x will be basically 14 Newton. So hence the answer should be option D. Let's check it out. Yes, it is option D. But I think that one statement was missing, that the entire system is uniformly accelerating. It is not like it is having relative motion and all of that. So that common acceleration is there. That is one piece of missing information in the question. Yeah. Spring force will be same on both sides. Who is it? Krishul. Because it's the same wire which goes from left side to right side. So always remember, whenever you have a spring or a string, the force of tension or force of spring is same on both sides. Like for example, say you have a wall and there is a rope. Say you have a wall and there is a spring. If somebody pulls it with some force F over here, naturally this side will also experience that same force F, and inside the string, wherever there is a tension, that will be F. Here, inside that spring, okay, inside that spring, whatever that spring force will be there, that spring force will be just F throughout that spring, from one side to the other. Okay, so for ideal springs and ideal strings, the tension throughout it, or the spring force throughout the spring, no matter where you cut it, will be the same. Okay, fine. So that is the reason for taking same spring force. But yeah, the directions will be different, because this is this side, it will pull this block. This is this side, it will pull this block. So that's why the directions are opposite. That's all. Okay, kind of action and reaction. Let's move to the next question on your screen. In the adjoining figure, the coefficient of friction between the mass and the block is mu. Find the minimum force required to keep the block stationary with respect to the wedge. All right, you have to keep that block stationary with respect to the wedge. So that means they both move as a system. So if you consider m plus m as your entire system, there is only one force externally. So as a system, they will accelerate. So I can just say F is m plus m into A, or rather A is nothing but F divided by m plus m. Okay. As a whole, they will accelerate with this value. Now, if you can treat it like a inertial frame, good. If you don't, it's easy also, even in non-inertial frame. Think like this. There is a person who is sitting on capital M. So then that frame of reference becomes non-inertial frame, and observing this M body. So there will be one extra force. There will be one extra force on M, which is the pseudo force like this. And the value of the pseudo force will be mass of this body into the observer's acceleration, which we just figured it out, which is A, small a. Is that making sense? So extra pseudo force will come. So that pseudo force only is responsible for giving the normal. Yes, its original weight will be like this. The friction will prevent it from sliding down. And when you are just preventing it, Fs max will act, which will be nothing but mu into n. So these are the forces acting on that mass. And remember, this mass is at rest with respect to that capital M. So there is no unbalance over here. So first of all, normal force is balancing Fp. So normal force is m into A, and A is nothing but F divided by m plus m. So that is normal. Next, for vertical direction, your mg force is Fs max, and Fs max is mu into n. N is small m capital F upon capital M plus small m. This is mg. Mm cancels. So from this, g is nothing but mu f divided by m plus m. Question is, what is the force required? So F will be nothing but m plus m multiplied by g, whole thing divided by mu. Whole thing divided by mu. Is that clear? That is the answer. M plus mg divided by mu. Yes, perfect. There you go. Clear? Perfecto. Amazing. Any other type of question that you have problem with in Newton's laws? Let me know quickly before we transition to work power energy, guys. Yeah. Any other type of question you have issues with, let me know so that I can help you out with. Okay. And then we can directly go to work power energy. Ready for it? Yeah. No other doubts? Any other specific type of question you always get stuck or have a doubt, concern? Yeah. Shall we start work power energy then? Revision. Loving this session? Like the session? Subscribe to the channel already? Very good. Good to go. Okay. Fine, Dharani. Not necessarily. When one block is on the other with friction. Okay. I'll help you with that. I'll tell you what to do. So say for example, there is one block over here and another block over here, and there is a surface like this. Okay, and let's say we call this block as M1, let's say we call this block as M2. You can have multiple scenarios on this. Say for example, I tell you, listen, I am pushing this particular block like this, and let's say I'm pushing this particular block like this. Multiple scenarios. So say for example, I'm pushing this particular block over here, and maybe both of them are moving now. Okay, so there is some friction here, there is some friction here. So when you show the free body diagram, this is what will happen. This is upper block, this is lower block. This is M1, this is M2. You will show this force for sure. Its original weight and normal will still be there. First, show all the regular forces which you would normally do. Like this one will be there, M1G, this one will be there, N1. The normal's reaction will be on the from the upper face of the lower block. So it will be N1 like this. So this common surface which is there, M2 will exert N1, M1 will exert N1, same equal opposite action reaction. These are the first set of forces that you will draw. Now the only thing which is remaining is friction. How to understand that? Well, see, this block will be moving, this block will also move, but I think because you are pushing this block, this will move faster. So let's say V2, this will be V1. Kind of makes sense that why V1 should be less than V2, because when you push this, at max, they will move together. At max, they will move together. So V1 will be equal to V2. But usually, it might happen that you push this, so this block will move, but not as fast as the lower block. Make sense? So now because this mass is moving towards the right, 100%, the friction on it will be towards the left. So this will be F2 and this will be mu2 multiplied by N2 because this normal is coming from the lower surface and the friction is also on the lower surface. So that coefficient into N. Clear? Next, M1 for M2 is moving behind relatively or at least tending to move behind. So because the tendency is behind, so on M1, the frictional force will be forward. So that F1 will be mu1 N1. Once you understand any one of the friction, on the other block, the friction will be exactly opposite because it should be action reaction. So you will see the friction on this guy will be exactly this way. So it will be the same F1 which will come over here. That's how you complete the FBDs. Okay? Yeah, perfect. Yeah. Same way you can do it for this guy also. So say for example, there is this block here and there is another block over here. This is, let's say, M1, let's say this is M2. Your regular forces always first F, then your M1G, and then your normal, that same normal on this block, then this own weight, and then there is a normal over here, and I think that's it. So now because you are pushing this block will definitely move with some speed. This block might also move, but this block will have more speed than this block, so V2 will be less than V1. At max can move with it with an equal speed because you're pushing the upper block, so obviously it will move faster. It can't move faster than the original block. So now what happens is, first of all, because this lower block will try to move towards the right side, so friction on it will be left side, so F2 will be mu2 into that normal. That's one thing. Because M1 will move faster than M2, so for M2, M1 is moving ahead, so M1 will experience a frictional force behind. So M1 will experience a frictional force behind. So F1 will be mu1 N1. So on M2, there will be a reaction of it. So it will be like this. So that will be F1. So always if you know one of the friction, automatically you know the second friction is in the opposite direction. Okay. Notes you will get, don't worry. That's how you do it. Yes. Yeah, this is a complete syllabus. We start with 11th. If you see the introduction of this session, you will understand. Okay, let's do work per energy questions and theory first. All right, first, work is force into displacement only for constant force, which is actually a dot product of force into displacement. You can also write it as Fs cos theta, theta being the angle between force and displacement. Usually the unit is joule, but erg is CGS unit. 1 joule is 10 to the power 7 ergs. But when the work has to be calculated for a varying force is changing angle, direction, magnitude, whatever, then you use integration of the force with displacement, which is also the area under the force and displacement graph. Whenever force and displacement make acute angles or 0 degrees, then the work is positive. That means you are giving energy to the body. When force and displacements are perpendicular to each other, like the moon's gravitational pull and its displacement are perpendicular, so there is no work which is done on the moon, which makes sense because the moon is neither gaining or losing energy because of the earth. When work is negative, meaning force and displacements are opposite or the angle is obtuse angle, then you are sucking away the energy from the body. So that is negative work. So three signs are possible: positive, negative, and zero. That is neither positive nor negative. Now, when we talk about kinetic energy, half mv square, or you can also use p square by 2m, p square by 2m. You can also use half pv. All these are identical looking formulas. Half mv square, p square by 2m, or half pv, because p is mv, so mv into mv will become mv square. Okay, one and the same thing. So this kinetic energy can be changed if you do some work. If you do positive work, kinetic energy will increase. If you do negative work, kinetic energy will decrease. If you do zero work, it will remain the same. That means same speed. Direction might change, but that's none of our concern. So work done always changes the kinetic energy. That is called as your work kinetic energy theorem. After that, you learn about potential energy. Potential energy is the energy possessed by a body because of its configuration or a state or the manner in which it has been placed. So, for example, a mass which is placed on Earth, because of the manner in which it has been kept over there, it has the tendency to be attracted towards the Earth and fall down. So, it has capacity of doing work. So, it has gravitational potential energy. A stretched bow and arrow has energy, capacity to do work. It can shoot that arrow, give it some momentum. A spring which has been expanded or compressed also has capacity to do work. So, it has spring potential energy, which is half kx square. For a mass on Earth, it is mgh, height from which you have displaced it up. Okay, but also generic formulas for potential energy you should know. Yeah, it is there on the next page. Okay, right over here. For example, the work which you do in by that conservative force is negative of the change of the potential energy. This is very, very important. So there are two kinds of forces, conservative and non-conservative. Conservative are the good people, non-conservative are the bad people, the evil. Conservative means like gravitation, electrostatics, elastic, spring force. Non-conservative means like friction, viscous force, air drag, normal, tension. These are non-conservative forces. So the conservative forces like spring, gravity, they ensure that no matter which path you take, the work will be same. In fact, they also make sure that if you come back to the same point, the total work will be zero. There is no such guarantee by the non-conservative force. So if you come back to the same point, the work done by friction may not be zero. If you take one path and if you take another path, the viscous force, friction, air drag, they might do different work. So they are non-conservative forces. Now, non-conservative forces can never ever store energy. So always potential energy is associated with conservative forces only. So that's why I said work done by the conservative forces, like work done by gravity, work done by spring, work done by electrical energy, is negative of the work done by, is negative of the change in the potential energy. So that's why this term is very, very important. Work done by conservative force. So I'll just put that word conservative over here. Work done by conservative force is negative of the change in the potential energy. Very, very important. Yes, we are doing everything. 11th and 12th, both. Now, when you add this kinetic energy, half mv square or p square by 2m, with potential energy, mgh, half kx square, whatever, the total energy is called as mechanical energy. It's just the pure sum of kinetic and potential. Now, usually what happens, this is conserved, meaning if kinetic energy decreases, potential energy will increase, but this total energy will remain constant. Like for example, you throw a ball up, the speed reduces, kinetic will reduce, but gravitational potential energy gets stored. When it comes back, again that potential energy gets converted back into kinetic energy. So the total energy is usually conserved, and that is called as the law of conservation of mechanical energy. Initial kinetic plus initial potential is final kinetic plus final potential. When will this happen? Only under a situation where conservative forces are there. Otherwise, it will not be conserved. So in such cases, you will see that if non-conservative forces are there, then you will see initial kinetic plus initial potential. Uh, this will be more than the final kinetic plus final potential. So that's why you have to also consider plus the work done by the non-conservative force will be final kinetic plus final potential. Usually this will be negative. Usually friction, viscous, air drag, they will do negative work. So if initially it had 100 joules of energy, you subtract something, whatever will be left, maybe 80, 70, whatever, that will be less than the original energy. So this is what the equation will look like if there is a non-conservative force. Lastly, average power is work per unit time, but instantaneous power is force into instantaneous velocity. So keep the difference clear. Read the question whether it is at a some time, meaning instantaneous, or till some time, then it is average. Power is how quickly you are doing that work. Okay, great. Right. Let's do the question then coming up on your screen, and here it is. Okay, if a position is given by this for a mass of this moving from this to this, the work done is how much? That's the question. Let's do this question, guys. So work done is integration of force with respect to displacement. So the force is basically 3x square minus 2x plus 7. Displacement is dx. Limits will be from 0 to 5. So 3 is there. Integration of x square is there from 0 to 5 minus 2 into integration of x dx again from 0 to 5 plus 7 integration of dx is there again from 0 to 5. Okay, so this will become 3. X square's integration is x cube by 3, which is nothing but 5 cube by 3 minus 2 into x's integration is x square by 2, so it will be 5 square by 2 plus 7 into integration of dx is x, so just into 5. 3 cancels, 5 cube is 125 minus 25 plus 35. So 100 plus 35, 135. So the option is the right answer. Yes, that is absolutely correct. So simple integration questions usually come on this. Next question, sometimes the question can be also on graph. So they might just give you a graph and you might have to find the area under the graph. But just keep in mind, whenever you are finding areas, if it is on the top, it is positive, it is below, it will be negative. Keep that in mind. Sometimes they can also give you a question, what is the change of the kinetic energy? Don't get confused, because whatever is the work done will also be the change of kinetic energy. So if final energy or initial energy is given and change is asked, or initial is given, final is asked, something like that, this answer will also be the answer for delta K by work kinetic energy theorem. Okay, so all these questions are similar in category. Next, a force is acting on a body, displaces it from this point to this point, then the work done by the force is how much? Because the force is constant now, you have to use dot product. But from this point to this point, how much is the displacement? So it will be final position minus initial position. So do the math. 2 I cap minus 3 I cap is minus I cap. 2 j cap, there is nothing to subtract, so just 2 j cap. 3k minus 4k will be plus, so plus 7k cap. So that is the displacement. So now we can find out the work, which is force dot displacement. So it will be 2i plus 3j plus 4k dot minus I plus 2j plus 7k. So 2 into minus 1 is minus 2, 3 into 2 is basically 6, 4 sevens are 28. That's it. How much is the answer, guys? Quickly. Yeah, 28 plus 6, 34 minus 2, 32. 32 joules should be the answer. Yes, 32 joules is the right answer, my dear warriors. Very good. Option A, Sabri. Karthik. Very good, Harni. Sir, I'm late, just now finished. No issues. You can just start from wherever I'm teaching. You can watch whatever you have missed later on, but don't miss the live class. So, guys, even if you're joining in late, don't think I have missed something. Yeah, you have missed, but it's not like dependent. So, you can continue from wherever you have started to watch it. Okay. Yeah, around 4 o'clock we'll be having the first break. Correct. Because after 3 hours. Okay, almost every 2.5, 3 hours, I'm planning a break. Next question on your screen, here it comes. Motor pump 7560 kg of water per hour from a well of depth 100 meters. The efficiency is 70%. And the power of the pump is how much? Okay. So the power of whatever that pump is, keep in mind, only 70% of it. So just 70% of the pump power is actually useful for doing that work per unit time. That is the first thing you should realize. 70% means 7 by 10. Power of the pump, I do not know. That's what is the exact question. Work done per unit time. Work is being done to lift the water. So lift the water means I have to do mgh. So it will be mgh divided by t. So therefore, the power of that particular pump will be, okay, mass into G into H divided by T multiplied by 10 divided by 7. 10 goes on the top, 7 comes below. Mass of the water 7560. G 10. Height 100. Okay. Time, how much time from a well per hour? So how much 1 hour has 60 minutes? 60 minutes has 60 seconds. So basically 3600 seconds. So into basically 10 by 7. 0 will get cancelled. 756 is there, 36 is there. Approximately how much are you going to get, guys? Just check this out. Yeah. How much are you really getting? 756, 36, 7. 0 cancels, 0 cancels. 3 zeros are there. Into 10 to the power 3. This will be in watt. So final answer will be in kilowatt. Okay. So 36, 7. Is it close to 3? Just check. Is it close to 3? 3 kilowatt should be the answer. Yes, 3 kilowatt is the answer, guys. 3 kilowatt. Perfect. Yeah. 3 into 10 to the power 3, which is actually 3 kilowatt. Amazing. Moving to the next one on your screen. If the potential energy of a particle of mass 0.1 kilos moving along the x-axis is given by this equation, then the speed is maximum at a position of, interesting, potential is given. They have asked when is the speed maximum. Crazy, right? So think like this. Maybe the potential energy is changing, but the potential energy, whenever the potential energy is minimum, obviously the kinetic energy is going to be maximum, because law of conservation of mechanical energy. So you need to figure out when is potential energy minimum and then figure out the rest of the case. So we need to figure out when is potential energy minimum at which particular value of x, at which particular value of x. So for that, we have this equation of potential energy. U is basically 5x into x minus 4. So expand it. So 5x into x is 5x square minus 5 4s are 20. So 20x. So to find out minimum, I know the slope will be 0. So du by dx, let's find out, which is 5 into 2x minus 20 into x's derivative is 1. This should be 0. So 10x minus 20. So 20 is equal to 10x. Therefore, x is equal to 2 meters. X is equal to 2 meters. So this is the place where potential energy is minimum. So naturally, the kinetic energy is maximum. So which is option A. Yeah, it is minimum at 2 meters. If they had asked you how much is the kinetic energy, then you need to know how much is the total energy to solve this particular question. So maybe they would have given the total energy is E, and I know the kinetic energy will be maximum when potential energy is minimum. So I will use this x and substitute it here to get the value of u minimum, and that u minimum I will put it here. From that I can find out how much is the k max, if that was the question, but it is not asked here, so no need, not needed. But I'm just telling you how different problems can be framed. Next one on your screen, here it is. A body is projected at an angle of 60 degrees with the horizontal. Kinetic energy is initially x, kinetic energy at highest point. Well, when you throw it at the highest point, it is u cos theta versus u. So kinetic energy at the highest point versus kinetic energy initially, it will be half m u cos theta square divided by half m u square. So kinetic energy initially was x. Half m cancels. U also will cancel. So it will become just cos square theta. So kinetic energy at height h will be x into cos square theta. So how much is theta? It is 60. So cos square 60. Cos 60 is half. So half square. So it will become x by 4. So x by 4 is the D option, which is absolutely the right one. Okay, correct. Okay. Yes, very nice, very nice. Proud of all of you guys. Let's move to the next question on your screen. The bob of a pendulum is 200 centimeters long and it is released from a horizontal position. 10% of its inertial energy is lost, so mechanical energy is not conserved due to some resistance. Then the speed of the bob at the mean position is. Okay, so this is the pendulum. It comes down like this, and when it reaches here, like this, it has some speed. Question is, what is the speed at this position? That is what has been asked. So one thing is clear, that at this particular point, it has some potential energy which is mg into the length of the string. Assuming I take this as my zero reference to measure the potential energy. So initially it has only potential energy. Kinetic energy is just simply put zero. So initially no kinetic energy, only potential energy is there. So of that 10% is lost. 10% is lost. So 90% of this initial energy will be the final energy, which is just half mv square. If you understand this, now it is very simple. 10% is lost, so 90% is remaining as kinetic energy. That's all. So 90% means 9 by 10 multiplied by mm will cancel. G is 10. Length is 200 centimeters, which is 2 meters, is half into v square. Correct? Yeah, everyone understand till this point? So let's see what happens over here. 10 10 cancels. So 9 multiplied by 4 is v square. So v will be 3 multiplied by 2, which is basically 6 meters per second. 6 meters per second is option A, which is absolutely the right answer. Okay. So such questions might also come where mechanical energy is not necessarily conserved. Thank you. Okay. Yeah, perfect. Perfect. Let's go to the next question on your screen. And here it is. The power required for an engine to maintain a constant speed of 50 for a train of mass so and so on a rough rail is how much? Coefficient of friction is given, acceleration due to gravity is given. So for the train to go with constant velocity, it needs some force and that needs to exactly balance the frictional force. So the power technically is that pushing force into velocity, which numerically is that frictional force into that velocity. How much is the frictional force? It is mu into m into g into velocity now. So frictional force is mu mg. Mu is how much? 0.05. Mass is how much? 3 into 10 to the power 6. G is 10. Velocity is how much? 50. Okay. So 50 over here. Great. So this will become this 0 goes, becomes just 5 multiplied by 5 multiplied by 3 into 10 to the power 6. 25 into 3 is 75. So 75 into 10 to the power 6. So 75 megawatt should be the answer, which is option A. Yeah, 75, not WM, megawatt. Yeah, so guys, this is 75 megawatt. 10 raised to 6 is mega. 75 kilo is also there, but that will not be the right answer. So those were the questions. Let's go to now system of particles and rotational motion and rigid body, which includes center of mass, momentum, collisions, everything. Yeah, amazing. Great. All right. Man, 99 percentile is going to happen, and don't worry, it all happens not from one session. If somebody told you that just 99 percentile will happen from one session, then you don't ask anyone, just ask yourself. Just ask yourself that if it was possible 99 percentile from one session, then why people are stupid or fools or mad to enroll in a coaching for 2 years or 1 year or join courses, learn from a teacher, study so many books. Just think about it like that. Okay. So I'm not going to answer it. You just ask yourself that question. Are people mad or am I mad? To that, just one session, we can get 99 percentile if it was possible. And I would just teach for once. in a blue moon. Other time, I will just sit and dance or do some monkey things. Yeah, why should I teach? I can put a monkey instead of me, right, over here for 2 years. That monkey will be very entertaining. You might probably love it. Hmm. Yeah. Collision questions are also coming now. Yeah. Starting off with center of mass. Center of a mass of a body is that position or that location where the entire mass can be assumed to be concentrated, where, you know, if all the same forces were still acting, it will trace the same path as that in that body. So if you have some body, I don't know where the center of mass is, somebody says this is the center of mass, then you apply all the same forces, see how that particle moves, that body which has that point on the body should also move the exact same way. Then that is the location of the center of mass. It basically simplifies the questions in many situations. Instead of taking the entire mass, you just start focusing on one point. You're not worrying about the dimensions of the body, all those things. So it becomes easy. Like, for example, imagine I have a big body and I want to figure out what is the potential energy. I tell you, listen, this is where the center of mass is. Then let's say this is that height from that zero. So I know the potential energy of the body will now be potential energy of the center of mass. So it will just be mg into whatever this height is directly. So it is a convenient way. Now, in order to figure it out, how much is that center of mass, there are simple formulas. Wow, Chad 693, you are really the Chad, bro. I mean, if you watch it at 2x and came to this particular live place, really the Chad. Okay. So, having said that, the location can be given by integration of the coordinate into dm divided by integration of dm. So, you can use it for x, y, and z. So, this formula can give you the location of center of mass. If it is a continuous mass system, if it is not, then the position vector of that center of mass is simply given by the summation. So, m1 r1 plus m2 r2, like that, mn rn, the whole thing divided by total mass. So, m1 plus m2, like that till mn. But otherwise, you just use integration formula. Now, standard center of masses you should know. Like, for example, for a solid hemisphere, the location is 3r by 8. For a hollow hemisphere, it is basically r by 2. Then for a solid cone, from the base, it is h by 4. For a hollow cone, it is h by 3. Then for a triangular lamina, or a triangular sheet, it is basically the median, yes, or an intersection, which is basically the centroid. And for symmetric bodies, it is always the point of symmetry. Like for a cube, it is the center of the cube. For a sphere, it is the center of the sphere. For a cylinder, it is the center of the cylinder. For a rod, it is the exact midpoint, like that. Simple. Then for one last thing, which is an arc, it is nothing but r into of theta by 2, the whole thing by theta by 2. For a sector, which is like a piece of a pizza, the same formula, just 2 by 3. 2 by 3 times the radius of the sector. Theta is the angle which is subtended at the center in radians. So that is the formula. So if you know these basic formulas, you are sorted for all the problems. Okay. So these formulas you should definitely know. All right. Perfecto. Now, next thing for collisions. Yeah. Let's have a look at some questions and theory also. 1 second before that. Let me go back. Yeah. We define first impulse. impulse J is nothing but change of momentum, which is nothing but final minus initial momentum, which also can be written down as the integration of the force with respect to time from initial time to final time, which is nothing but area under the force versus time graph. From this, you can also find out the average force acting on a particle, which is the change of momentum by the time or just the impulse upon the time for impact. Okay, so that can give you the average value of the force. Next important thing, whenever two objects collide, so let's say one body is coming like this, another body is coming like this, and they happen to collide, then they exert same amount of impulse on both of them, each other. So let's say the impulse is like this, then impulse on this is exactly opposite but same in magnitude. It's like action and reaction during the collision time. And impulse always is generally considered for a small duration, not for a large duration. Keep that also in mind. Okay. Now, once you understand that, next thing is there are different types of collisions and types of impacts which can happen: elastic, inelastic, and perfectly inelastic. But irrespective of what type of collision it is, one thing is always conserved, and that is the momentum, which is also a law of conservation of momentum, which says whatever is your total initial momentum, m1 u1 plus m2 u2, if there are two bodies, if it's a single body, just m1 u1 will come, is equal to the final momentum, m1 v1 plus m2 v2. So law of conservation of momentum is always there. This is always true only if the net external force is zero, not otherwise. But most of the collision problems, you will see the force of collision is an internal force. Externally, there is no significant force, so you can always conserve the momentum. Now, what are these types of collision? So basically, in case of elastic collision, you will see that my final energy of kinetic is same as initial kinetic energy. So there is no loss. But in inelastic collision, the final kinetic energy is lesser than initial kinetic. Here also, final is less than initial. Here there is no loss. Here there is a loss. And in the third one, there is maximum loss. So that is called as perfectly inelastic collision, where maximum kinetic energy is lost after the collision, maybe in deformation, heat, light, sound, whatever other forms. Loss is maximum in case of perfectly inelastic collision. Most of the collisions in our day-to-day life are inelastic in nature. So they will hit and they will rebound. Energy is lost, definitely. But generally, they do not stick. If they stick to each other, then it is perfectly inelastic collision. There is a parameter which was given by Newton which tells me how elastic or inelastic the collision is, called as the coefficient of restitution. Don't remember this formula, rather remember it is always the relative velocity of separation after collision. Obviously, separation happens after the collision. Still, I'm explicitly mentioning it. Upon the relative velocity of approaching, because before collision, they will approach each other before the collision. Before the collision. So before the collision, they will be approaching each other relatively. After the collision, they will be separating out. If you take that speeds and divide them, you are going to get the value of E, which is the coefficient of restitution. This E for elastic collision is 1. For inelastic collision is less than 1 but more than 0. But for inelastic collision, perfectly, it is equal to 0. So it tells me how elastic or inelastic a collision is. That parameter is usually given or sometimes even asked. Okay, so these are the things which you should know. Some special formulas which you might remember, like this one. You have a surface, and let's say this is the normal, and imagine there is a mass which collides with it and rebounds like this. So say for example, this is incident angle, this is a reflected angle. Then tan of incident angle by tan of reflected angle is coefficient of restitution. So if there is a mass which hits a surface and rebounds, tan I by tan R is E looks like the Snell's law. That's all. Okay, keep that in mind. So very rarely questions come, but if it comes, you will save time. You will not waste time deriving. Okay, fair enough. Let's do some questions now on center of mass and collisions. First one on your screen. A body of certain mass is moving towards north with a velocity of 20 and another of 3 kilo is moving towards east with a velocity of 10. The magnitude of the velocity of the center of mass of the system of the two bodies is how much? Velocity of the center of mass is simply m1 v1, just like center of mass formula, plus m2 v2 by m1 plus m2. Mass 1 2, velocity 1 20, mass 2 3, velocity 10, but towards north and towards east. So there is a catch over here. So be careful. 20 meters per second is north, so it will be j cap. Mass 2 is 3, velocity is east, so it will be I cap. Okay, whole thing, because these are actually vector quantities. M1 and M2, so 2 and 3. Okay, so this will become 2 plus 3 is 5. So 2 into 20 divided by 5 j cap plus 3 into 10 divided by 5 I cap. So 10 by 5, 2, 2 3 is 6, so 6 I cap plus 4 2 is 8, 8 j cap. That's your velocity of the center of mass vector wise, but magnitude wise 6 square plus 8 square under the root. So this will be nothing but 10. So 10 meters per second should be the answer. Yes, perfecto. That is absolutely correct. Very good. Amazing, amazing, amazing. Next question coming up on your screen, and here it is. It says a composite body is made up of joining two or more bodies. Okay. Find the mass of the center of mass of the following composite body made by joining a disk and a square of side 2r of the same mass per unit area. Mass per unit area is the same. So first thing in such problems, figure out their masses and where their center of mass is. Like for the circle, the center of mass will be here, and side is 2r. So this is also 2r. So this is r. So this is definitely r comma 0. Center of the square will be here. This is 2r, this is 2r, so this is r and 2r, so this will become 3r. So this is 3r comma 0. I hope you get it, guys, how we did this. Okay, because this is given to be 2r and even this is going to be 2r, and remember this is r and all of that. Yeah, so that's the logic behind it. Now let's figure out the masses, but mass per unit area is the same. So assume sigma is the mass per unit area. Mass of the circle is, let's say, m1. Area is nothing but pi r square. Mass of the square is m2. Area is 2r into 2r, so 2r square. So from this, m1 will be equal to sigma pi r square, and our m2 will be sigma will be there. 2 square is 4, so 4r square. So I got m1, m2. I think my job is done. So the x coordinate, because y wise there will be no y coordinate will be 0. It's obvious. It will be somewhere here. So y coordinate will not be there. It will be 0. So x coordinate of center of mass will be m1 x1 plus m2 x2 divided by m1 plus m. Now you might see some problems where a circle is taken out of a square, or a square is taken out of a circle, or circle is taken out of a circle. In that case, the procedure remains the same till here, but after this point, instead of putting plus, put minus. So you have a cavity problem, just replace that plus with a negative sign. Everything else procedurally remains the same. That's all. So m1 I know from here is sigma pi r square, m into x coordinate, which is just r, plus m2 is sigma 4r square, x coordinate is 3r, whole thing divided by m1 plus m2, that means sigma pi r square plus sigma 4r square. Sigma and r square will get cancelled, so pi r plus 4 3 is 12 r divided by what is there, pi plus 4, so r in bracket pi plus 12 divided by pi plus 4 should be the answer. Pi plus 12 divided by pi plus 4. Perfecto. There you go. Yes, it's needless to say y coordinate of the center of mass will be 0. Cool. That's how you solve this question. Very good. Very good. Yes, immediately after rotation, we are going to have a break. Don't worry. Yeah. 100 balls of mass m moving with speed v collide with a wall normally and reflect back with the same speed. The total force by the balls on the wall is. If you consider any one ball, the momentum is mv. The change of momentum of any one ball will be final momentum minus initial momentum magnitude wise. So this will be nothing but 2mv. So the total change of momentum will be, there are 100 balls if I'm not wrong. So 100 into delta P1, which is 200 mv. So now the force is how much the total momentum changes per unit time. So it will be 200 mv and in t seconds, so divided by t. So 200 mv divided by t, which is the second option. There you go. Is that okay? So these kind of questions usually come in the JEE examination. Next, let's go to moment of inertia questions. Yes, few questions only are there. Yeah, we'll be done with this within no time. Yeah, let's do this. Moment of inertia, simple formula, sigma mi ri square or integration of r square dm. R is the distance from the axis, m are the masses which are present around it. It tells me how difficult it is to change the state of rotation. It depends on the axis of rotation, the total mass, and also what is the shape of the body. So these three things, distribution of the body, okay, that's the three things on which moment of inertia depends on. Okay, there are a couple of theorems. One is parallel axis theorem, where if you already know the moment of inertia about center of mass, about an parallel axis, it is given by, first write down the moment of inertia about an axis through the center of mass plus mass of the body, mass of that body, into how much ever distance you are shifting it by, square. So plus md square. That will give you the total moment of inertia. Okay? Yeah. Right. Very good. Next, you have perpendicular axis theorem, where if you have a body and you know about perpendicular axis, if I rotate it, I will get some moment of inertia. Let's say I call it I perpendicular. Then from that same point, draw two axes, one let's say Ix and one let's say Iy. If you add the moment of inertias for Ix and Iy, you will get the moment of inertia about that perpendicular axis. You can call it I perpendicular or you can also call it Iz. So this moment of inertia is Ix plus Iy, but please keep in mind this should be a laminar body, two-dimensional body. So you cannot use it for a cylinder or a sphere. You can use it for a disc, a ring, plate, all those things, but never for a big body like three-dimensional body. Torque is the equivalent of force in rotation. It's also called the moment of force, having the unit Newton meter. It's a vector quantity. It is R cross F. R is the place where that F is acting. So magnitude wise, it is RF sine theta. Theta is the angle between the force and the position where the force is acting. That torque, just like in Newton's laws, gives acceleration. Here, that torque on a rotating body gives angular acceleration. So actually speaking, instead of F is ma, torque will be moment of inertia into angular acceleration. Into angular acceleration. Okay? Great. Very good. So let's do some questions based on this. First question on your screen is here. The moment of inertia of a solid cylinder of mass so and so, radius so and so is how much? So guys, it's a solid cylinder. Clearly, formula is mr square by 2. So mass is 2.5, radius is 10, so 0.1, whole thing divided by 2, correct? So 25 by 2, that's going to be 12.5. So here it is going to be 1.25 multiplied by 0.01. So that's going to shift the decimal places couple of times. So once here and once here. So 0.0125. 0125, yes, kg meter square. So that's option C, I believe. Yeah, that's option C. But cool. Very good. Yeah, option C for Captain Shreyas. Very nice. Very nice. Let's do the next question on your screen. Here it is. A solid sphere and a solid cylinder have the same mass, same radius. The ratio of the moment of inertia of the solid sphere about its diameter and moment of inertia of the solid cylinder about its axis is what ratio? If you talk about the solid sphere, about its diameter, I mean this main axis, it is 2 by 5 mr square. If you take a cylinder and about its usual regular axis, it is nothing but mr square divided by 2. If it is hollow, it is just mr square. Solid, it is by 2. You have just been asked to find out the ratio. That's all, guys. Not a big deal. So 2 by 5 divided by 1 by 2. So it will become 4 by 5. So 4 by 5 should be the answer, which is right over here as option B. Can you revise continuous distribution questions just like for a rod or for a ring? Uh, yeah, sure. You mean for the center of mass part? Sure, that's not a big deal. I'll just tell you what happens in such cases. Say, for example, yeah, let's say you have a rod, okay, and some function is given. Let's say that function is given to be, alpha x square. So this is x, this is that rod, total length is L, and this is given mass per unit length. So generally they call it as lambda. Question is find where the center of mass is. So in such type of problems, what you do, so some function is given, continuous. So start with the basic formula, which is x coordinate of the center of mass is integral x dm divided by integral dm. Now x I know, but dm I do not know. So what you need to do in such problems is first find dm. Lambda is technically dm by dx. So dm is nothing but lambda dx. So this lambda is already given as alpha x square. So just put it over here. So that's it. Just have to substitute dm as alpha x square dx, and over here also alpha x square dx. As you can very easily see that alpha alpha will get cancelled. So x coordinate of center of mass will be integration of x into x square is x cube dx. Here just x square will be there, x square dx. Limit 0 to L, 0 to L. Because start from here, go till here. X cube's integration is x raised to 4 by 4. So L raised to 4 by 4. X square's integration is x cube by 3. So L raised to 3 by 3. So L raised to 4 by L raised to 3. 3 will go on the top, 4 will come below. So L is there. So 3 by 4 times of L. That's the answer. 3 by 4 times of L. Is that okay? Pakka? Yeah. All right. Great. I'm trying but can't solve. Where should I work? Focus on? Focus only on problem solving. Watch my problem solving classes. So many problem solving classes I have taken. Take those problems. Try to do it on your own. You are stuck. Watch how I do it. Solve it again. Watch me do it and solve it. That's all you need to do. Okay. So I have made many problem solving sessions. So please check that out. Okay. Next. Yeah. This circular motion concepts where you need angular position, angular velocity, all of that, and frequency, velocity, all of this. So first is angular displacement, that is how much angle you move in a certain time. Yeah, that is also given by the length of the arc which you travel divided by the radius. So if you travel like this is S, maybe it has some radius over here, and this is the angular displacement. Length of the arc is r into theta. So theta is length of the arc by radius. Then you have basically instantaneous and average angular velocities. So as you're rotating, maybe your speed is increasing, then it is slowing down, then again increasing. So instantaneous is d theta by dt, and average is delta theta by delta t. Velocity, this was displacement. Now we talk about velocity. Velocity is displacement by time. So average angular velocity versus instantaneous. For average, you will take big displacement by big time. For instantaneous, you will take small displacement by small time. Omega is the symbol. That omega is also related to the frequency of circular motion and even the time period. So if I have, for example, over here, a uniform circular motion, something like this. So then the time taken to complete one circle is time period. Frequency is how many rotations are happening per second. So angular velocity is 2 pi by time period or 2 pi f. We can also write down the velocity is omega into r. The linear velocity is nothing but angular velocity into the radius. So that formula also is valid. You can also use kinematic equations. Oh, I think I put it here. Anyways, we can also use kinematic equations just like you used in translational motion, but for circular motion or rotational motion. So final angular velocity is initial velocity plus alpha into time. Displacement is omega t plus half alpha t square. Final velocity square is initial square plus 2 alpha into displacement, where alpha is the angular acceleration. So angular acceleration alpha is how quickly your velocity is changing with time. And remember, tangential acceleration is alpha multiplied by r. Tangential acceleration is alpha into r, just like tangential velocity was angular velocity into the radius. So that same formula is valid here. Yeah, we have centripetal acceleration, but that is completely different. AC is omega square multiplied by r, which is also v square divided by r. If you take centripetal and if you take tangential acceleration and you combine both of them, then you will get the total acceleration. Then you will get the total acceleration. These are some basic terms which you should definitely know. So the particle is going in a circular path like this. Centripetal is always going to be towards the center of the circle. Let's do some questions based on this. A circular disk of diameter mass rolling on a smooth plane, rolling on a smooth plane, okay. 2.56 Newton meter of torque is acting on the disk, then its angular acceleration is how much? Okay, so there is torque, so therefore there will be angular acceleration. Torque is I into alpha. Alpha is us, so alpha will be torque divided by moment of inertia. Torque is given, I is not given, but disk is mentioned. So disk moment of inertia is mr square divided by 2. But clearly diameter is given. Okay, we can find the radius, not a big deal. So 2 times torque by mr square. So what is the torque? The torque is given to be 2.56, mass 4 kilos. Diameter is pointed, so radius will be 0.4, so 0.4 square. That's it. That's how you're going to do the solution. Yeah. What do you think is the answer, guys? Yeah, break is going to come after this particular problem. Yes. How much is it? Come on. 4 square, 16. Okay, so 0.16. This will go 16 times 16 by 4, 4 to the 8. Just check it out. Is it 8 radians per second square? Answer should be 8 radians per second square, which is option A, of course. Yes, very good, guys. Very good. Proud of all of you. Next, rotational kinetic energy. It's very similar to your translational kinetic energy and even the work concepts. In translation, work was force into displacement. Here, if your body is rotating, there is a torque acting on it. So the torque into angular displacement is the work. Similarly, you will say that the power is torque instantaneous, that is instantaneous, torque into angular velocity instead of force into linear velocity. Everything is similar, there is no difference. Kinetic energy, instead of writing half mass into velocity square, equivalent of mass is moment of inertia, equivalent of velocity is angular velocity. So you can also write it as half I omega square is just the energy because of rotation. That's all. Okay. And just like work kinetic energy theorem was there in translation, same theorem is applicable here. So you can say the work done on a rotating body because of a torque will change its rotational kinetic energy. Same things applicable even over here. Great. So let's do some questions coming up on your screen. Oh my God, where did we go? Yeah, this one. Hmm. A solid sphere is rolling without slipping on a horizontal plane, then the ratio of its rotational to total kinetic energy is. Okay, so we have a solid sphere, okay, and it is rolling. So this velocity is there, this angular velocity is there. When it rolls, V will be equal to omega r because it is rolling. Now let's find out how much is the kinetic energy of rotation. It will be half I omega square. Moment of inertia, it's a solid sphere, right? So for a solid sphere, it is 2 by 5 mr square. Omega will be V by r. So put V by r over here. So what will I get? 2 will cancel, r square will cancel. So mv square by 5 is the rotational energy. Let's find the translational energy, which will just be half mv square. So the total energy, which is rotational plus translational energy, will be rotational is mv square by 5, translation is mv square by 2, LCM is 10, so it will become 2 plus 5 and mv square. So it will become 7 by 10 mv square is the total energy. But that is not the question. The question is find the ratio. So ratio of the rotational by the total. Ratio of its rotational and total. So rotational is mv square by 5. Total is 7 by 10 mv square. So mv square cancels. So 10 goes on the top, 7 comes below, and this 5 comes here. 5 and 10 goes 2 times by 7. So 2 by 7, which is B option, should be absolutely right answer. Perfect. There we go. Okay. So these rotational energy questions can also come. Yeah. Many times they couple it with rolling. Then you can also get questions on angular momentum and its conservation and its relation with torque. Just like you have linear momentum, angular momentum version is basically when a body is rotating, it carries the momentum of rotation, which is called angular momentum, and it's a vector quantity, which is position vector of that particle into the momentum itself, r cross p, which is also r into m into v into sine theta. Theta is the angle between the position and the velocity or the momentum. Now this formula is okay if you have a single particle, but for a rigid body, don't use this formula. For a rigid body, the angular momentum is I into omega, moment of inertia into angular velocity. This is okay for a singular particle, like a point mass. But if it is a disk, cylinder, whatever, and it has many particles, so just use I omega. Similar to momentum is mass into velocity. Here it is equivalent of mass, which is I into angular velocity. Angular momentum also can be conserved like linear momentum, provided net torque is 0. So if the torque is not there, angular momentum will remain constant. And the reason for that is because torque is the rate of change of angular momentum, dl by dt. So if no torque, dl by dt is 0. So if dl by dt is 0, it only means one thing, angular momentum is constant. Keep that in mind. So before and after comparison can be done, it will be always equal. So these are some basic concepts. Let's have a look at one of those questions. Consider a disk of mass 5 kilos, radius 2 meters, rotating with some angular velocity about an axis. Then an identical disk is kept gently over the rotating disk along the same axis. The energy dissipated on both the disks continues to rotate together without slipping is. I've asked how much energy is dissipated and all of that. So I'll tell you one thing. I don't know what will be the final and initial energy. So I'll first find out the final speed of rotation. I know initial angular momentum should be final angular momentum. Both are rotating about an axis is kept over it, okay, along the same axis. Initially, we had one disk only. So the disk's moment of inertia will be mr square by 2. It will have some angular velocity. The other disk was just kept over it, so plus 0. Finally, an identical disk is gently kept over it. That means mr square by 2
identical means into 2, final angular velocity will be omega f. Mr square by 2 will cancel. Initial angular velocity is just 10. So 2 multiplied by omega f. Therefore, final velocity is 5 radian per second. That's the first thing. Okay. Now they are asked the energy dissipated. Okay, that means the loss of kinetic energy. Initial kinetic energy is half I omega square, omega I square actually. So moment of inertia is mr square by 2. Mass is 5, radius is 2 by 2 into omega initial is 10. So this will be how much? 2 square cancels. 10 square is 100. 100 into 5 is 500. So this is the initial energy. Final energy will be half. Total moment of inertia will be double. And final angular velocity square. So 2 times of 5 mr square by 2. Omega final is just 5. So 5 square over here. So check this out. How much will this come out to be? 2 square and 2 square will cancel. 5 square into 5, 125. 125 into 2, 250 joules. So 250 joules. So if you subtract them, then you will get the loss, which is obviously going to be 250 joules. So the answer is option B, which is 250. So this problem is also a reminder that even if angular momentum is conserved, kinetic energy must not necessarily be conserved. It may happen, it may not happen. That's depends on the problem situation, but it's not necessary. So that's how most of the questions are, where you keep a disk or you stretch the arms, initial angular momentum, final angular momentum, equate it. You have to find the velocities before, after, or kinetic energies before, after. Yeah. All right. Great. So we will do gravitation after the break. Okay, so we are just going to take a small break and we will resume. Now it's 4:20. We will probably resume at 4:45. 4:45. Okay, cool. See you in a bit. Am I audible now? Let me know. Yeah, welcome back, guys. Yeah, I hope am I clear, visible, audible? Everybody get back. Call your friends. It's time to start off with gravitation. The break time is over. Now we'll take the next break only after 11 syllabus is done. Are you ready for the marathon? Because this is a big marathon. It's not just you who are in this marathon. At least you are sitting. I'm standing. I have to teach. You are listening. So understand a lot of effort is going on from my side. So I need that support. I need that josh. I need that participation and that engagement, guys. It's time for gravitation. After that, we'll go to solids and liquids, fluids. Then we'll go to thermal physics and thermodynamics and all of that. And then we'll finally conclude with SHM and waves. Okay, so that is the flow. I hope that we take the next break only after 11th is over. Okay, for dinner. Ready? Okay. Yeah, let's cook. Starting off with gravitation. The fundamental principle on which this entire chapter is based is the Newton's law of gravity, which says that any two masses separated by some distance will always attract with a force which is inversely proportional to the square of the distance and directly proportional to the product of their masses. And this force is always attractive and does not get hampered by the presence of other masses or something in between them. And that constant of proportionality G, which is a universal constant, is nothing but 6.67 into 10 to the power negative 11 in SI units. This force is not necessarily between two particles. If you have multiple particles, each pair of those masses will experience the same force, Gm1 m2 by r square. Okay, that's your gravitational force. Now, with this gravitational force, you can calculate how much is the acceleration due to gravity on the surface of the earth at some height and even below. So when you are on the surface of the earth, what happens is that gravitational force will cause some acceleration. So if you use force is ma, you will get that gravitational acceleration, which is capital G mass of the earth by the radius of the earth square. This value is very, very important, Gm by r square. The mass of the earth is very large, in fact, of the order of 10 to the power 24 kgs. I think it's around 10 to the power 24 kgs. Radius of the earth is 6,400 kilometers. Substituting that, you will get the value of G. So the mass of earth is roughly 10 to the power 24. Radius on the earth is 6,400 kilometers. So into 10 to the power 3 meters, this was kilos. The acceleration due to gravity for earth comes out 9.8 meters per second square. But this is an approximate value. Still, I mean, you might say, sir, 9.8 is better than 10. Yeah, you're right. It's better than 10. 10 is used for calculation purpose. Okay, because 9.8, not that great number. This value changes from place to place because Earth's rotation, if you consider, or the variations of, the topography, like, somewhere water is there, somewhere land is there, somewhere mountain, somewhere valleys. So the mass distribution is not really uniform. And the third one, the Earth shape is not exactly a sphere because this formula is only valid for spherical bodies. So Earth is ovulation shape. So because of which gravity at the pole is more than the gravity at the equator. And even so, even on the equatorial points, it might not be the same. And even on North Pole and South Pole, it is not the same because, somewhere more land, more water, minerals are different, composition is different. So this is a more or less an average value, which you can say. But yeah, the fluctuations are not too much. It's not like 9.8 becomes 12.7. No, 9.8 to 9.85, 9.73, like that. That's kind of variation. So almost close to 9.8. Okay. That's number one. Number two, when you go with height and you go up, then the gravitational acceleration reduces, and the value of gravitational acceleration is gm by, instead of r square, it is r plus h being the distance from the surface, not from the center, square. But if the height is not too much, you can use binomial approximation and it becomes gravity on the earth, which is g 1 minus 2 into altitude by the radius of the earth. So this usually you use for small heights, but for large heights, you can use gm by r plus h whole square. Next, when you go below, then it is exactly opposite of the previous formula. Instead of 1 minus 2 h by r, it is then going to be 1 minus d by r, where d is the depth from the surface. Always h and d are measured from the surface. And if somebody decides to draw a graph of this, you should know how it changes, specifically inside versus outside. Here it is a straight line. Here it is a straight line like this. And after the surface, it goes like that. So this is till r, it is g. So here it is inversely proportional to distance square. Here it is directly proportional to r. So it is a straight line till you reach the surface. After that, it again decreases. So it is the maximum on the surface. Keep that in mind. All right. Now that was small g. So let's solve some questions based on this. The acceleration due to gravity at height of this much radius from the surface of the earth, okay, is how much? All right. So altitude is given. So acceleration at height h is capital G m divided by r plus h whole square. So gm is there, r plus h is this. So root 2 r minus r and this whole square. Oh, best part, r cancels. So gm divided by root 2 times of r square. So it will become gm by 2 r square. But what is gm by r square? Gm by r square is basically g. So it will become g by 2. That means 9.8 divided by 2, which is 4.9 meters per second square, which is close to 5. So I will mark it as 5. That's okay. If you take it as 10, okay, or else 4.9. Is that absolutely clear, my dear warriors? Yeah, very good. Proud of all of you. Moving on to the next one. The time period of a pendulum on the surface of the earth is t. If the pendulum is taken to a height equal to half of the radius of the earth, then the new time period. So they have coupled two chapters over here. Basically, time period of a pendulum is given by 2 pi under root L by G. So essentially, it is inversely proportional to root of G, number one. So the new time period by the old time period will be the old gravitational acceleration by the new gravitational acceleration. Okay, now how much is that going to be? See, it's taken to a height equal to half of the radius of the earth. So the new gravitational acceleration will be gm divided by r plus height equal to half the radius. So r by 2 whole square. Okay, so this will become gm by r plus r by 2 is 3r by 2. So 3r by 2 whole square. So it will become gm by r square, and 2 will go on the top as 4. 3 square will become 9. What is gm by r square? It is original acceleration due to gravity on the surface. So it will be basically g1 into 4 by 9 into 4 by 9. So from this, we will immediately get what is g1 by g2. g1 by, this was nothing but g2. So it will become nothing but 9 by 4. 9 goes on the top, 4 comes below. So instead of g1, I can put 9. Instead of g2, I can put 4. And entire thing under the root. Root 9 is 3, root 4 is 2. So old time by new time is 3 by 2. So the new time period will be 3 by 2 times of t. So 3 by 2 times of t, which is obviously B option. That's the right one. Okay. So this concept from oscillations and this concept from gravity. A similar question can come if you take the pendulum below the surface of the earth. So then you will use the depth formula. That's it. That is the only difference. Yeah. When will I finish? When will I finish what, bro? I will finish this session maybe by 12 o'clock. I don't think it will end before 12 o'clock today. But be mentally prepared that the session might extend till 1 o'clock or even 2 o'clock. Okay. But then it will be the heights of the lecture. I mean, a record breaking class of 12 hours. Assuming potential energy at infinity to be 0, the gravitational potential energy between two masses separated by distance r is given by negative gmm by r, not r square, and there is no plus sign, it's a minus sign. In electromagnetism, there is a plus sign where it is kqq by r. Here it is negative sign, gmm by r. This negative sign indicates that the potential energy at any place is negative as compared to the reference energy, which is 0 at infinity. So when the masses are infinitely separated, it is 0. But when they are finitely placed, it is lesser than 0. That's why that negative sign comes. If there is a system of masses, then the total potential energy comes by adding the potential energies of each and every pair of the masses. For example, there is a mass here, there is a mass here, there is a mass here, there is a mass here. So between these two, there will be potential energy. Between these two, there will be potential energy. Between these two, there will be energy. Between these two, similarly between these two, and between these two. So whenever you have to find the potential energy of a system, you basically take the sum of each and every pair possible where I is not equal to j. That's it. Yeah, u12, u13, u14, u23, ut3 4, u4 1, like that. All the possible combinations you will take. Is that clear? So that is the idea behind it. No problem, sir. But oh, wow. Then wish my friend happy birthday. Chad, which friend? He's not even here. Then why should I wish that friend? If that friend is here, then I will wish. Okay. Yeah. Now, based on that, you also uh, get the formulas for a satellite which is orbiting the planet. Um, let's say you have a satellite which is at a distance of smaller from the center. Then the total energy of the satellite will be its kinetic energy because it has some motion, and some gravitational potential energy because it is separated from the main mass of the Earth. So by distance of r, so half mv square minus gmm by r will be the total energy. But you need not have to leave it like that. If you find out the actual speed, which is possible using Newton's laws, where you write the gravitational force is m into centripetal acceleration, you get the orbital speed as root gm divided by r. Root gm divided by r. With that concept, you will get the kinetic energy, potential energy, everything literally. Okay, so it's not here. So I'll write it down. So from that, you will get kinetic energy is basically negative of the total energy, and the potential energy is 2 times of the total energy, where that total energy, which we just wrote down over here, where the total energy comes out to be negative gmm divided by 2r. So this is the total energy of the satellite, kinetic plus potential together, and kinetic will be negative of this, so minus sign will not come. Potential will be double of this, which makes sense. Basically 2 will go off, so minus gmm by r. That will be the potential energy. Something very similar in modern physics which happens for atomic structure. Okay, orbital speed also, obviously you should know, root gm divided by r. Lastly, you come to the concept of escape velocity. So when you throw a particle at such a speed that it never ever returns because it has enough kinetic energy to reach infinity, then that speed is called as escape speed, given by root 2 gm by r. Here the mass of the projectile does not matter, only the mass of the planet from which it is being thrown matters. The angle at which it is thrown also never matters. And for Earth, this escape speed happens to be 11.2 kilometers per second, not per hour. Okay, for Jupiter it is higher. For a black hole, it is infinitely large and usually more than speed of light, basically. So whenever the escape velocity is higher than the speed of light, that means even light can't escape and nothing can move faster than the speed of light, which is an indirect way of saying nothing can literally escape. So it becomes a black hole. So any planet or object having escape velocity more or equal to the speed of light considered as a black hole. Okay, so keep these things in mind. This also comes from energy considerations. So let's solve a question coming up on your screen. Here is the first one. Yep. Sir, but it's given it's only class 12 chapters, isn't? Where is it written, man? Only 12 standard chapters. Have I put it on the thumbnail or something? Oh, complete physics. Yo, somebody made the title wrong. Yo, 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 yo. I'm so sorry, guys. This has to be changed. Complete. That's why people are asking. Some admin has done this wacky job. Need to take care of this. I just changed it. It is complete physics. My bad. My bad, guys. No wonder people are asking, sir, why are you? That's what I was thinking. Students are not very dumb. Hmm. Okay. Okay. In title. That's what I checked the thumbnail. Thumbnail was fine. Okay. No issues. I changed the title, guys. So hopefully now people. Oh, so it means that I should have taken two marathons, huh? Only one class 11 separate and class 12 separate. Should I do that then? Should I do that? Only class 11 separate and class 12 separate. Do you want me to do that? Or you want me to do only one marathon? Yeah, now it got changed. You want me to do that? So should we do only class 11th today? Is that so? No. Now got changed. Separate. Yes. So it's okay. My wish. Only one. Both one separate. One marathon. No, one marathon. Yes, please. No, one full. Yeah, I'll do one only. So, yeah. Your wish, sir. But salt tough. Okay. No, no. We'll keep only one. And I'll tell you why also, because I'll tell you what will happen. Um, yeah. No, no, no. I'll tell you what will happen because of that. No, then the whole session alignments, everything will get spoiled. But I can do one thing though. I will do one day only 11 syllabus questions and one day 12 syllabus tough questions. That is okay for you. Today we'll do revise complete physics 11th and 12th together, not an issue. But in just couple of days, just 3-4 days more, one day only 11th problems, one day only 12th problems, and good unseen problems like a big you can think mock test. Yeah, we'll do that. Okay. If the escape velocity of a body from the surface of the earth is 11.2, then the orbital velocity of the satellite in an orbit which is at a height equal to the radius of the earth. Escape velocity is this much, the orbital velocity of a satellite in an orbit which is at a height equal to the radius of the earth. So orbital velocity is given by root of gm by small r, where that small r happens to be the distance from the center. So it will be r plus the height here at a height equal to the radius. So it is r plus r. So it will become root of gm divided by 2r, where I can do one small thing. How about writing it as root of 2gm by r? If I do it like that, I have to put the number which 4 over here. Check this out, because 2 by 4 is 2. Why I did this? There is a reason for that. That root 2gm by r is actually the escape speed, and I'm just left with 1 by 4, which is escape speed by 2. That means 11.2 divided by 2, which is nothing but 5.6. So 5.6 is option D, which is absolutely the right answer. Yeah, but keep in mind, this is not kilometers per hour or meters per second, it is kilometers per second. It's crazy high speed. Yeah, you will be getting the entire PDF for you to revise, definitely. I'm so glad Rakesh Balan, and I know that many channels might be there. For South India, very few channels are there. And in that also for JEE specifically, getting the proper JEE content, this is the only channel, simply put, in entire country. I can vouch for that. There are many people who tried before, many people who have been doing it probably just now. But there is only one channel when it comes for our South Indian students, students from Northeast, students from English speaking states or English speaking cities or English speaking schools. If you want the quality content, this I am the only one. That's it. You don't have to go anywhere else. Okay. Next one coming up on your screen. The potential energy of a satellite of a mass m revolving around the Earth at a height of a radius of the planet itself from the surface is how much? Potential energy is being asked, and potential energy simply is minus gmm by small r, but that small r is radius of the earth plus height. So r plus r. So it will become minus gmm by 2r. But if you notice, such an option is not there, so you need to be little bit careful now. What do I do? Okay, I have an idea. I'll write this as minus gm by r square, and that small m remains, that negative is outside, 2 is there, and that r is extra, so I'll put r over here. Why on earth would I do it? Yeah, see, gmm is there, 1 r will get cancelled, 2 is also there still. The reason why I did it, because gm by r square is actually acceleration due to gravity, and I got that hint looking at the options. It did not come to me in a wild dream. Okay, so I can write this as minus gm by r square is small g, this is small m, this is r by 2. So this is basically minus mg radius of the planet divided by 2, minus mgr divided by 2, which is 0.5 basically. Okay, so it is probably, oh my god, that is not mentioned here, but yeah, that is the option, guys, which is option A. Yeah, option A. Very good. First option, not the second option. Be careful. Many people forget that number 2 in the denominator because it's radius from the center of the planet. So that will become radius of the planet plus the altitude, r plus r. So that 2 number, if you miss, you will get option B. Be careful. Okay, cool. Let's go then to the next question. Okay, perfect. Kepler's laws, and then the time period of satellites also. The Kepler's laws basically are observational laws given by Kepler, which were again proved by Newton himself. So these three tell you about how the motion of small satellites around planets are, or how planets move around the sun. So first of all, the theory says that whenever a small body is moving around a heavenly body, then like the planet around the sun, for the planet, the sun is very massive, or for a satellite around the earth or a planet, because satellite is very small as compared to the earth, then the motion is given by Kepler's laws. First thing which happens is the motion of that small body is in an elliptical orbit as compared to circular. Yeah, and at the center you have a very large mass, okay, which is at one of its foci. So this small m will be going like this. This is the focus of that particular ellipse. There are two focus. There is nothing at the other focus, only one focus, one heavenly mass will be there. So if a satellite is revolving, the Earth center will be the focus, and the satellite will be going in an elliptical orbit. A special case of an ellipse is a circle. So it can go in a circular orbit, but it is not always a circle, but it is definitely an ellipse. Because remember, circle is not uh, sorry, ellipse is not a circle, but a circle is always an ellipse. Okay, keep that in mind. Second law is all about how fast and how slow it is. When it goes, then it is very fast. When it is far, then it is very slow. And the uh, theory behind it is angular momentum conservation. So if you are close, then how much area it sweeps should be the same as how much area it sweeps when it is really, really far away. When it is really, really far away. So the area swept per unit time is the same. So that is called dA by dt, also the aerial velocity, and it is given by L divided by 2 times of m, by 2 times of m. So this is basically your aerial velocity, guys. Yeah. Is it buffering? Just check, refresh. Okay. Yeah. All right. I hope it is clear. You're not receiving. I'm also getting that buffering. Second. Yes, I am also getting a error message on YouTube. Uh, Viewers are experiencing buffering. YouTube is not receiving enough video to maintain smooth stream. What should I do? What should I do? Just refresh, maybe. Hello, 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 hello. Just check now. Just check now. Is it fine? Yeah. Okay. Great. This mass over here, which mass is it? Yeah, a lot of people always ask this question, sir, is it this mass or this mass? Yeah, come on, guys, quickly think and tell me. Is it the bigger mass or the smaller mass? All good? Okay, great. Yeah, for CBSE also I will be doing it, but after the J mains first attempt. Yeah, we'll be doing CBSE marathons for physics, chemistry, maths also. Don't worry. So the aerial velocity is constant because angular momentum is conserved. So this is a constant value. Yeah, this is always the small mass. Yeah, it is not the big mass. It is the mass which is going to revolve. Yeah, keep that in mind. Third law is all about the time period. So the time taken to revolve is square is directly proportional to the cube of the semi-major length. Now, semi-major length means this is the major length. Semi-major means from here to here. So this is the semi-major length, which is A. The same thing will happen here also. This is also A. So the square of the time period is directly proportional to the cube of the semi-major length. Keep that in mind. In case of a circle, the semi-major length happens to be exactly the radius of the circle. So usually you will see square of time period is proportional to the cube of the radius. That's what you will generally see in most of the problems. Now, for a satellite, you will see the time period. The time period of a satellite is given by 2 pi under root. You have r cube. Actually, this is small r cube divided by gm. Notice this is also following Kepler's third law, but this radius is the radius of the circle, which coincidentally happens to be the semi-major length for that particular scenario. And if you square both sides, t square will be still proportional to the cube of radius. So it follows the third law of Kepler. Okay, keep that in mind. All right. So let's solve a question coming up on your screen. The time period of revolution of a satellite close to the planet's surface is 80 minutes. The time period of another satellite which is at a height of 3 times the radius of the planet from the surface is how much? We just saw that the time period of a satellite is 2 pi under root r cube by gm. So T2 by T1 will be R2 by R1, and this obviously cubed. That's what it should be. Kind of makes sense because it's directly proportional to root of is directly proportional to the root of r cube. So R2 by R1 whole cube inside the root. Now the new time period, I do not know. Old time period is 80 minutes. Root is there. What about the radius? The height is 3 times the radius. So actually it will be r plus 3r the second time. First time it is close to the surface. So it will be r plus a negligible height. Because it is close to the planet's surface, height can be neglected. R plus 3r is nothing but 4r. So 4 by 1. So that is nothing but root of 4 cube. So root of 4 is 2. So 2 cube. So 2 cube is nothing but 8. So that is T2 by 80. That means T2 will be 80 multiplied by 8, which is 8 is the 64. So 640 minutes is the correct answer. 640 minutes is option B. Absolutely the right one. Got it? So this is purely based on your Kepler's law. Next question, homework question, you can take it because it's very similar. The radius of the orbits are given, this and this. And the question is, what is the ratio of the speeds, orbital speeds they have asked. I'll give you one simple hint. Orbital speed is root gm divided by r. So using this, you can easily get the answer. Okay, so try this out as a homework later on, not now. Okay, it's time to do mechanical properties of solids, guys. Ready for this concepts? Let's revise them. Yeah. Okay, starting off with An elastic body is a body which tries to come back to its original shape and size when deformed, whereas a rigid body is the one, even when you apply sufficiently large forces, it never gets deformed. And as compared to a plastic body, where you apply a force, it gets deformed and stays like that. It doesn't make an attempt to come back. So that is a plastic behavior, which is other extreme. Rigid behavior, it does not change. Elastic behavior, you pull it, leave it, it comes back like a spring. Okay. So most of the bodies around us are elastic, or you can say almost elastic in nature. Few bodies like clay, cheese, pizza, right? So if you pull it, it stays there like that only. That is plastic behavior. Some bodies almost behave like rigid, like diamond or stones. Even if you apply large force, it barely changes until the force is very, very large, and then you start noticing cracks and all of that. Okay. Now, there are three things in this chapter: parameters, physical quantities, stress, strain, and modulus, which often come. And you will see one is a cause, the other one is the effect, and the third one is the material property. The cause is the stress, the effect is the strain, and the material property is the modulus of elasticity. So stress causes an effect of strain, and how much strain will occur will depend on the modulus of elasticity. And that modulus of elasticity is defined as the ratio of stress divided by the strain. That's it. So the ratio of stress and strain gives me the modulus of elasticity. Stress has the symbol sigma, strain has the symbol epsilon. Strain is a dimensionless quantity, whereas stress is a quantity with the dimensions. Bear that in mind. So what is stress and what is strain? Let me tell you. Okay. But before going ahead, let me also remind you, if you are applying some stress, then how much effect strain will be produced will be dependent on the modulus. So the modulus of elasticity is higher, then keep in mind the strain will be less. That means the effect will be less. So it will not deform much. But if it is infinitely large, imagine modulus of elasticity is infinite, then the strain will be tending to zero. That means negligible effect. So that will be a rigid body. Keep that in mind. So a rigid body will have highest modulus of elasticity, which is infinity. But if it is zero, then without even effort, the strain will be large. So you can keep on deforming it. It will be very, very easy to, deform it. Okay, so what is this stress and strain? All right, so I think I have not put that definition slides over here, so I'll put it here. So usually our stress is the force intensity, which is force by how much area that force is acting, and it has the units. It has the units of Newton per meter square, or basically just pascals. Strain is how much is the change upon the original dimension. So it is a dimensionless, unitless entity. Strain can be also in percentage, like 1% strain, meaning if the original length was 100 centimeters, the length has changed by 1 centimeter. That's in percentage. So stress and strain. So you apply a force on an area, and because of which it deforms, so it produces some strain in that object. How much will be produced depends on modulus. There are three kinds of modulus depending on three kinds of deformation. First one being Young's modulus. So if you take a rod and you pull it, or if you take a beam and you compress it, you take a cylinder and you pull it, the length will change. So that is longitudinal deformations, either compression or tension. So all the questions involving tension or compression are related to something called Young's modulus or longitudinal deformation. So when the length changes, and because of the force is perpendicular to the face, something like this. So this was your body, I suppose, and you are applying the forces like this, perpendicular to the face, in this manner. So in such scenarios, the length will change, and the modulus is then called Young's modulus. It is the longitudinal stress by longitudinal strain. So longitudinal stress over here longitudinal stress over here will be how much force you are applying upon how much area on which you are applying it. As you can see, you are applying it on this particular area. Okay, so that is that area which will come over here, and the strain which will be produced will be how much the length changed upon the original length. So this could be the original length. This would be the original length of that body, and it might expand like this. Maybe it will expand like this. So that expansion is basically your x. So if you take the division of that, you will get the Young's modulus. Simple. Okay, keep this in mind. That's what has been done. Young's modulus is stress by strain. The next type of modulus is shear modulus. So you have a surface like this. It's parallel to another surface below it. So you are applying on this area, a force which is parallel to the surface. Then that surface will slide like this. It will become maybe it will become like this. It will slide like this. So there is an angle by which it moves. So from that you can get the strain. Strain is basically tan of theta. How much is the displacement divided by L? So L is this, and how much it has moved is basically x. So opposite by adjacent is tan theta, that is the strain. Whereas the stress which is developed is called shear stress. It is how much force you are applying upon that area, force by area. So you will get basically the shear modulus then. I think that needs to be put. Yeah. So the shear modulus is basically how much shear stress is there upon how much shear strain is there. Shear stress is the parallel force by area. Shear strain is nothing but tan of theta. The symbol for shear modulus is G. The symbol for Young's modulus, remember, was Y. Lastly, you have bulk modulus. So that is used mainly for liquids or gases. So if you have a gas or a liquid and you have applied some extra pressure because of which, or less pressure because of which, the volume changes. So from all sides you are applying some pressure. So the pressure itself becomes the bulk stress. So the bulk stress is exactly how much extra pressure you have applied. There will be some change in volume that becomes the bulk strain. So that is how much volume changes per unit original volume. That is called as the bulk strain. If you take the ratio of both of them, you will get the bulk modulus, which is right over here. So bulk modulus of elasticity, usually K or B, anything you can use. So I'll just put it in a much better way over here, guys, for all of you. The bulk modulus. So if you want, I'll just yeah, I'll just this K and B, they are the same. Is nothing but the bulk stress divided by the bulk strain, which is delta P by delta V by V. But since this is modulus, this has to be always positive. So actually you put a negative sign to make it positive. That's it. That's only because of the fact that one of them will always be a negative number. So to make this ratio positive, you add one extra negative sign, because modulus of elasticity, modulus means positive number. Why are we doing it? Because if delta P is positive, delta V will be negative. If delta P is negative, delta V will be positive. So to make it a positive number, we are adding one extra sign. That's it. That is the only reason for it. Okay. Now, if you take 1 by B, that is called as compressibility. So one reciprocal of bulk modulus is called compressibility. So if it is more compressible, that means it has less bulk modulus. So it is easy to compress or expand it. If the bulk modulus is higher, the ratio will be small, 1 by B. So compressibility will be less. Okay, so it is not so easy to compress or expand it. All right. Till this point, absolutely clear, guys? Let me know if you understood it. Yep. All right. So let's begin with some questions. But before that, one last thing over here. There is also elastic energy which is stored. How much it is? It is given by half stress into strain into the volume of it. This is the way you can write elastic energy, yeah, stored per unit volume. Keep this formula in mind. And also the stress strain graph is what you should be aware of. This is stress, this is strain. So like this it will go, like this, then it will become plastic before it finally breaks. So here the slope of this particular graph is Young's modulus. Also, if you take the area, that is nothing but elastic potential energy per unit volume. That means if you take volume here, half stress into strain is that area. That's what it means. This particular point over here, that is called as yield stress. Yield stress. This zone is called plastic zone, and the maximum stress which you can apply is also called as the strength of the material or sigma strength. How much is the maximum strength? After this, it does not bear it. It will immediately break if you apply any more stress after this particular point. So this particular graph, again, you should definitely be aware of. All right. So let's have a look at this questions coming up on your screen. A force required to stretch a wire of area of so much area to double its length is how much? Interesting. Come on. Negative, why? Because that question, see, if you apply more pressure, delta P will be positive. But what will happen to the volume? It will become less. So delta V will be negative. So that's why I said one of those terms in that bulk modulus will always be negative. So that's why we add an extra negative sign. Okay, so force is asked, modulus is given. We all know Young's modulus is stress by strain, and stress is force by area. Strain is change in length by original length. So it will become FL by AX. But the question is how much force is required. Therefore, the force will be YAX divided by L. Now, Young's modulus 2 into 10 to the power 11. Area of cross section 1 millimeter square. So 1 into 10 to the power minus 6 meter square. The change in length. Now that is very important, guys. See, the original wire was like this. You have made it double the length. So if original length was L, this is X, which is going to be L because the final length is double. So a lot of people I have seen they put X as 2L, which is absolutely incorrect. Actually, X is also L and denominator is also L. So a lot of people generally make this mistake of putting the number 2. And that's why this question sometimes becomes tricky, especially in the exam environment. So it will become 2 into 10 to the power 5. But this is force, so it will be in newtons. So 2 into 10 to the power 5 newtons, that's absolutely the right answer, which is B. Else you will probably get 4 into 10 to the power 5, which is anyways not there in the option. Got it? Yeah. Okay. Clearo? Perfect. Let's do the next question on your screen. If pressure of a body is increased from 200 to 250 kilopascals, the body volume decreases by 0.2%. The compressibility of the material of the body is how much? Okay. So basically 1 by bulk modulus. So compressibility is 1 by bulk modulus, and bulk modulus is change in pressure upon change in volume ratio. So always take the mod of it, forget the negative sign. You just need a positive number. That's all I care about. Okay. So if you see how much is the pressure change, that is from here to here, that is 50 kilopascal. So 50 into 10 to the power 3. Relative change in volume we need to find out. Delta V by V percentage is 0.25. So delta V by V into 100 is 0.25. So delta V by V is 2.5, or I can just say 25 into 10 to the power minus 2 and more 10 to the power minus 2, which will make it as 25 into 10 to the power minus 4. So put 25 into 10 to the power minus 4 over here. Anyways, this is all positive, so I don't need the mod symbol anymore. So 25 goes with 52 times. This will go on the top and it will become 10 to the power minus 7. So 1 by 2 is 0.5 into 10 to the power minus 7. So I can write this as 5 into 10 to the power minus 8 is the compressibility. So that is option D. 5 into 10 to the power negative 8. Yeah, is that right? D option is the right answer. So sometimes they ask questions on compressibility just chumma to play around. That's all. Okay, next, go to the next one. When a wire is made of some material, Young's modulus is gamma, is subjected to a stress of S, or no, it's not gamma, it is Y only, because options say Y. The elastic potential energy per unit volume stored in the wire is. Okay, I just told you energy is half stress strain into volume. So energy per unit volume is what they have asked, is half stress multiplied by strain. Now, they have asked the question only in terms of modulus and stress. So I need to get rid of strain. So we know modulus of elasticity is stress by strain. So strain is stress by modulus. So instead of strain, put stress by modulus. That's it. So this will be half sigma into sigma by y. So it will become sigma square by 2y. So sigma over here, they have used s. So it will be s square by 2y, s square by 2y, s square by 2y. Option C will be the right answer. Yes, s square by 2y. Options look very similar. Okay, confusing also. Chances of silly mistakes are very, very high. Cool. Yeah, option C. Yep, C for Captain Shreyas. Very good, very good, very good. Let's go to the next question on your screen. The elastic potential energy stored in copper rod of length 1 meter and area of cross section 1 millimeter square where stretched by 1 millimeter is how much? Interesting. The elastic potential energy stored in copper rod of length 1 meter and area of cross section when stretched by 1 millimeter. Modulus is given, stretching is given, okay, area is given, but force is not given. Okay, so let's think. Energy is half stress into strain into volume. Now, stress is not given, so I have an idea. Stress by strain was modulus, so stress is y into epsilon. So I can write stress as modulus into epsilon as it is. Volume is area multiplied by the length. So this will become half Young's modulus epsilon square. Epsilon square. Epsilon is it given to me? Not exactly, but x by L. So x by L whole square into area into length, which is as good as saying it is Young's modulus. It is Young's modulus. One of the length will get cancelled. X square area, that's it. The whole thing divided by 2L. L square and L, 1L will remain below. That's all. So now just substitute. Modulus 1.2 10 to the power 11. X expansion is 1 millimeter. So 10 to the power minus 3 whole square. Area of cross section 1 millimeter also. So 10 to the power minus 6 over here. Whole thing divided by 2 into length. Length is 1 meter. Okay, so basically 1.2 divided by 2 is the only numeric number here. So it should be 6 into something. So either this or this. Now check it out. Which answer are you getting? Come on, guys. Calculate and let me know which is the answer. It should be 100% 6 multiplied by 10 raised to something, either 10 raised to 1 or 10 raised to minus 2. Most likely negative number, minus 6, minus 6, minus 12. So minus 1. Yeah, minus 2, I believe. This should be the answer. Option A. Yep, option A is the right answer. Perfect. All right. All right. Okay. Yeah. Okay. Yeah. Very nice. Very nice. Let's go. Next question on your screen. There is a wire of length something, it is stretched by 1 millimeter by force F if a second wire of same material, same length and 4 times the diameter is stretched by the same force, then the elongation is how much? For such questions where comparison is involved, ratio is involved, first derive the expression for whatever quantity is being asked. So elongation, so first find how much is elongation going to be in terms of other variables. Young's modulus is stress, which is force by area, divided by strain, which is x by L. So if you take x on the top, x will be equal to F by y will come below, area will anyways be below only, and length will go on the top, FL by AY. But area is not given, diameter is mentioned. So write it as FL divided by Y. Area is pi r square, radius is diameter by 2, so square. So 4 will go on the top. So 4 times FL divided by pi Y d square is the extension. Clearly mentioned by the same force, same material. So Y and F are the same and same length. So L is also same. So X is indirectly proportional to the square of the diameter. Very directly you get it. So therefore, X2 by X1 will be D1 by D2 whole square. Clearly it is mentioned the new diameter is 4 times the old diameter. So D1 whatever it is, this is 4 times of D1. So this will be 1 by 16. X2 I do not know. X1 it is clearly mentioned it was 1 millimeter. So X2 will be 1 by 16th of a millimeter. 1 by 16th of a millimeter. That is the answer. 1 millimeter will go on the top. So D answer is absolutely the right answer. Very good. So these are the kind of questions that you are usually going to get in solids. Okay, let's go to fluids now. Viscosity, surface tension, fluid statics, all of them. Ready for it, guys? Yeah, ready for some fluid related concepts? Perfecto. Let's start. Okay. Now, fluids basically are those materials which can take the shape, size of that container, can easily flow and acquire that shape. But our fluids, which we usually consider in our JEE physics, we consider it to be incompressible. That's very important. That means unless specified otherwise, the volume will not change, density will not change. Okay, but otherwise, if you apply sufficiently good pressure, then obviously volume will change, density will change. So we ignore changes in density. We consider it as incompressible. Second thing, we consider the liquid to be free flowing. Usually that means negligible losses are there when the liquid will flow. But actually it comes, if you consider viscous or air drag forces, but usually we neglect it unless specified otherwise. Like in projectile, we ignore air resistance. It's understood. Same way when liquids are flowing, we ignore resistances encountered on their way. Third thing, we assume that the flow is predictable. That is also called as a stable flow, okay, or laminar flow. So the flow is stable, okay, it is streamlined, you can say. You can predict what is happening at what point, what is the velocity. It is not irregular, random, which is turbulent in nature. No, it is not turbulent. Turbulent means like the waves of the sea. You cannot predict when the wave is high, when the wave is low. It is random. It just comes sometimes high, sometimes low. How the river water is flowing, especially in high mountains, after a waterfall or before a waterfall, it's very random. But when the river is flowing slowly, then you know the water is going with this speed. Even after 1 hour, it will be the same speed. It's not going to change much. So that is predictable, stable, laminar flow, or you can say streamline flow. All these assumptions are usually made for most of the questions, and which is okay. Also, there is one more assumption which is made, which is called as irrotational flow, and it means that the particles of the fluid, when they travel, they go in translational motion. They do not have rotational motion of the molecules. Else, our energy calculations will go haywire. So we ignore the rotational motion of the particles, which is then called as irrotational flow, which is a fair enough assumption. Okay. Yeah. Now, Over here, pressure, first thing, how much force you apply per unit area is called pressure, and the pressure of the liquid always spreads everywhere throughout the fluid, including the walls of the container. So whenever a question comes, what is the pressure of the fluid? It's the same force per unit area which applies on the walls, or the walls which apply on the fluid, or the fluid which applies on the other part of the fluid, or the fluid which applies on any body which is touching that fluid. So it is uniformly distributed. That exactly is called as Pascal's law. So the pressure variations are passed on everywhere so that the pressure gets equalized on all the fluid part or particles. But obviously the fluid pressure changes with depth or height. That is only because of gravity. But if gravity was absent, then the pressure everywhere would have remained the same. That extra pressure variation comes because of gravitational weight, nothing else. And how the pressure changes with height or depth is given by this formula. dP by dH is actually negative rho g. That's very important, negative rho g. That negative signifies that as height increases, the pressure decreases. What is this? dP by dH, rate of change of pressure with height. So if I move up by dH, how much does the pressure change by? The pressure changes by dP. So dP by dH is the rate at which the pressure changes, and it is negative rho g. Rho is the density of the fluid, g is acceleration due to gravity. As you can see, if g was not there, dP by dH will be 0, so pressure everywhere would have remained the same. Is that okay? Now, this variation of pressure only happens with height. It does not happen horizontally, okay, laterally. It's only with height. So, as you go up, pressure increases, increases, increases. But if you go horizontally like this, pressure is constant. These lines of constant pressure are also known as isobars. They are also known as isobars. Keep that in mind. And the pressure always increases opposite to the acceleration due to gravity. So always this is opposite. So that's why that negative g is there. Keep that in mind. Okay. Next, how much is the pressure at actually some depth or some height? So if you consider some liquid surface and just above it atmospheric pressure is there, let's say it is usually 1 atm, which is roughly 10 to the power 5 pascals. And if you go down by height h, at this point the pressure is given by atmospheric pressure plus rho g h. The rho is the density of the liquid here. So P is P naught plus rho g h. Okay, keep that in mind. All right, great. Now, as a rule of thumb, keep this in mind that if you generally go 10 meters below, the pressure gets added by 1 atm. So if you are at a depth of 20 meters, the pressure would be added by 2 atms. So the actual pressure over there will be 1 atm because of atmosphere. Over here, this contribution will be 2 atm. So 2 plus 1 will be 3 atmospheric pressure. So if you are at a depth of 50 meters, think about it. 10, 10, 10, 5 times. So 5 atm contribution because of the liquid plus an extra 1 atm because of the air pressure. So totally 6 atm pressure will be there. Yeah. Now, having said that, let's see some questions based on this. All right. Yeah, over here. In a hydraulic lift, if the radius of the smaller piston is 5 centimeters and the radius of the larger piston is 50 centimeters, then the weight that the larger piston can support when a force of 250 Newton is applied on the smaller piston. This is a concept of Pascal's law. So you have a piston cylinder arrangement like this. And imagine it's here, the pistons and the liquid is filling the tubes. So whatever pressure is there on the left side will also be there on the right side. Pressures are equalized. Now over here, the weight that the larger piston can support when a 250 Newton is applied on the smaller one. So let's say this is the smaller one and that is 250 Newton. Then the question is how much weight can this bear? So F2 is asked. given this is basically area 1, this is basically area 2. So this arrangement is completely based on Pascal's principle. The fluid pressure will be the pressure on the walls, pressure on the tubes, pressure on the piston, everywhere the pressure will be same. So pressure on the left side will be pressure on the bigger side. So P1 is force 1 by A1, P2 is force 2 by A2. So F2 is asked. So F2 will be F1 into A2 divided by A1. F1 is 250. Area, what is it? Radius is given. So area 2 by area 1, I can write it as pi r2 square by pi r1 square. So this will become 250. R2 by R1, pi cancels, square. So 250 multiplied by radius of larger is 50, smaller is 5. So 50 and 5. Is that right? 50 and 5. So 50 by 5 and then whole square. So there you go. What does it come out to be? 10 times. So 10 square. So 250 into more 100, which is 25 kilonewton. 25 kilonewton is option D, which is absolutely right. So you can see over here that with just barely 250 Newton, you're able to hold to 25 kilonewton. So that's, amplifying the force, magnifying the force multiple times. So this is how hydraulic lifts work. You might have seen in garages to lift cars and vehicles, they lift it using this hydraulic principle. So you can lift massive loads with a small force. Now, before going ahead, one small thing, barometric pressure and all those things are there. So if you have a tube which is like this, this is called as a barometer, where you have a test tube which is inverted and kept inside that liquid. There might be some small air gap. This is a liquid column inside. So if I know how high it is from the outer liquid over here, that's enough for me to figure out what is the pressure inside. So the pressure of the atmosphere, not pressure inside, my bad, pressure of the atmosphere is rho gh. This device is basically called barometer. And here, whatever is trapped is so negligible that this is also called vapors. Some water vapors are there. So the vapor pressure is usually negligible. So whatever liquid's pressure is there is going to be balanced by the atmospheric pressure, which is P naught. So that's why you can use this device to measure the atmospheric pressure. Now, usually questions can come like, you take a barometer, you take it on a different planet. So obviously G will change. What will happen if height will increase, pressure will increase? Or maybe you take it inside a lift. So if the lift is going up or down, G will change. So H will automatically change to keep the RHS and LHS balanced. So such questions can come for barometer. Then you have manometer. Which is basically two tubes connected by another tube. And you will see the length of the liquid in both the tubes is not going to be the same. That's because you have connected one tube to some gas, some liquid where the pressure is P1, and other is open to the atmosphere. So you will now see some height difference between the liquid levels in both the limbs. These are called as the limbs of the U tube. So that pressure difference which will come will be equal to rho gh. So you can say this is P1 minus atmospheric pressure. So here it is open to atmosphere. So pressure difference is rho gh. So manometer is used to measure the pressure difference, whereas barometer is used to measure the atmospheric pressure. That's the main job of these devices. Keep that in mind. Also, in such manometers, keep in mind, pressure at this point will be equal to pressure at this point. Pressure at this point will be equal to pressure at this point. Pressure at this point will be also equal to the pressure at this point. But don't say ever that pressure at this point and pressure at this point is same. No, it is not. Because they are in two different liquids. Only in the same liquid at the same height, the pressure is same. So this is very, very important. So this and this is same, this and this is same, this and this is same. That's another story that as you go down, this pressure will be more than this will be even more than this. But this is air, this is liquid. You cannot equate such pressures. It's not allowed. Only in same liquid, same height, pressures are same. All right. So let's do a question similar to this. Let's see if we can do this question. Yeah, you can also call it as gauge pressure. Gauge pressure is the difference of atmospheric pressure and the actual pressure. Yeah, not the absolute one. Come on, guys. Let's see if we can do this question. How many slides are there? I also don't know, man. There are many slides. If I count the slides, no, then I will only get a shock. So that's why I did not count. I did not have the courage to measure the number of slides. Let's see. How do you do this question? As you can see, the area of cross section in the wider tube is 800. If a mass of 12 kg is placed on the massless piston, the difference in the height levels. So, like I said, in the same liquid, the pressure is same. So at this point and at this point, the pressure is same. At this point and this point also pressure is same. So I think it's better that we compare these two because height difference is given. So if I call this point number 1, this will be point number 2. So pressure at point 1 and pressure at point 2 will be same. Pressure at point 1 will be nothing but rho GH plus the atmospheric pressure, because outside air is there P naught plus that rho GH. So that will be the one. P2 will be atmospheric pressure plus the pressure due to this weight. So that will be nothing but the force per unit area. So the weight of that object divided by that area. As you can very easily see, P naught and P naught just got cancelled. So how much is the weight? What have they asked? Then what is the difference of the thing? Okay, 12 kg. So 12 into G. What is the area of cross section? 800 centimeter square. So 800 into 10 to the power minus 4. Rho is 10 to the power 3. G is 10. Height I do not know. So therefore height will be 12 by 8. 1010 cancels. This will become 10 to the power minus 3. Goes on the top as 10 to the power 3. Here also I have 10 to the power 3 and 10 is there. 10 to the power 3 will cancel. 10 goes on here. So H will be 12 divided by 80 basically. So 12 divided by 80 should be the answer, but it will be close enough to 12 by 80. Yeah. So, but this will be in meters. This will be in meters. So centimeters, which will be 1200 by 80. So it will be 120 by 8, which is 60 by 4, which is nothing but 15 centimeter. Yeah, so 15 centimeter should be the answer. Yes, that's perfectly fine. Right. Got it, guys? How to solve these kind of questions? So it's based on pressure inside a liquid concept, how it varies, P naught plus rho GH, plus equating the pressures inside the liquid, plus, Pascal's principle where the pressures, how they equalize at the same heights. Okay? Yeah, very good. Excellent. So these kind of questions you can definitely get in hydrostatics or pressure variation. The next concept comes on flotation concept and buoyancy principle given by Archimedes. Archimedes says that when you immerse a body inside a liquid, then whatever part is immersed inside of that solid, it will displace an equal amount of fluid outside. That means that much volume will come out of that container, or that much water will rise, and whatever amount of water is displaced. So imagine there is a liquid and you put some object inside, so you are using up some space of that fluid, that is called as the displaced fluid. So that much volume of water, if you take it and measure what is its weight, okay, weight, not mass, weight, exactly that much amount of force will be applied on that solid which is kept inside, and that force acts upwards as if it is trying to hold it and reduce its feeling of weight and makes it feel like weightless. So that force which acts upwards is called buoyant force or upthrust force, and that force is always going to be equal to the weight of the fluid which has been displaced. So to visualize it, you can think of as if there is some liquid over here. Then what happened is, just 1 second, guys. Yeah, just 1 second, just 1 second. Oh, 10 to the power 3 in the previous question. I mean, this one. Density of water is a standard value, guys. Water density is 1000 kg per meter cube. This is a standard value which you should remember. Okay, 1 gram per cc. You can also remember it as 1 gram per cc, centimeter cube. That's a standard value. Okay, so coming back over here, this was the liquid. Now what you have done is you have put a solid, maybe like this over here. You have put a solid over here, something like this. So there is some amount of fluid which was there over here, which just got displaced. There was some amount of fluid which just has gotten displaced. You can see this is called as the displaced fluid. This is the displaced fluid. So if you measure the weight of it, so if you measure the weight of this, which will be mass of that fluid which is displaced into G. Mass is density of that fluid into volume of that fluid which is displaced into G. But this volume of that fluid which is displaced will be also volume which is submerged. Volume which is submerged. So if you see this much part exactly, this is that part which has been submerged. Okay. So that weight happens to be the buoyant force. So on this particular solid, you will see there will be a buoyant force which will be exactly equal to the weight of this fluid, which is rho, density of the fluid, into volume submerged into G. So this is called as the buoyant force. This is called as the buoyant force. Keep that in mind. Density of the fluid into volume which is submerged into G. This is the volume which has been submerged. Okay, this is that volume which has been submerged, which is also the volume of the fluid which has been removed from here. So this is exactly that same volume. It has to be. Cool. Very good. Now, other regular forces will be there, like the original weight of that body. Now, if the weight of the body is more than the buoyant force, it will sink. If the weight of the body balances the buoyant force, then it will float. Very simple logic, nothing great about it. Okay? If the weight of the body is more than the buoyant force, it will sink. If it is equal, it will just float. So that's the logic behind it. Now, there are some tricks which you can remember. For example, if the density of that solid which is floating is given as, let's say, 800, and density of that liquid is given as 1000, then always keep in mind that this is the liquid, this is the solid. Then because the solid's density is 80% of the density of the fluid, it means 80% will be below and 20% will be outside. This rule of thumb, keep in mind that if you know how much percentage is the density wise of that solid as compared to the fluid, exactly same percentage will be submerged and exactly the other percentage will be outside that fluid. For example, we know that icebergs are 90% inside water. That means density of ice is 90% of water. So 100%, the density of ice will be 900 kilograms per meter cube. Got it? So this, you can use it directly for solving problems. How much is submerged, etc. You don't have to do that calculation of buoyant force, area into length, volume submerged, nothing needed. Then, when the fluids begin to move, this was all about hydrostatics. When fluids begin to move, they follow two major principles. One is equation of continuity and Bernoulli's principle. Equation of continuity says that when the fluid moves and it can widen up, it can become narrower, anything can happen. The velocities will change because the areas have changed. If this is area 1 and this is area 2, as it becomes wider, the speed becomes less. So it says that area 1 into V1 will be area 2 into V2. I think this should have it A2, but A2 V2. This is called as the equation of continuity. And this particular number is also called the rate of volume flow, which is basically how much volume is flowing per unit time. How much volume is flowing per unit time. So whatever volume goes in, that much volume will come out. That is equation of continuity. As simple as that. So if area 2 is bigger, V2 will be smaller, which makes sense. At a wider place, the speed will be less. It will go slowly. Okay. Second important principle is that of Bernoulli's principle, which says that at this point there might be some pressure inside the liquid. It might be at some height from some standard surface or line, and it might have some speed. So pressure plus rho g height plus half rho v square will always be a constant throughout that liquid. So for example, if the height has gone up, that means y will go up. So either the pressure will fall or maybe the velocity might fall. So that the sum of these three numbers will remain the same. At some place, maybe the velocity becomes large, then either this will go down or this would have come down. If this can't change, then this will change, or both might change. But their sum will remain the constant. Now, what are these numbers? The first number is called as how much external work is being done per unit volume. This number is how much is the gravitational potential energy per unit volume, and this number is how much is the kinetic energy per unit volume. So if you think about it as such, this total constant, why it is true is because this is representing the total energy per unit volume, and that has to be constant by energy conservation. So Bernoulli's principle comes out of conservation of energy, which is how much work is done per unit volume plus potential energy per unit volume plus kinetic energy per unit volume for that liquid as it flows should remain the same. And continuity equation comes from the conservation of mass. Whatever mass goes in has to come outside. So that gives me continuity equation. Okay? Till this point, Clear, guys? All right. Let me know. Are you now ready to do some questions? Fire up the chat box, guys, quickly. First question on your screen. Here it comes. Answer it quickly. Fire up the chat box with the answers. An incompressible liquid flows through a horizontal tube as shown. Then the velocity of the fluid over here is how much? Okay, it's not a singular tube. It has been split. So it doesn't matter. Still, whatever goes in should come out from both the sides. Whatever goes in is A1 V1. Whatever comes out is A2 V2 plus here A3 V3. So area over here is A. There also it is A. There it is 1.5A. So A multiplied by 3. Area 2 is A. Speed is 1.5 plus. Next area is 1.5. Velocity is unknown. Now 3 A first, no, we can't, this was 1.58. A we can first cancel out. So it is 1.5 plus 1.5 into V3. This 1.5 goes here, so it will become 1.5 is 1.5 V3. So V3 will be 1. So 1 meter per second is absolutely the right answer. Yes, very good. Yeah, very good. Good to go. Very good. Shall we go ahead? Next question on your screen. Yeah. Okay, let's go. What does it say? A boat having a length of 3 meters and breadth 2 meters is floating in a lake. The boat sinks by 1 centimeter when a man gets onto it. The mass of the man is how much? Okay, so what is happening is there is a boat like this and it sinks further by 1 centimeter. So this is that extra 1 centimeter which the boat has sunk. But do not forget, actually the boat is a three-dimensional figure. So actually it will be something like this. That's how the boat will be. Okay, assuming a rectangular shaped kind of figure. So like this and like this. So I want you to visualize this part is that extra volume which is submerged. So extra fluid displaced. Why will it come? This extra fluid has been displaced to support the man, to support the weight of that man. And what does Archimedes' principle say? The weight of the fluid displaced is exactly the buoyant force. So that means the the buoyant force over here is supporting the weight of the person. So the weight of that person should be equal to that extra buoyant force, which is nothing but rho V, that is extra volume submerged, into G. So what is the density of the fluid? I think we can just, the mass of the man is asked. So this will be M into G. G and G will cancel. So M will be rho F into extra volume submerged. Now volume is area multiplied by that extra length which got submerged over here. So density of the fluid, we can just take it as 1000. Area of cross section, length 3 meters, breadth 2 meters. So think of it like this. This is 2 meters, this is 3 meters. So this will be 2 multiplied by 3. And this is 1 centimeter. So that extra height will be 10 to the power minus 2. So from this, we get this as 10 is there, because minus 2 will plus 2 will cancel. So 2 3s are 6. So this will become nothing but 60 kilos. So 60 kilos is option A. That's absolutely correct. Got it? Option A. Yeah. So, oh, you need Pandu to visualize. This is our Pandu. So he's inside that boat. Yeah, I hope you can see the Pandu. He's inside that boat. Very happy because the boat is able to balance him. Cool. Very good. Let's do next question on your screen. There is a wind with some speed blowing parallel to the roof of a house. The area of the roof is this much. Assuming that the pressure inside the house is atmospheric pressure, the force exerted by the wind on the roof and the direction of the force will be how much? Interesting. Let's think. So imagine this is the roof of the house, and what happens is over here, this is inside the house. Here the pressure is just P naught. Whereas on the top, what is happening? Because the winds are blowing, okay. So over there, if you use Bernoulli's principle, you know, everywhere, this P plus half rho v square plus rho gh will be constant. Now, neglect this height difference. It is not so much to cause sufficient pressure difference. So just consider a point above the roof versus below the roof. It's negligible height. So I can say since h is nearly the same, or I would say nearly the same, for which 2 points? If you consider a point here versus a point here. So it is mainly P plus half rho v square, which is constant. So inside it is P naught. Velocity is not there, it is still air. Outside it is P plus half rho v square. Okay. Now, what is mentioned? Assuming the pressure inside the house is atmospheric pressure, the pressure exerted by the wind on the roof is how much? The force exerted by. Now, in order to calculate that force, what will I need to calculate, guys? Won't I need to calculate the pressure itself? Yeah, won't I need to calculate the pressure itself? From that only I can get the final answer. But keep in mind that this pressure inside is applying a force like this. The pressure P from the top is applying a force like this. It's like they're fighting each other out. So the net pressure force, won't it be P naught minus P? That will be half rho v square. Now pressure is force per unit area. So this will be net force per unit area is half rho v square. So therefore, the net force acting on it will be half rho v square multiplied by the area. Do you guys get it? The inside air is pushing the rooftop. The outside air is pushing it below. Under normal conditions, these should be equal, but the conditions are not the same. Here the wind is blowing, so the pressure has changed. So there is a difference of the forces causing an unbalanced pressure or unbalanced force. So solve this now, you will get the final answer. Yeah, half is there. Density of air is 1.2, velocity 40. So 40 square, area of cross section 250. Area of cross section 250. Just do the math and tell me what is the final answer that you are getting. Come on, my dear students. Yes, are you getting the answer as 2.4 into 10 to the power 5? Just check it out. 2.4 into 10 to the power 5. Very good, very good, very good. Amazing. Option D, Harni. Very good. Perfecto. Lovely. Amazing. Okay, we'll go to surface tension. Just give me 1 minute. Just give me 1 minute, guys. So welcome back, guys. Yeah, time to continue with the surface tension. A short 5-minute break. Direction of what, Samuel? Okay, you are asking the direction of this one in this question. Okay, how do I know whether it is upwards or downwards? I'll tell you one thing. See, this is P naught plus 0. This is P plus something. So when you add pressure with something to get the same number, obviously this P should be lesser than P naught. Make sense? If this is some 10, this might be 8, because if you want to get the same number, so this could be 8 plus 2. So P is definitely smaller. That means upper force is smaller from the top side. Downward force, or from the down force, it is larger. So net force will naturally be upwards. So 100% the net force will be upwards. And this is the reason why the roofs blow in reality, even during hurricanes or strong winds. You might have seen some scary videos where the roof of a house gets blown away. Why? It's because of the Bernoulli's principle. Yeah, it gets a net force. By the way, from this only the understanding of a plane's wing comes. So if you create a differential velocity on the top and bottom, the velocity with which the air blows is different, pressures will be different. That will create a net force which is enough to lift the entire plane, which is lift yeah which is enough to lift the entire plane. So that is called as the lift of a plane. The same question can come for a plane also. They'll give the area, they will give you velocities at the top and bottom, and find out how much is the lift force. Same question gets repeated, guys. Okay, so now time to look at surface tension, guys. Yeah, surface tension, there are a couple of simple formulas over here. So imagine this is the liquid surface. This is the inside of a liquid, also called as the bulk of the liquid. This is the surface of a liquid, and the surface of a liquid always is under a tendency to contract. No molecule wants to expose itself, uh, and because of which the surface of the liquid feels as if it's always trying to contract, and it's like a rubber sheet. Imagine like a cloth like this, which is stretched. So it is always trying to contract. It is stretched and it is always trying to contract. So it feels like a fabric which is under tension. And that's why it is called as a surface tension phenomena, because this phenomena happens on the surface of a fluid. Now, what happens is, if you take any particular imaginary length on the surface, it can be anywhere, doesn't really matter, there will be force which will pull it from this side to this side, and also a force which will pull it from that side to this side. So that force which acts per unit length, any length on the surface, is basically the surface tension, T or S, whatever symbol you want to use. Okay, so the surface tension is how much force acts on the surface of the liquid per unit length, Newton per meter. Okay, this value will depend on the temperature, adulteration, composition, nature of the liquid, and all of that. And if you increase the temperature, the surface tension reduces, and it can become zero at a critical temperature also. All right. Having said that, also keep in mind this force also comes because of cohesion and adhesion forces of nature. Cohesion is when two molecules of same kind apply forces on each other. Adhesion is that force when two molecules of different kinds, maybe copper with water. Okay, so those molecules apply forces on each other. That is called adhesion force. Now, surface tension predominantly is a cohesive force. Keep that in mind. Okay, because molecules of similar kind are applying on each other. Yeah. So the surface area always tries to reduce. Keep that in mind. Now, because the surface area tries to reduce, it means if I try to increase the area, obviously I will have to perform work, and that work will get stored in the form of
surface's energy, so surface potential energy. So if a surface has a larger area, it has more ability to perform work because it will tend to contract itself from all the sides. So the I would say the work done per unit area is also surface tension. In fact, that there is a derivation for that, but it's okay. Another way of remembering it is, let's get rid of this. So it is basically U is equal to S into A, or S you can use, or T. Okay, surface tension you can use the symbol T. Just like over here also you can use T or the symbol S. Different books will use different symbol. This is very easy. United States of America, USA. So this is the energy which is there on the surface. This is the surface tension, is the area which is being exposed. Okay, as simple as that. This formula you should remember. Where will you use this formula versus where will you use this formula? Usually for these questions, what happens is you will be given a wire frame which is like this, and there will be a rod which is movable. Okay, there will be a rod which is movable like this, and there will be a film which will be formed over here like this. And then, you might be asked, what is the force on this particular movable rod? This rod is movable. It can slide left and right. So it so happens that the force which is acting on that rod of, let's say, length L will be, a lot of people make a mistake over here. They write it as S into L, but that is absolutely wrong. It is 2 times of SL because there are two surfaces of the fluid, one on the top and one below it. Yeah. The liquid is a film. Remember, a film, it has multiple layers. It's like saying there is a layer on the top, and do not forget there is a layer below over here also. So that's why SL and SL together makes it 2SL. Okay, keep that in mind. Oh, hi Maharaj. Welcome, my dear student from Salem. Okay, welcome aboard. Yeah, both. So that 2 number, do not miss. Where do you use this formula? This formula is used where you might be given that there is a big drop, and that is being converted into smaller drops like this. So in such scenarios, you will see the energy will change because the area has changed. But one thing which will remain constant is if there are n number of drops, each of them will have some volume of small drop that will be numerically equal to the volume of the big drop. So these kind of questions you will use this principle. Volume will remain the same. From that you can find the radius. From the radius you can find the area which has changed. So once you know how much area has changed, you can also find how much energy is required for that area change. Usually that energy changes comes from external work done or might come in the form of heat. Okay, so usually they'll ask how much heat is being liberated or required, or how much is the work which is being generated or expelled out. That kind of questions. All right. So let's solve some basic questions on that. Then we'll go to drop and bubble questions. There is a wire of certain length on a surface gently pulled with this much force. To keep the wire in equilibrium, the surface tension is how much? The wire is horizontally placed on the surface of the water and gently pulled with that much force. So what is the surface tension? Direct question, guys. What are you going to do? F is SL or F is 2SL? Which formula will you use? Yeah. Wire of certain length is placed horizontally on the surface of water and is gently pulled by, okay. It's not a film as such. So if it is just a surface and okay, it is pulled up. Oh, now a lot of people will think I don't need the number 2, or should I need the number 2? So I'll tell you what this actual question is. So that wire, if you consider it like this, imagine the fluid surface to be here. This is that fluid surface. Now what is actually happening is that the wire
is over here and the liquid is being taken up like this. Try to visualize it, guys. You are pulling that wire on the top by applying a force like this. So, actually speaking, there is surface tension force on this side of the liquid and also on the back side of the liquid. Try to visualize this from maybe the front side. So then you will see probably the wire like this. You'll probably see the fluid surface over here and maybe, and just maybe, this film like this. It is like that. So this is how that wire is. Try to visualize. So there is one force of surface tension here and one force of surface tension here, and you are pulling it up like this by that force. Are you now able to visualize it? How many of you? Yeah. So visualization is the tricky part. Formula is very simple, nothing great about it. So you will see over here that the force will be SL over here, SL over here. So it will become 2 times of SL again. So S will be F by 2L. So my force is how much? 1.456 into 10 to the power negative 2, and 2 is 2. Length is how much? 20 centimeters. So this is 0.2. Yeah, guys. So 2 2s are 4. So it will become 1.456 divided by 4 into 10 to the power minus 1. Yeah, how much is it coming out to be, guys? Option A or option B? Let's check this out. This is 1.4. This is also almost 1.4 only. This will become close to enough to each other. Yeah. Just check this out quickly. Surface tension will be force divided by 2L. Yeah. How much is it coming out to be? B option, pakka. 0.0364 Newton per meter. Just check this out. Let's see if it is correct or wrong. Yes, 3.64 into 10 to the power minus 2. So 0.0364. Perfect. Awesome. Option B is the right answer. Very nice. Perfect. Great. You can think this is like 14, this is like 4. So 4 goes with 14, slightly more than 3 times, but less than 4 times. So it will be close to 3.5. So, or 0.35. So, but into 10 to the power minus 1. So it will become 0.035. So close enough to that. That's how you can roughly do the calculation part. Let's do the next question. A mercury drop of certain radius, okay, is divided into 10 to the power 6 droplets of equal size. If the surface tension of mercury is 35 into 10 to the power negative 3 Newton per meter, then the change in the surface energy in that particular process is how much? Now, again, just like before, I told you volume conservation you have to use. So let's say initial volume should be equal to final volume. Initial volume should be equal to final volume. For the big drop of mercury, the volume will be 4 by 3 pi, let's say capital R cube. How many drops? 10 to the power 6, guys. Crazy. Final volume will be 10 to the power 6 into 4 by 3 pi, smaller radius cube. 4 by 3 pi will get cancelled. So R cube will be equal to 10 to the power 3 into 2, or you can say 10 to the or 100 in raised to 3 into small r cube. So from this, capital R is 100 times of R, or small radius is old radius by 100. Once I get the new radius, we can figure out the change in the surface energy. So since U will be SA, therefore delta U will be S delta A, change in the area. This is what we have been asked. So delta U will be S into change in area. If you see, finally, because of many drops, there will be many small drops, so bigger area over there. There are 10 raised to 6 such drops. Each drop will have 4 pi. small r square area minus the original area was 4 pi surface area of a sphere, which is 4 pi capital R square. Obviously 4 pi is same. So 4 pi just comes outside with surface tension. 10 raised to 6 is there. This small r is capital R by 100. So it will become r raised to 2 divided by 100 square, which is 10 raised to 4 minus again r square. So r square can be taken outside. So with 4 pi. So 4 pi then into s multiplied by r square. What is left inside? 10 raised to 6 and 10 raised to 4, that is 100 minus 1, that's like 99. So 4 pi s r square multiplied by 99. Now we have to do everything in ergs or joules, which depends what we get as the answer. So 4 into 3.14, radius originally was 1 centimeter. So 10 raised to minus 2 and then whole square and multiplied by 99. Just do the math and see if you are getting the answer as 4356 microjoules. You should get the answer as 4356 into 10 to the power minus 6 joules. That's it. That is the answer, which is option C. Understood how to do this particular question? Yeah. So these kind of questions, very, very, very common, guys. All right. Then you have angle of contact and pressure difference across drops and bulbs. Let's do that. So keep this in mind. Whenever you have a fluid surface which is concave or convex like this, then the pressure always on the concave side versus the pressure on the, this is here, pressure on the convex side, it's different, and always it is more on the concave side. The pressure on the concave side minus, it doesn't matter whether the fluid is inside or outside, doesn't matter which side is the fluid part, always concave side is higher. So I'm not saying fluid side is higher or air side is higher, is given by 2s, 2 times surface tension divided by r, where r obviously is nothing but the radius of curvature, where r is nothing but the radius of curvature. Yeah. All right. Great. Next, because of this, now we can write down the formula for a normal drop of water versus a bubble which is trapped inside a water. And finally, imagine just a bubble in air. Imagine just, ayo, what just happened? Versus this is bubble in water, and finally just a simple bubble in air. So you will see that in this case, if this is P1, this is P1, this is also P1. Outside pressure is atmospheric pressure. So in the first case, P1 minus atmospheric pressure is 2s by r. In this case also, P1 minus P0 is 2s by r. In this case, inside pressure minus the outside pressure will be 4 times of s divided by r. That's the major difference. Yeah, I hope this is clear. And you can see every time inside is concave, outside is convex, concave, convex, concave, convex. Why 4s came? Because if you see closely, there is one surface which is inside and other surface which is again outside. So there are two transitions which are happening, if you notice. So this is the film of that bubble. So here it is P1, outside it is P0. From here to here, extra 2s by r. From here to here, extra 2s by r. So 2 times 2s by r, which makes it 4s by r. Concave to convex, again concave to convex. Getting my point? Yeah, how this works? Now, based on this, bubbles and drops, obviously one question, so I told you when a drop breaks into smaller parts. There are questions where you might be asked, there are two bubbles, they meet and form another bubble. This is a very common question, this and this. they coalesce and form a bigger bubble. Let's say this has some radius r1, this has some radius r2, and this has some radius r. Then in such kind of problems, what happens is the number of moles of the gas will be conserved, not the volume. So volume is not conserved. Very important, because the pressure inside is different. You cannot add volumes when the pressures are different, because when they mix, it will have a new pressure because new radius. So keep that in mind. Okay, so volumes are not conserved because pressures are not the same, since pressure is not same. But what is conserved? Moles. Moles is always conserved, the amount of matter inside. So number of moles inside N1 plus N2 will be the number of moles in the final bubble which will be there. So from this only you get our final answer as R1 square plus R2 square is R square. Looks like Pythagoras, but it is not anything related to geometry. It comes just from moles conservation, and you have to use ideal gas equation. PV is nRT, nothing else. PV is equal to nRT. So this is one common question and common formula which always comes. All right. Now the next other formula which comes is on the angle of contact and capillary rise. So any liquid which is in contact with a solid will make an angle, and that angle is called as the angle of contact. It is always measured within the liquid. So if you have this as your solid surface, your liquid inside might be making some kind of an angle over here. So this angle which is inside the liquid, because this angle also you can measure, always measure this angle, that is called as the angle of contact. Simple. Now this angle can be of multiple kinds. This is one possibility, especially with glass and water, you get the angle as acute. Sometimes the level is flat. Okay, so it's like this, and sometimes it's exactly opposite of this. So it is like this. So here you can see the angle is obtuse. Here the angle is 90 degree. All possibilities can happen for liquids touching a solid. When it is acute, it is said that the liquid wets the solid. It is hydrophilic in nature, meaning it attracts the solid and solid attracts the liquid. When it is obtuse, then it is hydrophobic. It is not going to like the solid. It repels the solid in a way, not so fond of it. And when it is neither of the two, it is 90 degrees, and it is neither hydrophilic nor hydrophobic. If you're there, okay. If you're not there, also okay. No difference. So that's when it is 90 degrees. This happens, example, water with glass. Okay. This happens when water you put it in a silver container. This happens when you take mercury in glass. So this angle not only depends on the liquid, but it also depends on the container, that is the solid. Because the same water with silver is 90, but with glass it is acute. Also, you can see the same glass is used here, but with mercury it is obtuse, with water it is acute. Okay, so this is basically the angle of contact concept, and it happens because either the cohesion is bigger or adhesion is bigger. Cohesion is between the water molecules or the liquid molecules. Adhesion is between the liquid and the solid molecules. If it so happens that the adhesive forces are stronger than the cohesive forces, meaning the solid attracts the liquid better than the liquid attract each other themselves, then it is acute. That means it is philic, it loves it, it has affinity towards the solid. When the adhesive forces are much weaker than the cohesive forces, so the liquid molecules attract each other better than what the solid would attract them, then it makes an obtuse angle. So it is hydrophobic. It does not, the solid does not love the liquid over there. And in this situation, then you will see that it has equal amounts of cohesive and adhesive forces. So there is no benefit of either of them. So neither does the water go up nor the liquid comes down. So it makes a flat surface over there. That's the concept behind it. This angle of contact can change If you adulterate the liquid with something, maybe you add some dirty water, this theta will change. With pure water, it is usually 0 degrees or 1 degree around that. But if you make that water contaminated, then it might go to 8 degrees, 9 degrees, 10 degrees also. But still, you can approximately take it very small angle. Okay. If you change the temperature also, things can change. All right. So for water, silver, all these things are mentioned over here. Now, this is the reason why the water also rises in a small tube. And if you have a small tube like this, and this is the water outside, you will see the water inside the tube will rise like this. So water inside the capillary will rise. So this is basically the height rise in capillary effect, and that height rise is 2 times of the surface tension multiplied by cos theta divided by rho gr. 2s. So 2s is there. S is surface tension. You can also use T. Nothing matters. So 2s cos theta by rho gr. Very, very important. If g changes, it will change. If the radius of the tube, this r is basically the radius of the tube over here, by the way. Okay. Radius of the tube becomes smaller, height becomes larger, and that's the principle by which the water is being sucked by trees using this surface tension phenomena. There are small, small tubes called as capillaries, which are like their veins, you can say. And because the radius is very small, water automatically climbs up from the roots of a tree to the leaves and branches and all of that. Okay, there is another reason, osmosis and all of that. We are not discussing that. Okay, what happens if the tube is at an angle? Still, the answer will remain the same. So even if the tube is, let's say, at an angle like this, you will see that the liquid inside of it will still go to the same height. Okay, so the height will always remain the same. Yeah, the length here will change. The length here will definitely change. Okay, great. Generally, theta is 0, so cos 0 will be 1 for water with glass, but otherwise, if theta is different, then obviously you have to find cos or sine values. Now, for water with silver container, theta is 90, so cos 90 will be 0, so the water will neither go up nor go down, it will be flat. But if you take mercury, in such situations, because it is an obtuse angle, you will see that the liquid will actually end up going down. So there is a dip in the level. So keep that in mind. Okay. So let's now solve some questions coming up on your screen. There is a capillary tube of radius 0.1 millimeter which is partially dipped in some liquid. Okay, surface tension is so much, glass water angle is 0 degree with 30 degrees inclined with the vertical. The length of the water resin in the capillary tube is how much? Okay. The Sigma crash students will get the Sigma batch access. It should be there in additional content. There might be something, or just check the past sessions. Okay, or I'll do one thing. I'll make a small video on how to access it and I will post it. Okay. Yes, man, CYQs will work, and that is the promise that we do. We never under deliver. Sigma batch students, Sigma batch has been the best batch ever, and you can see that all our Sigma students extremely happy, extremely attentive, scoring well, and best part is I'm seeing many students who joined in June also, or in May, April, not April, in May, June, their scores have drastically improved. And even when students joined in the month of November, when we launched the Sigma Crash, there were a couple of kids who were at 50, 60 marks. Now they are at least getting 120, 110 marks. And I was seeing the entire Excel sheet, and that transition which has happened is massive. And the simple reason is because they're attending the class. If somebody is not attending the class, not doing anything, the data is also seen that barely they are giving the test, not improving the scores. So the moment they are attending the classes, the moment they are giving the tests and working on themselves, there is a massive change which has happened in all the kids. And there are many kids right now who are scoring above 200 also. So just through this batch alone, they are not even attending any offline classes, because I know that some of them, if they are attending the classes continuously, that means they are not joined any other offline batch, or at least even if they are paid, they have not attended that batch. So that's a really commendable thing, and I'm pretty sure this year in JEE mains and in advance, so many selections are going to happen, and that too only from the Sigma batch. Yeah. So let's see. What about this? Everything 30 degrees inclined with the vertical. So first of all, keep this in mind. It's inclined. The height rise will be the same. It should be the same. So the actual height that you should consider is h, whereas inside the tube it will be L, and 30 degrees with the vertical. So that is this. So length of the water inside the capillary, this is L, and you can see that cos 30 degrees is h by L. So L will be h by cos 30. So that is cos 30 is root 3 by 2. So 2h by root 3. But what is h? H is 2s cos theta by rho g r. So 2 2s are 4 by root 3. Okay. S is surface tension, which is how much? 70 dynes per centimeters. Okay, so we'll take everything in centimeters, into cos theta. Theta is 0, so cos of 0 degree divided by density of the fluid. What is the density of the fluid? Is that water? Yeah. So water's density is 1 gram per cc. G is there and radius is there. Radius is in 0.1 millimeter, which is 0.01 centimeter. What about G, guys? 9.8 meters per second square will be 9.8 meters will be 9.8 into 100. Okay, correct? Centimeters per second square. So it will become 980 centimeters per second square, CGS unit. So this will be 980. That's all. So solve this. Root 3 value is 1.732, and you will get an approximate answer right over here. Just see if you are getting it as 16.49 centimeters. Yeah, 16.49 centimeters. Okay, over here. So from that, you have got the value of the length. But 16.49 is almost how much out of these numbers? Out of these numbers, which value will you mark it? Sir, can I listen to this session if I have some basic knowledge about few chapters? Yes, we are doing all the topics, most of it, bearing very few low weightage topics. Yeah, so we are doing literally everything. Yeah, guys. So which answer will you mark then? In this case, because they have given the answer not in decimal places, but in, these things. So 57 by 2 ruled out. 82 by 5 almost, because 18 5 is 60. 68 by 5 no. 71 by 5 no. So I think almost like close enough to option A, you can say. Yeah, great. Taking a drop. Man, Arivasu, don't tell such negative things. Yeah, there is nothing to be afraid of, my dear. So please stop saying such negative things about yourself, because it really, uh, honestly, I feel that you should not be taking such, uh, such deep thoughts at this age. Okay, because I'll tell you one thing, man, that Arivasu, JEE is just an exam, and I'm not just saying ki, okay, fine, because you are saying such negative things, sir is saying that. Obviously, as a teacher, obviously, as a student, our goal will be to crack the best of the best. And always there will be somebody who will get all India rank 1, somebody will get all India rank 100 also, somebody will get all India rank 1 lakh, 10 lakh also. So if you ask me, what are those all India rank 10 lakh students doing now? After 10 years, 5 years, 20 years, are they doing nothing? Have they lost everything? Have they, you know, become complete losers? Absolutely not. They are doing pretty well. And I know many of my friends personally who did not even clear the basic, means got barely anything and still doing very well in. So getting into IIT makes things easier, obviously, but not getting into IIT does not mean it is the end of it, right? So don't be demotivated. I know some sessions like these, you might feel I have to study so much and I have barely studied anything. You blame yourself. I agree, you are to be blamed, but does not mean that you have to, think so negatively. Okay. So cool down, calm down, work as much as you can. Maybe you might not think of 99 percentile, but at least you can get 95 percentile. No, I think you can. Try that. How cos zero? Because contact angle is given. Yeah, contact angle is given. Yeah, amazing. Okay, shall we go ahead, guys? Karthik, I'm really sad to hear that your friend took such a drastic step, and it must be heartbreaking for all of his friends and family members. And it's definitely not needed, guys. If you think about it, in the future, you feel that, oh, such negative things, yeah, this can happen, that can happen. But let me tell you, nobody knows the future. Nobody knows the future. Yes, you can look at the past and you can always tell, oh, I shouldn't have done this, I should have done that, this should not have happened. Past is very easy to be judged, but the future, guys, future is in your hands. And a lot of it is also in God's hands, the nature's hands. Yeah. So leave it up to them, but you do your hard work. You will see miracles will happen. Not everything can change. You might be not even an IITian. Something will happen someday because of which something else will happen. Because of that, something else only will happen. And then you will do so well in life. And then you will start connecting the dots, looking at the past. Oh, why did I become so successful? Oh, maybe because of that thing, because of that thing, because of that thing. So you just don't know what miracles God is planning for all of you. Got it? So believe not just in yourself, believe in the superpower, believe in the nature, believe in God. I'm pretty sure everything will happen the right way. And even if something bad happens, it's maybe for something else. Bad today might be for something good, which happens tomorrow. All right. So let's go ahead to the next concept of viscosity. Wow. Wow, wow, wow. Guys, there are crazy number of slides. I'm doubtful whether it will happen before 7:30. And then we have 12th also. So worst case, worst scenario, we'll do one thing. We'll just do 11th standard marathon today, and then we'll take up a 12th standard marathon separately if I'm not able to proceed much ahead. Okay. All right. I'm so glad, Arivasu, you said that. So glad. Okay. So viscosity, when liquid is in contact, liquid solid is in contact, that friction which resists that motion is called as viscous force or drag force. It's not like the solid contact, which is then called as friction. So when two solids are in contact, the resistance is called frictional force. But water flowing and boat is going or a ship is going on water, that friction is then called viscous force because the formulas, the behavior is completely different. So you cannot say mu n is friction. No, it's completely different. And this viscous force is obviously a non-conservative force like friction. Yes, it also depends on the nature of the fluid. It also depends on the temperature of the fluid. So if the temperature rises, usually you will see for liquids, the viscous force reduces. And if temperature rises for gases, it is usually going to increase the viscous force. So it is very different in behavior for liquids versus gases. So I'll repeat. I think it should be there on the next slide somewhere. Or is it? No. Okay, so when temperature increases, okay, then then the viscosity, then the viscous nature, depending on whether it is a liquid or a gas. For liquids, it reduces. For gas, it increases. This is very important. And the reason for that is because for liquids, viscosity comes because of the molecules bonding each other by cohesive forces. So the bond will weaken. So because of which the viscosity reduces. But for gases, the viscous nature is because the molecules are moving randomly, colliding with each other. So that is why that viscous force comes. So that's why you will see when temperature increases, viscosity increases because of more collisions happening in the gas molecules. Now, usually, uh, to discuss how much is the viscous force, Newton gave a simple formula. Newton is there everywhere. So, he observed layers of liquid. So, and he saw that layers of liquid, when they are sliding each other, what velocity they are moving with, how much force is needed to pull them, and all of that. And then he gave a beautiful formula, which is F is eta A delta V by delta Z, whatever you want to call it, delta V by delta X or delta V by delta H, where, for example, this is one layer of the fluid, maybe this is the next layer of the fluid, maybe this is the next layer of the fluid, maybe this is the next layer of the fluid, and all of that. So like this. So we'll see when you are applying the force from the top, okay, when you're applying the force from the top to slide these layers of the fluid, that force depends on how much area are you pulling, how much area are you pulling, also depends on how fast the velocity is changing with height. Meaning over here at this point, let's say the velocity is this much for this particular layer. At the next point, the velocity is slightly higher. So here if the velocity is v, here it is v plus delta v, and this happened when you change the height by some delta z. So this term of delta v by delta z is called velocity gradient. This is called velocity gradient. How quickly the velocity changes from one layer to other with height difference. So that force is eta A dv by dx. This eta is called constant, which is coefficient of viscosity. So it tells me how much force is needed. Basically, if eta is more, area is more, or velocity gradient is higher, I will need more force to pull it. Okay, it is highly viscous in nature then. It's very difficult to slide those layers. And whenever liquids slide, you will see they slide in layers, even inside pipes, in canals, in rivers, in oceans. There are layers of fluid which keep on sliding over each other. So fundamentally, this is the law which is applied on every layer to layer of the liquid which is sliding over each other. Okay, great. All right. All right. Okay. Yeah. What about the timeline of this video and all of that? Guys, there is one simple thing I'll tell you. See, even when you're watching this particular video, right now, hmm, after some time, by 1 day or 2 days, with AI, our AI will understand the video, everything, and it will make its own timestamps. It will create its own notes. It will create its own question bank. You can ask with everything, not just doubts. You can go to the description. You can ask a doubt right now also in this class as you are watching it live. Even after the class, any doubt you ask, you will get an answer. I think somebody has asked some question. I don't know what this is. I can't open it, but yeah. So, uh, you can interact with Ved and it will generate smart notes and even quizzes. So, hey, Ved, please help me with more questions on, drops merging, or more questions on energy released when drops break in surface tension. Ved will help you. So that's the best part about Ved, and thousands of students are right now using Ved. Okay, so you can also use right now. Great. All right. Next, if you take a liquid drop, if you take a liquid drop whose radius is r and which is right now, let's say, moving with some velocity inside a fluid. then it will experience a force which will oppose that motion. That is the drag force. That drag force is given by 6 pi viscosity coefficient into radius into the velocity. This is called as the Stokes law. So any spherical body of radius r moving with speed v experiences a drag force 6 pi eta rv. This comes after using this particular law, Newton's law, and using some complex differential equations, then you get this particular law. We don't have the derivation entire JEE syllabus, okay? But yeah, you should know this. Obviously, it should make sense. 6 pi is coming. Pi can come only from either derivatives or integration, and that to some inverse trigonometric functions. Yeah. Okay. So keep this in mind. Now, this concept is used in terminal velocity, where imagine water drops from the clouds are falling down. So what happens? It is experiencing its weight and buoyant force, but the weight of the drop is more than the buoyant force. So that's why it goes down. But what happens as it moves down is that this drag force comes into play. And you can see it is directly dependent on the velocity. So initially, velocity is negligible, so drag force is negligible. But as it increases the speed, the drag force becomes significant. And after a point, you will see the drag force with the buoyant force together, the drag force with the buoyant force together is balancing the weight. So there is no net force on the drop. And that's why the drop goes down with constant velocity. That is the final speed which the drop will achieve, after which the speed remains constant. So that's why it is also known as the terminal velocity of the raindrop. And in a way, it is good for us because else, without the drag force, the raindrops would have accelerated continuously and the raindrops would fall on humans at a very large speed. That would have killed us all instantly because you cannot experience such large water force. So the speed is reduced by drastic amount because of the drag force. That terminal speed comes out as 2 by 9 r square in the numerator with the difference of the density into g by eta. Eta is the viscosity coefficient, g is acceleration, r is the radius of the drop. What is this difference? It's basically the difference of the density of the drop, which is the circle, that sphere, and the difference of with density of the liquid or the air surrounding it. So that ball, that drop, that sphere density minus the outside density. So that difference will come over here. So remember this formula. Also, the graph is very important over here. So if you draw the graph of, let's say, velocity with the time, that graph looks something like this. And eventually you will see it will reach this terminal velocity over here. Yeah, it slowly stops increasing the speed and becomes constant. All right, keep this in mind. Okay, so let's see some of the questions coming up on your screen. When the temperature increases, the viscosity will, come on, my dear warriors, very straightforward. Gases decreases, liquids increases, gases increases, liquids decreases, both increase, both decrease. Yeah. For gases, it will increase. For liquids, it should decrease. So I think it should be B option. Cool. I just told you. For gases, randomness increases. So more difficult to move that in that gas. But for liquids, it's not about the random motion, but the bonding between the molecules reduces, it weakens, reducing the viscosity. Is that clear? Yeah, very good. Option B. Next one on your screen. There is a solid steel ball of some diameter with some speed falling under gravity through an oil of density this much. Take density of steel as this much and G as 9.8, then the viscosity of the oil in SI unit is. This is a purely numerical problem. That's all. So our terminal velocity is 2 by 9 r square difference of the density into G divided by eta. They have asked what is the viscosity of the oil. So eta will be 2 times of r square multiplied by sigma minus rho into G, whole thing divided by 9 multiplied by velocity. So I have to just substitute. So 2 multiplied by radius. Radius is not given, diameter is given. 3.6 millimeter means 1.8 into 10 to the power minus 3 meters. So put 1.8 into 10 to the power minus 3 meters square. Difference of the density 7825 minus oil density 925 G, which is 9.8, whole thing divided by 9 into velocity. Velocity is 2.45 into 10 to the power minus 2. So that's all. So solving this, you will get the answer. Okay. Yeah, you'll get the answer. I think as 1.99. Yeah, 1.99 has the answer, which is option D. Okay. I think you can do this calculation. No, it is not B, it is 1.9. Great. Okay. Thermal properties of matter. We are already at 7:15, 7:30. We took a break at 4 o'clock, 4:15. So we'll do one thing. 3 hours are over. We'll take a break. Looks like after thermal properties, KTG, thermo, then we have oscillations, then we have waves. So it will again take minimum 3 hours. And YouTube has a limit of 12 hours. I can't extend the lecture beyond 12 hours, even if I want to, even if I'm alive. So looks like we'll have to do only 11th today, but it is okay. Whatever we are doing it properly. So I'm very happy about it. We'll take one more marathon. Shreyas Sir is ready for one more marathon. Okay. So I will take a half-hour break. I'll just have my dinner and you also have your dinner and we'll meet at, what is the time now? 7:20. So around 8:50 or something. Sorry, 7:50. My bad. 7:50, 7:55. We'll meet and we'll continue with the class. Okay? All right. See you.
All right. So let's begin with the class. Welcome aboard, welcome aboard, welcome aboard. I hope I'm audible and visible to all of you. I hope you guys had your dinner. Yep. Fully energetic, recharged, ready to go. Okay. So till now, we have completed unit dimensions, kinematics, everything, mechanics, work per energy, collisions, center of mass, rotation. We also did, you know, uh, gravitation. We also did fluids, viscosity, surface tension, solid mechanics, all of that. Now it's time to go on to thermal physics, KTG thermo. Then we'll go on to uh, oscillations and then waves. So that's the flow of today's lecture. Yeah. All right, Chad. Welcome, Weekend Vlogs. Navinesh, Rivas, Varsu, welcome. Done with my dinner. Watched previous recording. All right, not an issue, but shows your enthusiasm towards completing the syllabus. And Lewis Hamilton, I'm so glad that you are made up your mind to get All India rank 1 with your captain Shreyas in JEE 2030 and such a young warrior out there. Okay, so let's begin. Let's begin. Second year, we'll do it after 3 days or 4 days. Okay, so I think already maths and chemistry classes are scheduled. So after that, I think we will conduct the physics class for second year, second PUC or whatever you want to call it. Okay, so let's begin with the class and starting off with thermal properties where we begin with the temperature scales, their conversion factors. Now, standard numbers which you need to remember for Celsius, Kelvin and Fahrenheit. See, water freezing point is 0 degree Celsius, boiling point is 100 degrees Celsius. But in Kelvin scale, it is 273 for freezing and 373 for boiling. Now, because Kelvin is an absolute scale, so 0 Kelvin is the lowest possible temperature, but in Celsius, it will become minus 273. And the conversion factor is simple. So the Kelvin scale is whatever you get in degree Celsius, you add 273 to it. That's all. Simple, math. Room temperature is 27 degrees Celsius, which makes it 300 Kelvin in Kelvin scale, which is the most commonly used temperature because 300 is a better number than 273. Most of the times you will see 27 degrees Celsius in many problems. Whereas body temperature is 37 degrees Celsius, 10 degrees more than the room temperature, which is at 310 Kelvin. Okay. Whereas in Fahrenheit scale, you should know this, it's 32 degree Fahrenheit for freezing and it is 212 for boiling of water. Okay, and 98 is the body temperature. Usually you use for body temperature 98 Fahrenheit. Yeah, and that's the usual body temperature that you have. If you want to convert between Celsius and Fahrenheit, the logic is simple. You take the Fahrenheit value and subtract 32 from it and multiplied by 5 by 9. You get your answer in degree centigrade. Simple. So Fahrenheit minus 32 kind of makes sense because if Fahrenheit is 32, 32 minus 32 is 0, you will get the answer as 0 degrees Celsius. That's how easy it is to remember it. Okay. And if you forget whether it was 9 by 5 or 5 by 9, simple. See, with Fahrenheit, what is the symbol of, sorry, what is the, spelling of the number 5? F-I-V-E. So F-I-V-E. So 5 with F. That's how it goes. So easy way to remember that. But if there is some random scale and you want to convert it to some other random scale, then the logic is using 2-point slope form where let's say there is a scale which is in degree x and there is another scale in degree y, and let's say you know the boiling and the freezing points, you know the boiling and the freezing points. So this is boiling, so let's say this is, sorry, freezing, this is let's say degree x1, this is let's say degree x2, this is freezing in y which is degree y1, this is boiling in y which is degree y2. Then you can figure out any basically I would say temperature in any other scale, and the logic is
So if this is x and let's say this is y, the logic is simple. Use y2 minus y1 upon x2 minus your x1 is equal to y minus y1 upon x minus x1. You will know y2, y1, x2, x1. Either you will know x or you will know y, and you will be asked to find the other thing. That's all. That's the logic behind these questions. Very simple and very straightforward. There is nothing much to it. So for example, let's say they give you a problem where they tell you that, you know, let's say 10 degree Celsius is, let's say, minus 40 degree Pandu for freezing. Okay, or just chumma they could tell 10 degree Celsius is minus 40 degree Pandu. And it is also known that 90 degrees Celsius is, for example, let's say, 120 degrees Pandu. Now, question is find, say, for example, if it is, let's say, 50 degrees Celsius is how many degrees Pandu? That is the question. Okay, that's the question. So anytime you get such a question, first convert it into this form. You need not have to draw this. It's just for your reference, guys. So say for example, on the x-axis, it is a degree Celsius. And on the y-axis, it is degree Pandu. So Celsius wise, basically, I know 10 degrees Celsius is minus 40 degrees Pandu, and 90 degrees Celsius is 120 degrees Pandu. So the question is, if it is 50 degrees Celsius, then how much degree Pandu it is? Let's say I call it P. So just simple formula, y2 minus y1, that means 120 minus minus 40 upon x2 minus x1, which means 90 minus 10, is y minus y1, that means P minus minus 40 upon x minus x1, that means 50 minus 10. So this will become nothing but 160 divided by 80 is equal to P plus 40 divided by 40. 160 by 80 is 2. 40 goes 2 times and P plus 40. So 42 is 80 and this will become minus 40 is P. So P will be nothing but 40 degrees. So 40 degrees Pandu is the correct answer. So 50 degrees Celsius is 40 degrees Pandu. Got it? Yeah, everyone? What is the minimum range of MA means? I didn't get your question, man. What is the minimum range of marks I may get by watching this session? 1000 or see, there is nothing like this session or that session. But if you're practicing every day like this, the way I'm practicing or the way I'm revising, then if you keep following these classes, you improve your performance and you are solving on your own also. Self-study is important. Then there is no reason why you should get below 200 marks. I don't see any reason. 200 is easily possible out of 300, which means 99 percentile for sure. Okay, because students have done it last year, so this year also should not be different. All right. Now, once you understand that, you have the concept of thermal expansion where you heat up that liquid, solid, gas, whatever, because of which it will expand. And how much it expands is given by a simple formula. The final dimension is the original dimension into 1 plus a parameter which defines that expansion into the change in temperature. Either the length will change, or the area will change, or the volume will change, any one of them. Formulas look very identical. Final volume is initial plus 1 plus gamma delta T. Final area is initial area 1 plus beta delta T. Final length is original length 1 plus alpha delta T. Only this parameter alpha, beta, gamma will change. What are these? They are called as coefficient of linear expansion, coefficient of superficial or areal expansion, and coefficient of cubical or volume expansion. That's all. So from this, you can find out any literally final volume, final area, final length. You can also rearrange these terms and you will see that if length is taken onto the other side, you will see actually this is the formula delta L is alpha or rather original length alpha delta T. Similarly over here also you will see change in area is original area into beta delta T. Here also you will see change in volume is original volume into gamma into delta T. This is something which you can easily notice over here. Now this alpha, beta, gamma depends on the material, what kind of solid, liquid, gas it is. But any case, beta will be double of alpha. Beta is double of alpha. And this gamma is triple of alpha. So volume, 3 dimensions, is 3 times the linear dimension. So simple. Gamma is 3 times of alpha, beta is 2 times of alpha. Very straightforward. Now you use this in many questions like, for example, like one such example is where you have two rigid supports and you have a rod or something whose length, area, Young's modulus, thermal expansion, everything is given. And then it is being told that it has been heated. But what happens is because the supports are rigid, the rigid supports prevent the expansion. They will prevent any kind of expansion. And because of which, what happens is there will be a force from here and force from here. That force will be compressive in nature. So there will be compressive force from both sides. And that force per unit area is then called as the thermal stress. Sigma is for stress. It's a stress which is being created because temperature is increased. So it wants to expand, but you can't expand it. So there is a stress which is developed, which is compressive in nature. This is simply Young's modulus, linear coefficient of expansion into the amount of by which you have increased the temperature, Y alpha delta T. So that's the concept of thermal stress. Okay. Okay. Perfect. Yeah. Very rightly said, Arivasu. What matters is what you do in the 3 hours of that actual exam, but also what matters is how you plan for those 3 hours in these hours. Okay. Next important thing that you should remember. Yeah, the pendulum case where you might have a simple pendulum and length L. Okay. And it is made to oscillate. Now the usual time period formula is 2 pi root of L by G when that pendulum will oscillate back and forth. But it's quite possible the length change because of the temperature change. So if you write down delta T by T over here, the power of length is half, so L raised to half. So using the concept of errors, this will become half times delta L by L. So this is as good as saying delta L is original length into alpha into delta T, but I don't want you guys to be confused between time and temperature. So that's why I'll use delta theta by L. LL cancels, so it will become alpha delta theta by 2 is how much time period will change relatively. So here delta theta is used because I don't want to get a conflicting or confusing result. Okay, because this is time, this is temperature. Okay, so keep that in mind. So this is relative change in the time period of oscillation, and this delta theta is just how much the change is there in the temperature. So this is another type of model of question which usually comes from thermal expansion. Then there is one more kind of thing which you should know, which is apparent expansion, where you might have a container and you might have some fluid in it and you have heated it because of which the container also expands and the liquid inside it also expands. So what you might see is not the real expansion, it is the apparent expansion. So if somebody ends up measuring how much is the change of volume, this is change of volume which is apparent or which is measured. Usually you will say it is the original volume into gamma into delta T, but this gamma will be apparent gamma. It's not the real gamma of the liquid. And this apparent expansion will be gamma of the liquid minus gamma of the container or the vessel. This is what that apparent gamma will be, okay, in most of the scenarios. Okay. Lastly, there might be some liquid, and you are expanding it, because of which the density will change. So how much is the change in density? That formula also comes. So we know that the volume will be original volume into 1 plus gamma delta T. That's okay. So this is some liquid and you have heated it. Okay, you have heated it. So volume will change accordingly, but how much will the density change? So density change formula is very much similar. It is original density upon 1 plus gamma delta T. But usually gamma is very small and delta T is also not that big. So if you write it in negative powers and use binomial approximation, this formula approximately becomes rho naught original density 1 minus gamma delta T. That's how this formula becomes. This is approximately, keep that in mind. This is exact, but most of the times you'll be using approximate only. Okay. All right. Very good. Great. Great. Awesome. Keep this in mind. Okay. Yeah, I will explain Newton's law if you want to. Don't worry, man. Yeah, don't spam. Just put once I can read it. All right. Yes, definitely. My support is there. God's support. It depends on you, Kaushik. And I'm pretty sure if you are working hard, God will also support your hard work. In the Equal test series, I am from the pro batch. Now I have written 2 full test marks. My first test is 200, second is 230. Wow, that's amazing. Sujanti, amazing, amazing, amazing. Really good. I hope it crosses 250 very soon, consistently. Okay. So let's probably, before doing some questions, this is there, phase changes and all of that. So there you have specific heat capacity, latent heat, and all of that. So there are three phases: solid, liquids, and gas. So when you convert from gas to liquid, liquid to solid, or vice versa, you need to supply some heat. So in such scenarios, whatever is the heat supplied for the phase transformation, phase means solid, liquid, gas. These are the three phases. That heat per unit mass is called as the latent heat. And you will see that the latent heat for ice to be melted into water is 80 calories per gram. So if you get 80 calories to 0 degrees Celsius ice, it will convert into 0 degrees Celsius water. Phase will change. Same way, if you take water at boiling condition, 100 degrees Celsius, but you want to convert it into steam, you will have to give it 540 calories so that it converts into vapor. The reverse also holds true. If you have steam at 100 degrees Celsius, it condenses to water boiling, then it gives out 540 calories. You can use that heat anywhere else. And the same is also true for water to ice. It will give out 80 calories per gram. So that heat of transformation, Q, is nothing but mass multiplied by L. This is your latent heat. This is the heat during phase change. Phase change. Now, please keep in mind, whenever phase change happens, temperature is always going to be constant. You will never see water is boiling. The water which is still not converted into steam is at 99 or 100, but the steam which is converted is at 101 or 102. No, the entire water plus the steam will be at 100 degrees Celsius until the last drop of water converts into steam. Once all the water has converted into steam, then you will see the entire steam, which is at 100 degrees Celsius, might go up to 101, 105, 120 also. So steam does not mean it will be always at 100. It can be at 150 degrees Celsius also. Same way, when water freezes into ice, until the last drop of water freezes to ice, neither the ice nor the water will change the temperature from 0 degrees Celsius. Once the last drop converts into ice, then the ice can go to negative temperatures like -5, -20, -100 degrees Celsius as well. And the same also holds true for melting. So until the last bit of ice melts, the temperature remains 0 degrees Celsius. So you might see some situation where there is partial ice, partial water, both of them are, at 0 degrees Celsius. Eventually, everything will melt. And once it melts, that 0 Celsius water might go to 10, 20, 50 degrees Celsius. Got it? So this is a isothermal process. Temperature is constant. But once it is converted into water or steam or purely into solid ice, then the formula cannot be used, which is Q is ml. Then you have a slightly different formula, and the formula is the heat which is supplied is ms delta T. This S is called specific heat capacity. Specific heat capacity. M is the mass, S is specific heat capacity, delta T is the temperature change. As you can see, this is within a phase. So heat within a phase is given by Ms delta T. Sometimes you will not use this. So guys, let me tell you, this is mainly for solids and liquids. But you will see for gas, you will use N small c delta T. Okay, this is mainly for gases. This is called molar specific heat capacity. Molar specific heat capacity, because it is in moles. Because this is in moles. N stands for moles, M stands for mass. So for gases, usually you will use this. For water, solids, generally you will use Ms delta T. Now you should know that, okay, for ice to water, water to steam, we know how many calories are required per grams. But same way, what is S value for water? So the value of S, specific heat capacity for water is 1 calorie per gram degree Celsius. In fact, the unit of calorie came from water. How much ever heat is required to raise the temperature of 1 gram of water by 1 degree Celsius from 13.5 to 14.5, that amount is called as 1 calorie. Okay, so that is calorie unit. Now, sometimes you might also do one thing. You might also write Q is equal to M into S. You can use a big symbol S delta T. This is no longer specific. It is just called as heat capacity. It is just called as the heat capacity. As simple as that. What is it called? It's just called as the heat capacity. Great. So these are the basic things about thermal physics which everybody should be aware of. Let's do a question based on this. Consider a rectangular sheet of solid material. Length is so much, width is so much, linear expansion is given, room temperature and atmospheric pressure is also given, the mass is also given, specific heat capacity is also given, the amount of heat supplied is also given, just change in the area of the rectangular sheet. So if you want to find the change in the area, then delta A will be the original area into beta into delta T. Now the original area is not given, but the length and the width are the given. So length into width. Beta is also, I think, not given. Alpha is given. So beta is nothing but 2 times of alpha. Change in temperature is not given, but we need to find that bit out. So therefore, change in area will be length, which is 9 centimeters, which is 9 into 10 to the power minus 2, d, which is 4 centimeters, so 4 into 10 to the power minus 2, to alpha. Alpha is also given. Alpha is 3.1 into 10 to the power minus 5 into whatever that temperature changes. So how do I find the temperature change? For that, heat supplied is given, and heat supplied is M C delta T. Heat already given as 8.1 into 10 to the power 2. Mass of the sheet 0.1. C or S, whatever you want to call. Okay. Specific heat capacity 900. So I'll put 900. Everything is in SI. So into delta T. So from this, I'll get delta T as 810 divided by, this will be 90, I believe. 0.1 into 900 is 90. 0 cancels. 81 by 9 is again 9. So change in temperature is 9 degrees Celsius or 9 Kelvin. So you just have to then simply multiply it by 9. That's all. So eventually we'll multiply it by 9. So from that, you are obviously going to get how much is your change in the area. Got it? Yeah? Straightforward, everyone. So you will get the answer as 2 into 10 to the power minus 6. So you should get the answer as 2 into 10 to the power minus 6 meters square. Okay, which is option A. Which is option A. Perfect. Cool. Yeah. Sometimes there are another kinds of question modules, like say for example, you are given, say, 20 grams of water at, let's say, 0 degrees Celsius is mixed with, for example, 40 grams of liquid at 50 degrees Celsius, whose specific heat capacity is 2 calories per gram per degree Celsius. Question is, find the temperature of that final mixture. Find the temperature of that final mixture. How do you do these kind of questions? They are essentially going to use these formulas, but there is one principle which you need to know, and that is basically the principle of calorimetry. The principle of calorimetry. So when two or more liquids, gases, solids are mixed, then somebody will be hot, somebody will be cold. So the heat which is lost by the hot body will be heat which is going to be gained by the cold body until the temperatures become equal. So not any random time or not any random heat. So till temperatures are equal. Basically, thermal equilibrium is achieved. Thermal equilibrium is achieved. It kind of makes sense. Cold water mixed with some another liquid, their final temperature will be a common value. After that, it will not change inside a calorimeter, which is a device which prevents any flow of heat or energy or mass from inside to out or outside to in. So use that principle of calorimetry, and you will notice very quickly that it is the water which is cold, so it will become hot, and it is that liquid which is hot, so it will become cold. So heat lost by the liquid is heat which is gained by our water. So this is the opening statement. I have used principle of calorimetry. How much is the heat gained by water? It's nothing but the mass of the water, specific heat capacity of the water into change of temperature of the water. How much is the heat lost by the liquid? It is the mass of the liquid into specific heat capacity of the liquid into change in temperature of the liquid. Okay. Do I know the mass of the liquid? Yes, it is 40 grams. Specific heat capacity 2. Temperature change. Well, think about it like this. The liquid was at 50 degrees Celsius. The water was at 0 degrees Celsius. The final temperature of that mixture, assume it as X. So this is what the change will be for the liquid. This is what the change will be for the water. Somewhere in between it will come. So when you calculate the temperature difference, never make it x minus 50 because that will be negative number. Rather make it 50 minus x. So this will just become nothing but for the liquid 50 minus x. And for the water, it will become x minus 0 because x is bigger than the value of 0. Mass of the water is 20. Specific heat capacity standard for water, it is 1 calorie per gram degree Celsius. You don't have to uh, be given that value. You should know that value by heart. Okay, it is expected. So from this, you can see that this will become 40 into 2, or 0, 0 will cancel. 4 2s are 8 into 50 minus x is 2 into x itself. So therefore 8 5s are 40. So 400 minus 8x is equal to 2x. Therefore 400 is equal to 10x. Therefore x is equal to 40 degree Celsius. That's the answer. Got it? No, not 10 by 3. Yes, Vicky 18. Yeah, it's the answer is 40. No chat, it's not 40, 10 by 3. Okay? Yeah, 40. Yes, Kanmanir, I will be taking CBSE board classes, but after JEE, not before that, because right now the complete focus is purely on JEE. Okay? This is mainly a JEE channel, and after that, we will concentrate on boards. So please remember that JEE cannot be compromised, because April attempt is a fake attempt. It's a pseudo attempt, because you won't get time to prepare for it, because you will be completely involved in boards. By the time you again come back, gone. Now you have the momentum, use it for JEE preparation only. Boards will happen, man. Boards, don't worry. You will pass. You will get more than 75 only. Okay? Yeah. So these kind of questions do come based on phase transformation and all of that. Okay. Then once this is done, it's time to move on to next chapter, which is heat transfer, which is conduction and radiation. Convection is not so much. Okay. Heat conduction. So whenever you take a rod or a solid, generally, basically what happens is one side is hot and one side is cold for some reason. The heat will go from the hot side to the cold side, and the heat will start flowing depending on how long the rod is, or the material is, what kind of material it is, and what is the difference of the temperature. So if you have a material which looks something like this, it has a thickness of L, it has an area of cross section, it has an area of cross section of A. So then whatever heat enters inside will also exit out. Heat in will be going out, and the rate at which the heat flows depends on the area and the temperature difference and the length. And this heat which is flowing, this heat which is flowing per unit time, is also called as the heat current. The heat current, this is also called as the heat current. Okay, this is nothing but dq by dt. That particular dq by dt is nothing but a constant into area into the temperature difference divided by the length. Temperature difference means maybe this side is hot, maybe this side is cold. So TH minus TC is our temperature difference. That's what it is. So if you take a very small thickness, then it will be dx, small temperature difference dt, then dq by dt will be K8 dt by dx. So dt by dx is also called as the gradient of temperature, meaning how much does the temperature change when I move inside that material by dx amount. That's called as temperature gradient. Why is this negative sign there? Because the heat will flow from high to low. So wherever the temperature will decrease, that means dt should be negative, then negative into negative will be positive. That means the heat flow rate will be positive. So heat flows in the direction of hot to cold, not from cold to hot. High to low, not low to high. So that's why that negative sign is there. Okay, and K is called as the thermal conductivity, which is a property of that particular material. So if it is more conductive or less conductive, accordingly K will be bigger or smaller. More conductive, it will be larger. Less conductive, K will be smaller. Simple. Okay, so that is the logic for it. Yeah. Okay. So heat flow current, and I should also mention this: heat will always flow in the direction of hot to cold and not the other way around. Now, usually what happens is, in specially conduction, you can convert these rods into resistances. So if you have this particular rod of certain area, let's say A, and length L and conductivity K, then you can say that this can be converted into a resistor, and this is often called as the thermal resistance. And that thermal resistance is simply L by Ka, is nothing but L divided by Ka. And the logic is that if you use Ohm's law in electricity, which says that the voltage difference is current multiplied by resistance. In here, the equivalent of Ohm's law is the temperature difference is the thermal resistance multiplied by the heat current. So the thermal resistance being L by Ka, heat current being dq by dt, and this being delta T, you can very quickly see K goes on the other side, length comes below, which gives me back my equation, Ka delta T by L. So that is the logic behind it. So voltage difference is like temperature difference, heat current is like your regular current in current electricity, which means one can definitely use series and parallel combination whenever needed. Not just that, you can also use Kirchhoff's current law and Kirchhoff's voltage law whenever needed. That's the beauty of it. Yeah, you can use KCL, KVL whenever needed, series parallel concepts also whenever needed. Okay, so let's see some questions based on that, and then we'll go to radiation. Okay, so here it comes. The difference of temperature in a material can convert heat energy into electrical energy. To harvest heat energy, the material should have what? What do you think? Come on. What do you think the material should have, guys? Convert the temperature difference into the of heat from to electrical energy. Convert that heat energy into electrical energy, one should have uh, high temperature, high thermal conductivity or low thermal conductivity. Think about it. Or high electrical conductivity and low electrical conductivity. Option A. Okay. Okay, I'll tell you what. So what happens is, one side is kept very cold and one side is kept very hot. One side is kept very hot. So what happens because of that? The heat begins to flow. Heat begins to flow. And you want this temperature difference to be there. Else what will happen? The hot body will lose out all its energy. The cold body will become warm and there will be no difference of temperature. So the heat flow is low, is very, very low. So because of which the thermal conductivity is very less, so that this hotness and coldness temperature difference is maintained. So very, very important. So you want to maintain the temperature difference is going to be maintained. And once this heat begins to flow, then that heat is used into electrical energy. And you want that inside that solid, the electrical energy which is going to be generated flows easily. So in order to harvest, so you're going to take out the heat which is going, okay, and you're going to convert it into electrical energy. You don't want much losses, so it should be conductive in nature. It should be conductive in nature electrically. electrically. So low conductivity of thermal, but high conductivity of electricity. So that is basically option A. Very good. 12th physics, I'll be doing it on another day, not today, because it looks like we will be exceeding 11 o'clock or 10 o'clock for sure. And after that, I can't start 12th because 12th will easily take me 7-8 hours, bare minimum. So YouTube does not allow the lectures to be more than 12 hours. Okay, there is a cutoff limit, and after that, lecture automatically will stop. So better to have a separate day because then the class will go until morning 7 o'clock, 8 o'clock. Then, yeah. So I'll do it after 3-4 days. Is that okay? Yeah. Moving on to the next question on your screen. The outer faces of a rectangular slab are made of equal thickness of iron and brass and are maintained at 100 and 0. The temperature at the interface is how much? Okay, outer faces of rectangular slab are made of equal thickness of iron and brass. Okay, and maintained at 100 and 0. What is the temperature at the interface? So what does it mean? See, this is, let's say, uh, iron, and let's say this is brass. Example. Now, thermal conductivity of iron, and this is your brass, get cancelled. So point will also cancel. So 2 times of 100 minus x. 2 times of 100 minus x will be 3 times of x. So 200 minus 2x is equal to 3x. So 200 is equal to 5x. Therefore, x is equal to 200 divided by 5. So x is basically 40 degrees Celsius. So B option is the right answer. So you can see we can use the logic of electrical circuits to solve such questions. Okay. Big buffer, sir. Okay. 1 second. All right. I'm so glad, Sanjana, you loved the session. Just check if it is okay now. Stream health looks fine. Okay. Buffer gone. Yeah. Okay. Great. Now, they can also ask questions where, you might be given multiple rods. This is also a very common question. And they tell you, listen, this rod is K1, this rod is having conductivity K2, this is having K3, and they tell you, listen, the temperature over here is 100 degrees Celsius, the temperature over here is 50 degrees Celsius, the temperature here is 0 degrees Celsius, lengths are same, let's say areas are same, and then they will ask you, can you figure out what is the temperature at this junction? How much is this? So in such problems, what I suggest, you decide how the heat might flow, accordingly frame the equation. Actually, the heat might not be flowing in that direction, but make that. Because if you follow the proper signs and notations, you will get the right answer. Else, if you think, no, I don't know how the heat will flow, what should I do? Will it be negative of this? Then you will make a big blunder. Okay. So let's assume over here, say for example, this is hot, this is also hot. So maybe the heat will go like this. The heat will also go like this. They will all come over here and they will come out from this side like that. So I will call this I1, I'll call this I2, I'll call this heat current I3. This is a node now, if you notice. This is basically our node or junction. So if I use Kirchhoff's current law, what will I get? Current 1 plus current 2 will be current 3. Is that right? Like I said, you cannot just necessarily use series parallel, which we used in the previous case. It was in series. Okay, so current will be the same. But you can also use Kirchhoff's laws. I'm using KCL over here. What is current 1? It will be conductivity 1 into area, whatever it is, into change in temperature, which is 100 minus x divided by the length, plus what is the current I2? It will be 50 minus x. Why not x minus 50? Because heat will always flow from high to low. So assumed direction is like that. So you have to take 50 minus x, no other choice, into A into 50 minus x, of course, the whole thing divided by L is equal to, finally, why did I put 50? This was K2, my bad. Finally, this will be K3 into A, and this will be now x minus 0 upon the final length. Why x minus 0? Because it should go from hot to cold. Simple. So that's why you will get this equation. A and L will get cancelled. So you will get K1 into 100 minus x plus K2 into 50 minus x is equal to K3 into x minus 0. So the temperatures are given, K values are given, you can substitute and you can easily find out the value of x. Understood? After this, just you have to solve for x. Usually K1, K2, K3 are given. Yeah. We have assumed all the lengths to be equal. So all rods similar. All rods are similar. So we are using that idea. Else L and A will be different. If it is different also, still you can do it. I mean, you'll just substitute the values. It will not get cancelled. It will make it more complex. That's all. Okay. Yeah. Yes. Always make it current electricity question. Things will look simpler for conductivity. Okay. So that was the most important slide over here. Okay. Great. Now let's talk about heat radiation. Okay. There also you will get some questions. Not necessarily every time a question has come, but still I will tell you about it. So radiation is the third mode of heat transfer, which is the fastest. And the best part is it does not require material medium. It can travel in vacuum also, and it travels in the form of, the heat exchange happens in the form of basically what? Electromagnetic waves. Okay, it happens in the form of electromagnetic waves. So there is no medium required. EM waves, photons basically, and it is the quickest, fastest mode of transfer. Basically, it travels at the speed of light. Now, how do I remember all the formulas and all of it? First, let's talk about, say, there is a body over here. There is a body over here. And there is another body over here, exactly similar. But this one is called black body. This one is your normal, regular body. Both of them have the same temperature, no doubt about it. Okay. So you will see they will start emitting radiation. They will start emitting radiation like this. Even this body will start emitting radiation. And this radiation, which is emitted, is dependent on the following three things. How much area is there of the surface? Next, the material, and obviously the temperature. As long as the temperature is more than 0, it will emit. If it is 0, it's only temperature when the body will not emit radiation. So if you think ice does not emit radiation because it is cold, see, it is cold for you, but it is not cold for 0 Celsius, sorry, 0 Kelvin. So anything above 0 Kelvin will have to emit radiation. Even at minus 272.9 Celsius, a body will emit radiation. It's only at negative 273 degrees Celsius, everything stops. Okay. So it depends on these three things. Now, black body emits the highest radiation. Black body emits the highest radiation, is going to emit the highest radiation. A normal body will always emit lesser radiation. That's why more radiation on black, less number of radiations I'm shown on the normal body. So the amount of radiation which is emitted per unit time, dq by dt, emitted, or sometimes also I can write it as power which is being emitted, which is also dq, which is emitted per unit time, is given by E sigma A T raised to 4. As you can see, Sigma is a constant which is also called as the Stephen's constant. Stephen's constant, whose value is 5, 6, 7, and 8. So 5.67 into 10 to the power minus 8. That's all. Very easy to remember. 5, 6, 7, 8. E is called as emissivity. A is area, T is temperature. As you can see, it depends on area, it depends on temperature. E is the material. So if the material changes, the power will also change. So all these three parameters are there here. The material, which is E, it depends on material, temperature, and of course the area. All of them are there. Got it? Simple and straightforward. For a black body, what happens? The emissivity is 1. For a black body, it is the highest, so E value is 1. For a normal body, the value of E will be less than 1, but more than 0. If it is 0, then it is not going to emit only anything. So worst case, 0, but there is no such real body which does not literally emit anything. That's not going to happen. So normal regular bodies will have E between 0 and 1. Is this concept clear, guys? Yeah. And that value of T should always be in absolute temperature Kelvin. Never put it in Celsius or Fahrenheit. Okay. Now what happens is this radiation will fall onto a body, another body, let's say. So let's say the radiation from some body was incident. This was incident radiation. Incident radiation. Now, when that radiation gets incident, one of these things can happen. Either that radiation can get reflected, reflected. Another possibility is that some amount of it will just pass through it. So it will get transmitted. And lastly, a part of it might just get absorbed into it. Just absorbed into it. It's gone. It's absorbed it. So we say then the amount of heat which is incident per unit time is equal to numerically sum of the three things: the amount of heat which is reflected per unit time plus the amount of heat which is transmitted per unit time plus the amount of heat which is absorbed per unit time, which is by law of conservation of energy. Now, if you take this number and divide it over here, then you will see on the left hand side, you will have the number 1. This ratio, heat which is reflected per unit time by heat which is incident per unit time, that is basically called as reflectivity. Then this number over here, where heat which is transmitted upon heat which is incident is taken, that is called transmittivity. And the last number over here, absorbed by incident, is called absorptivity. So R plus T plus A is basically 1. So basically R is nothing but how much heat is incident per unit time, sorry, not incident, reflected per unit time upon how much heat is actually incident per unit time. Same with this also. Okay, I'm not writing all these numbers, but you can understand it. Now, this absorption coefficient, just this one I will write if you want. This is how much heat is absorbed per unit time upon how much heat is incident per unit time. Kirchhoff found a very interesting thing, and he figured out that this absorption coefficient also is equal to E. So it means good absorbers are good good emitters. Good emitters. Bad absorbers are bad emitters. So which also means if E is 1 for a black body, so even A value, absorption coefficient, is also going to be 1 for a black body. Keep this in mind. Is this absolutely clear, guys? All these things? Yeah. Lastly, over here, when we talked about how the radiation which is emitted, we discovered one more thing, and we figured out the wavelengths which are going to come out of it. They are all of different colors. They are all of different wavelengths. So if you put how much energy is there for a particular range of wavelength versus the wavelength, that graph came out to be something like this. And when you increased the temperature, then that graph became like this. When you increase the temperature. So this temperature is more than this particular temperature. This shows that there is a particular wavelength which is emitted the most, and that I will call it as lambda max. This wavelength, which is the most prominent wavelength, most observable wavelength in a particular emission, decreases if you increase the temperature. So he gave this law, lambda max multiplied by the absolute temperature is nothing but constant. This is called as Wien's displacement law. Wien's displacement law. Okay. So temperature increases, lambda max reduces. All right. Okay. Perfect. Lastly, now that we have discussed emission and absorption, what will happen when both of them are happening together? See, transmission can't increase the temperature. Reflection also can't increase the temperature because it is reflected back. This is transmitted. Only the light which is absorbed can change the temperature of the body. So imagine you have a body over here, and out of that incident, part of it is getting absorbed. This is the absorbed radiation from the incident coming from some surrounding, coming from the surrounding bodies or just the surrounding. And at the same time, do not forget, the same body from the surface is also emitting on its own, and this has no relationship with this. It's just emitting. This is emitted radiation. So there is something which is going in, something which is coming out. So two things happening at the same time. So this means there is a net heat flow rate. So the net dq by dt, this is the net heat which is flowing inside the body, will be dq, which is absorbed per unit time, minus dq, which is emitted per unit time. Is that clear? Yeah, the difference of the two is the net heat flow rate. So when you write this down, absorbed will be, instead of E, it is A sigma A T surrounding raised to 4. This is E sigma A temperature of the body raised to 4. This is your surrounding. But A and E are equal. So in that case, E can be taken common. Sigma is anyways common. A is common. So I'll be left with the surrounding temperature raised to 4 minus temperature of the body, whole thing raised to 4. So that is basically your dq net by dt. This is your Stephens-Boltzmann law in the final form, where surrounding temperature, body temperature, everything is considered, and this is net heat flow rate. Okay. Now, when you convert this dq as ms, and this is nothing but dt by dt, okay, this dq is ms, small change in the temperature. This is E sigma A, and let's say the surrounding temperature from the body temperature is hardly any different. So temperature of the body plus delta T, okay, plus delta T, this whole thing raised to 4 minus temperature of that particular body raised to 4. When you solve this and approximate it, you will find dt by dt is proportional to, forget all the constants, is proportional to the difference of the temperature. Basically, how different is the surrounding temperature from the body temperature. This is called as your Newton's law of cooling. This is called as your Newton's law of cooling, where on the graph, if this is your temperature, this is your time, small t, then the graph looks something like this. Originally, body temperature will be like that. Eventually, it will come out to be like this. So, this is your surrounding temperature. This is your surrounding temperature. This is the body's temperature. This is the temperature of that particular body. It slowly comes to the surrounding temperature, but the rate at which it happens is different every single time. So you can see if I draw a tangent to the curve at any single point, that slope is actually your dt by dt. Actually, there is a negative sign over here also because it is cooling, so there is a negative sign. Other than that, no significance of that negative. Delta T is the difference between the body's temperature and the surrounding temperature. So this is nothing but your delta T, which is used over here. So that is your Newton's law of cooling. As you see, the delta T reduces, the slope will also reduce in magnitude. So it will cool slower later on, but it will cool faster in the initial stages. That's the logic behind it. Yeah, got it? It came from Bolt law. Yes. So I hope now all these concepts are clear, because if you read from NCERT and some random notes, I have not seen many teachers teach this topic properly, because it all becomes so confusing. People forget what the hell is emission, what is radiation, what is absorption, what the hell is Newton's law of cooling, what is this A equal to E, what is this Wien's law. But just 3 slides or 4 slides I have taken. Actually, there is one more slide, but it is printed slide. But from my notes, if you just go through these 3 slides, trust me, your entire radiation is done. That's all. Nothing else you need. That's the only slides you need. Yeah. Yeah, the PDF will be attached, bro. Don't worry. Okay. Great. So let's do some question on this. And yeah, what does it say? A solid sphere of copper of radius r and a hollow sphere of same material of inner radius r and outer radius r are heated with the same temperature and then allowed to cool, not cool in the same environment. Then hollow sphere cools faster than the solid sphere. Rate of cooling is according to Stephen's law, which is T raised to 4. I feel definitely there is a mismatch over here. Harish, the PDF will come by tomorrow. Okay. Rate of cooling is definitely not T raised to 4. It is just proportional to temperature. So reasoning is false. What about assertion? Solid sphere and a hollow sphere. If you have a solid sphere, more mass is there and allowed to cool, then the hollow sphere cools faster. So when you take a solid sphere, there is more mass in it compared to hollow sphere. So more mass means even if the heat coming out of it is there, the temperature changes will happen slowly because it has to cool the entire solid copper versus a hollow copper, which is a shell. So the solid copper will take more time to cool because there is more mass whose temperature needs to be lowered versus a hollow sphere which has a lesser mass, shell-like material, so it will cool relatively quicker. So assertion is true, reasoning is false. Makes sense? It's logical. No need of any formulas at all. Yeah, correct. Perfect. Amazing, amazing, amazing. There is one particular question which I will do over here for all of you. It is given to us that if the maximum wavelength of radiation is doubled, then the emitted power becomes dash number of times. This kind of objective question can come. Options can be there, but no need of options. Just see directly if you can solve it. If the maximum wavelength doubles, then the emitted power will become how many number of times? That's the question. Yeah, option B. Which option B, man? There is no such option B. Okay, let's try to solve this now. Uh, hmm. Maximum wavelength doubles. So I think wavelength is related to temperature by Wien's law. So we know lambda. Check now, check now, check now. Okay, just check now. It should be clear. Stream health is showing fine. Yes, perfect. Okay, so the concept here was basically that, we use Wien's law. So lambda becomes double, temperature becomes half. Second, we use Stephen Boltzmann law. So power is proportional to temperature raised to 4. So from this, temperature has become half. So T2 is half of T1. So it will become 1 by 16 times of P1. So answer is 1 by 16. I hope this is clear. Yeah, Wien's law and Stephen's law. Okay, clear? So these were some questions on radiation and everything. So now let's go to KTG and thermo before moving on to oscillations. Ready for it, guys? Ready, 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 ready. After this, we'll take a small break again, 10-15 minutes, because my throat is aching now. So yeah, I heard Diksha ma'am after she took a class, next day she called, she had to cancel one class and she was not able to talk only. She's telling something I'm not able to understand. And then I was like, ma'am, what happened to your voice? Then I realized, oh, she also took one big marathon and her voice was completely gone. Okay, so looks like that same thing is going to happen to me. Yeah, it's a good class, man. Yeah, yeah. So let's begin. KTG. First formula and basically assumptions. Remember where you take the molecules as small particles, they are moving randomly here and there with different speeds, different directions, all random. The size of the molecules is very small as compared to the containers. The number of molecules are very large. The collisions are elastic in nature. All of these are the assumptions which are there. Based on that, you derive certain formulas. First formula which you get is the uh, RMS speed formula. And what is the RMS speed? RMS speed is that speed which has the average kinetic energy of the molecule. Simply put, it is that. Okay. So RMS velocity is that velocity which has the average of the kinetic energy. And why is it different from the average velocity? Average velocity is just v1 plus v2 plus v3 by n, correct? So if you just want to find, I think average velocity formula is there in the next one. Yeah, average velocity. Average velocity is just v1 plus v2 plus v3 whole thing divided by the number of molecules. And that comes out as root of 8 by pi into RT by m. 8 and pi are constants. R is the gas constant. T is temperature in absolute value. M is the molecular mass in kgs. So that gives you average velocity. But remember, the RMS velocity is something different. Kinetic energy is half mv square. Just because the speed is average does not mean kinetic energy is average, because speed is not directly proportional to speed. Sorry, kinetic energy is not directly proportional to speed. It is proportional to the square of the speed. So that's why that speed which will give average kinetic energy will be different from just the average speed. Getting my point? Take some time to digest this fact, but once you understand it, that's it. There is no going back. Yeah. So the value of the RMS velocity is numerically v1 square, v2 square, v3 square, vn square, whole thing under the root divided by n. This root should have extended below. This is not right. Yeah, like this. Yeah. So this is RMS velocity. And that happens to be root of 3 RT by m versus root 8 RT by pi m. Okay, so RMS is root 3 RT divided by M. Keep that in mind. But there is one more speed which is called most probable speed. And why does that come? I'll tell you. See, if you draw the graph of speed versus number of molecules at a particular speed, that graph looks something like this. You will see there is one particular speed where maximum number of molecules are there. That is your most likely speed of the molecules. Many molecules will be there at that speed, but there are some molecules which are at very high speeds. There are some molecules at very low speeds. So you can find the average RMS, that's another story. But this is how the curve looks like. It's a bell-like curve, like a shape of a bell. It's also called as Maxwell's speed distribution. This is called Maxwell's speed distribution. Maxwell's speed distribution curve. And that most likely speed is root 2 RT by M. Is root 2 RT by M. The other velocities are over here. This is where your average velocity is, and this is where your RMS velocity is. So RMS is higher than average, and average is higher than the most likely speed. These are things which you should know. Sir, my t-shirt is 2025. What should I do now? I can't change it, man. Yeah, I don't have another t-shirt, or else I will have to teach in banyan. Okay, that I think is not allowed. So what is the comparison ratio? It is basically if you take the ratio of all these three speeds, what is that ratio going to be? So if you take most probable speed is to what is that? Average speed is to RMS speed. Most probable will be the smallest value, which is root 2 RT by M. RT and M are same, so it will have root 2 over here. Average speed has 8 by pi. RT and M are the same thing. So you will put root of 8 divided by pi. RMS velocity, like you can see, it has 3 RT by M. RTM is same, so 3 is the number which you should consider. So root 3. So this is the ratio of the speeds. Okay, RMS is the highest, most probable is the lowest. Cool. Yeah. Karthi, I'll take 12th in the next 4-5 days. Okay. So after 2-3 lectures of maths and chemistry is done, then I will take maybe by Monday, Tuesday or something. I'll take 12th class. Yeah, definitely. All right. Now, this RMS speed is related to the pressure and the density by this equation, where you have P is equal to 1 by 3 rho V square, which can be also written down as PV is equal to 1 by 3 N into M VRMS square. This N into M is the total mass of the gas. So if you divide by volume, Nm by V becomes the density. So that is why you get this formula. So N is basically the number of moles into Avogadro number. This is the number of moles. This is Avogadro's number. This is number of molecules. Keep that in mind. And that's number of moles, of course. What is small m? Small m is mass of a molecule. Mass of a molecule. And that mass of a molecule is molar mass divided by Avogadro's number. So this m is molar mass. Molar mass. If you divide it by the number of molecules, you will obviously get per molecule how much mass will be there. It's like unitary method. Okay. Now, from all of this only, you essentially get all these other terms as well. Like, for example, yeah, you end up getting PV is equal to number of moles into RT. You can also get pressure into molar mass is density into RT. Yeah, all these things you can get. Also, you get the number gas constant by the Avogadro's number. is nothing but K, which is called as Boltzmann constant. Boltzmann constant, whose value is 1.38 into 10 to the power minus 23. This R being 8.3 joules per mole per Kelvin. SI units generally will be using. So these standard formulas you definitely get using the previous equations. So all these things you should definitely be aware of. Okay. I think Boltzmann constant is also put over here. Okay, great, perfecto, amazing. All right, I think we can solve some questions based on this. Yeah, what do we have over here? 6 molecules have speeds 2, 5, 3, 6, 3, and 5. The RMS velocity is approximately how much? Okay, come on. Is it possible to get 90 percentile with just basic knowledge? I think so. Not very basic. Basic means you define basic now. Because basic can mean very basic also, like ABCD. Sir, I know ABCD. Can I get 99 percentile? 90 percentile? No. Sir, I know plus minus. Can I get 90 percentile? No. So, basic definition you need to be very clear. Because I saw one teacher making some, will do basics, will do physics or chemistry, mathematics from basics, and the teacher is teaching ABCD. Well, hello. Yeah, looks like yeah, the mic went off. So that was the limit of the mic. I had even, by the way, kept the mic for charging when the break was taken. Still the mic went off. So imagine Shreyas Sir's mic is continuously on. Yeah. So the mic battery died, but Shreyas Sir is still teaching. Anyways, next question. At what temperature is the RMS velocity of hydrogen molecule equal to that of the oxygen molecule at 47 degrees Celsius? All right. What temperature RMS velocity of hydrogen equal to that of oxygen? So 3RT, the temperature for oxygen is 47 degrees Celsius. So it will be plus 273. How much will it be? 320 Kelvin. Is that right? 320 Kelvin, because 27 degrees Celsius is 300 Kelvin. So 47 degrees Celsius means 300 yeah, correct. 320 Kelvin. So put 320 over here. Okay, I think they have given it deliberately because maybe 32 is divisible by 16. 16 is the perfect square. God knows, I don't know. And molecular mass of oxygen, oh, that's why 32. That's why they have given 47 degrees Celsius. So 32, 32 will cancel. And then over here it will be 3R. I don't know the temperature. This is going to be how much, guys? This is going to be 2. Yeah. So RR33 cancels. So T by root also will go. 32 by 32 gone. So 110 is remaining. So temperature will be 20 Kelvin. Everything I'm doing it in Kelvin. So option B, of course. Is that right? Okay. Yeah. Amazing, guys. Amazing. All right. Then you have the concept of internal energy degrees of freedom, law of equipartition of energy and all of that. Now, first, let's talk about degrees of freedom. It's basically the independent motions which a molecule can have, whether it is translational, vibrational, or rotational, which can possess energy. So generally, a molecule can have kinetic energy of translation in three directions. Then it can have rotational degrees of freedom. It can rotate like this, it can rotate like this, y-axis. It can also rotate z-axis. So 3 degrees of freedom rotation possible, and vibration also possible. So one vibration, it can go like this. Okay. It can also end up vibrating like this, twisting its arms. So vibration is also possible. Now, a monoatomic gas like inert gases, neon, helium, etc., they have only 3 translational degrees of freedom. Rotation is not going to have any energy, even if it can rotate, but it will not be considered for energy. So it has 3 translational degrees of freedom. Okay, so a monoatomic gas has 3 translational degrees of freedom. The moment you take diatomic gas like hydrogen, oxygen, like this, then they not only can have 3 translational degrees, but they can also have 2 rotational degrees like this. This rotation will not be considered because it will rotate about the axis, which will not have significant energy. So that's possible. But it can get more 2 degrees of freedom, which is vibrational degrees, if the temperature is sufficiently high, but normal temperatures, that is not there. Not just diatomic gas, even a triatomic linear gas will have the same degrees of freedom. So say for example, you have a gas which looks like this, triatomic but linear. Then not only can it translate in 3 degrees, but it also has rotational degrees of freedom, which is 2 rotational degrees. So linear triatomic like carbon dioxide and diatomic like hydrogen, oxygen have the same degrees of freedom. Additional 2 degrees of freedom will come. So I'll put over here +2 vibrational degrees of freedom at very high temperature, 2000 Kelvin, 3000 Kelvin, very high temperature, not for low temperatures. Okay, so keep these things in mind. Now, if you have a non-linear molecule which is triatomic, then what happens is, say for example, if you have the third case, non-linear polyatomic, then say for example like this, then not only will it have its regular 3 translational degrees, but also 3 rotational degrees of freedom. So such a molecule has 3 translational plus 3 rotational, which makes it 6 degrees of freedom. Keep that in mind. Okay, this is for polyatomic molecules. Anything. Okay, H2O. It's a polyatomic nonlinear molecule. All right. Now, why we discuss degrees of freedom is because of the law of equipartition of energy, which says that for a molecule, if you take every degree of freedom, each degree has half kT of energy, where K is the Boltzmann constant. So, if you talk about a molecule, then it has F degrees of freedom. So, therefore, the energy of that molecule, the energy of that particular molecule, is how many ever degrees of freedom it has into half kT. Simple. Is that clear? Into half kT. Lastly, a gas might have so many molecules. So the total energy of that gas will be n times the energy of each molecule. When you solve this, you get the internal energy of the gas as n, then F R by 2 into temperature. This Fr by 2 is Cv. Degrees of freedom into gas constant by 2 is exactly CV. So that's why internal energy of a gas is called NCVT, NCV into T. So that is what is also mentioned over here, I believe. Yeah. Mm, okay, that's all. Okay, we'll do one thing. We'll make fresh slides, or else it will become very confusing. So once you know this, so you also know the change in internal energy of a gas will be NCV into also delta T. Okay, keep all these things in mind. So per molecule, per degree of freedom, how much energy is there? Half kT. Just remember that. Per molecule, per degree of freedom, it is half kT. Other things you don't require. So this and all is not required. This will unnecessarily confuse you. 100 things. All this is not required. Okay. So per molecule, it will be F into half kT because F degrees will be there. Like monoatomic will have 3, diatomic will have 5, vibrational is there, then 7, polyatomic will have 6, like that. So if you have a gas, there will be n such molecules, so n times of that, but you don't have to multiply it n times. I just told you CV is R into F by 2, but you can also write it as R upon this gamma, same gamma minus 1, and the same CP value, you can also write it as gamma times R by gamma minus 1. Keep that in mind. Now, if you take mono, dia, and poly, then degrees of freedom for mono is 3. We will just make a small quick table over here. Okay, so degrees of freedom for mono it is 3, for dia it is 5, but it can be 7 also. For poly it is 6. Then degrees of freedom done. CV will take, CP also we will take. What's the values? So CV and CP. So CV, if you see CV formula, it is RF by 2. Degrees of freedom is 3. So 3R by 2. Here it is 5R by 2. Here it is 6R by 2, which is going to be 3R. CP is more than CV by R. You can see CP minus CV is R. So if you basically add one extra R, you will get CP value. So it will become 5R by 2. This will become 7R by 2. And this will become basically 4R. So this CP, CV values you might definitely need for solving questions. As simple as that. Okay. Yeah. Gamma value, finally we can write it down over here. Gamma is CP by CV. So, oops. So we have our gamma value. So what is gamma? Gamma is CP by CV. So this will be 5 by 3, which is 1.67. This will be 7 by 5, which is 1.4. This is nothing but 4 by 3, which is 1.33. So that's how gamma value is. As the number of degrees of freedom increases, gamma value will keep on decreasing. Okay? Fair enough? All right. Perfect. Great, guys. So these are standard formulas which you should remember. So let's see some questions based on this. If the ratio of the specific heats of a gas at constant pressure and constant volume is gamma, then the number of degrees of freedom is how much? So gamma is standard value, guys, which we all know, Cp by Cv, which is okay. So we all know gamma is 1 plus 2 by F. Take 1 on the other side. So 2 by F is gamma minus 1. Check now. Is it visible? Now it's good. Okay. So I just said for mono Cp is 5R by 2. For dia, Cp value is 7R by 2. So mono by dia will be 5 by 7. Dia by mono will be 7 by 5. So that's the answer. Okay. So I hope this explanation is clear. For the previous question, if you wanted the explanation, I just said gamma is Cp by Cv, whose value is 1 plus 2 by F. This I gave it to you here, 1 plus 2 by F. So if you take 1 on this side, it will become gamma minus 1 is 2 by F. If you take reciprocal, F by 2 will be 1 by gamma minus 1. Shift 2 on the top, so 2 by gamma minus 1. So that is B option. Okay, so that's how we solved these two questions. Are you ready now for the next explanation? Yeah. Okay. Previous one also I have explained. Okay, Kalyani? Fine. All right. All right. Okay. Shall we solve now this question? Let me know. A gas mixture contains 2 moles of oxygen and 4 moles of argon at some temperature of T. Neglecting vibrational modes, total internal energy of the mixture of the gases will be how much? Okay, so it will be total internal energy will be internal energy of oxygen plus internal energy of argon. Now, for oxygen, the number of moles is 2. Oxygen is a diatomic molecule, so Cv value will be 5R by 2. Yeah, and temperature I will take it as T. Argon, how many moles? 4. It's a monoatomic molecule, so Cv will be 3R by 2 into T. Okay, so 2 5s are 10, 3 4s are 12 by 2 into R into T. 4 2s are 4 3s are 12, 2 5s are 10, 2 is there common. So it will become 22 by 2, which is 11 times of RT is the total internal energy. Yes, 11 RT is the perfect answer. D option. Just check it out. Yeah. Venu Murugan will be doing 12th standard after 3-4 days because 11th only is going till 11-12 o'clock. Okay, so it's crazy. Oh, it was asked today only. Great. So I hope you got it there. And if you didn't get it there, now you know the explanation of it. All right. Next one on your screen. It says the average translational energy of oxygen molecules at 127 degrees Celsius. Average translational kinetic energy of the oxygen molecules is how much, and Boltzmann constant is also given to me. Now we know per degree of freedom it is half kT. So kinetic energy of translation, there are 3 degrees of freedom and each degree will have half kT. Whether it is oxygen, hydrogen, doesn't matter, it is half kT. So it will be 3 into half into Boltzmann constant 1.38 into 10 to the power negative 23. Temperature 127 Celsius is 400 Kelvin. Is 400 Kelvin. So put 400 over here. 4 by 2 is 2. So 2 3s are 6. So 6 multiplied by 1.38 into 10 to the power minus 21. These two zeros will be swallowed here. So 6 into 1.3, guys. Come on, how much will it come out to be? This is like almost 1.4. Yeah. So 14 6 are 84. So it will be 8.4 something, but it will be slightly less than that. So I think it will be 8.28. Yeah. You don't have to sit and calculate. 8.28 into 10 to the power minus 21 joules. So it should be option C. You can check it out. Yes, 8.28 into minus 21. Perfect. There you go. Yeah. Thank you, VJ. Then we make means a lot. Thank you so much. Calculation sucks, so don't have to calculate. Where did I calculate? I didn't even calculate. What did I do? This 1.38 is like 1.4. I know the table of 14, 14 6 84. So because of 1.4, it will become 8.4. But since 1.38 is smaller than 1.4, the answer should be slightly less than 8.4. The only option is 8.28. That's all. Yeah. Thank you. Thank you for all the love from VLC Warangal. Means a lot, man. Okay. Moving on to the next question coming up on your screen, and here it comes. If 2 moles of ideal monoatomic gas at temperature of 27 Celsius is mixed with 4 moles of another blah 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 this much temperature, then the temperature of the mixture of the two gases is how much? This is a combination of kTg and calorimetry. There is one hot gas, there is one cold gas. When hot body meets cold body, what will happen? Hot will become cold, cold will become hot. That's all. Energy exchange will happen. So the loss of internal energy by our monoatomic gas monoatomic gas will gain. So gain of that energy will be loss of energy in that another monoatomic gas. Simple. That's it. That is the logic I will be using. So one will lose, who will gain? The cold one will gain, and this one will be the hot one, which will lose. Okay. So number of moles. 27 degrees Celsius mixed with another gas. See guys, 27 degrees Celsius, 327 degrees Celsius. The final temperature is X degrees Celsius. So this is the cold one which will gain. This is the hot one which will lose. Final temperature is X. Keep this in mind. Number of moles into CV into delta T. Delta U is NCV delta T. Number of moles of the monoatomic gas is 2. CV for mono is 3R by 2. Temperature difference for the one which is gaining, it will be X minus 27. This diagram helps me very quickly. Whether I should do 27 minus X or X minus 27, it's very obvious. Always choose the positive difference. For the loss one, yeah, number of moles are 4. CV is anyways 3R by 2. And finally, it will be 327 minus your X value. 3R by 2, 3R by 2 cancels. So it will become 2 times of X minus 56. Sorry, 54. Am I? Minus 54. 2 into 27 will be 54. And 3R by 2 has cancelled. So 4 multiplied by 327 minus 4X. Okay, so come on this side. So 2X and 4X will become 6 times of X will become 54 plus 4 multiplied by 327. So X will be 54 plus 4 multiplied by 327 divided by 6. Guys, you do the math and tell me quickly what's the answer. Should we do this in Kelvin? Is that so? Are you sure? Are you sure? Should we do this in Kelvin? We did a mistake, says Chad. I'll tell you, we did not do a mistake, and I'll tell you why also. Okay, a lot of people think this. Very good, you asked me this thing. 1 degree Celsius is not 1 Kelvin, 100%. Yeah, we know this. But difference of 1 degree Celsius is always difference of 1 Kelvin. There is a difference between this and this. Yeah, so difference of 1 Celsius and difference of 1 Kelvin is same, meaning if I go from 0 Celsius to 1 Celsius, it's the same as going from 273 Kelvin to 274 Kelvin, or even 300 Kelvin to 301 Kelvin. There is no, uh, difference in that difference, I can say. Cool. So that is why when I take the difference, whether I take it in Kelvin or Celsius, anyways, I've done the same thing on both sides. Units are same. Anyways, they will get cancelled. So I need not have to worry about it. Got it? Yeah. So is the answer coming out to be 227? Just check it out. 227 degree Celsius. That's the final answer, which is option B, I believe. Yes. Very good, Sujan. Amazing, go, amazing, go, amazing. Very nice. Let's move to thermodynamics. After that, we'll take a break. Okay. Yeah. After that, we'll take a break and we'll do oscillations and waves. Okay. Is that okay? Fine, guys. Awesome. Let's do thermo, guys. Oh my God, my legs are paining now. I need to do some exercise and I can't sit. Okay, guys, let's do this. Ready for it? Yeah, thermo. Keep it up. And how many of you are watching this from 1 o'clock? Yes, we started the lecture at 1 o'clock in the afternoon and it's almost close to 10 o'clock. Close to 9 hours done. Okay, let's do this. Okay, we'll do this, guys, and then we'll take a break because or else that rhythm of thermal physics will break. Work done formula, integral pressure into volume, which is also the area under the pressure volume graph. If the work done is positive, then then it is expansion. If the work done is negative, then the volume decreases, so it compresses. Compression. And please keep in mind, the work done definition is always in physics work done by the system. In chemistry, it is work done on the system by the surroundings. So there is a small difference. In chemistry, there is a negative sign. In physics, there is no negative sign. Okay? Okay. Hold on, chat. Just few more minutes. Total duration will be, yeah, I think 11 hours. 10 to 11 hours to definitely will happen. Now, heat we have already defined. Internal energy change we already saw. Work I just told you. So from that, we have the first law of thermodynamics, which is also the energy law. Whatever heat you supply is the change in the internal energy plus whatever work is done by the system. This is your first law of thermodynamics, which is basically energy conservation. Say, for example, this was an energy drink. Shreyas Sir sees 100 calories is written. I drank 100 kilocalories or 100 calories of energy. So 100 calories I got. Out of that, 20 calories Shreyas Sir's body stored. So Shreyas Sir became fat. 20 calories. Remaining 80 calories, what will Shreyas Sir do? Shreyas Sir will do work. 80 calories, Shreyas Sir will do work. So I took 100 calories, I became fat, 20 calories, internal energy increased, and work done. Shreyas Sir is doing work. So 80 calories. That's first law. Got it? Cool. Wow. Awesome. Great. Now, yeah, let me tell you a couple of things over here based on this graphically. So let's say this is pressure, this is volume. Now, what happens is you are at some pressure and some volume, and you go to some other pressure and other volume via this path 1 versus some other path number 2. You can see you're going from the same initial state to the same final state via different paths. Different paths for the same final destination from initial source. In such cases, you will notice the change in the internal energy via path 1 and path 2 is the same because this is a state variable, whereas the work 1, because the area under that graph, you can see this is the area versus this area. Yeah, so you will see the work done will be definitely more than the work 2, and we all saw that if work is more, Q will be more if delta U is the same. So heat will be also more. So Q1 will be more than basically Q2. These are basically path functions. This is a state function. This is path function. Keep that in mind. Cool. Now, let's say, for example, somebody starts from a point and comes back to the same point. Okay, starts from a point and comes back to the same point. That means initial point and final point is same. Another person also starts from the same point but comes back in a different way to the same point. This was clockwise versus this is anti-clockwise. Initial and final point is the same. Such a process is then called as a cyclic process. These are cyclic conditions. In all such cyclic conditions, you will notice in all such cyclic conditions, delta U will be 0 because you are coming back to its original state. So no change. So delta U is always 0. So if delta U is 0, then what you will notice? If this is 0, Q and W will be the same. So Q will be equal to W, which is the area enclosed. which is basically the area enclosed, which means I'm talking about this area over here or this area over here. This area gives me the heat or the work done, one and the same thing. But keep in mind, this work will be negative for anti-clockwise. For clockwise, this will be positive. In chemistry, it's exactly opposite. Keep that in mind. Okay? These graphs are clear and these comparisons are also clear. Yeah, very good. Keep these things in mind. Great. Now, whenever you notice any, what do you say, pressure versus volume graph, and let's say that graph is something like this, and the pressure depends on the volume as this function PV raised to alpha is some constant. On this line, P into V raised to some number is a constant. Such a graph or such an equation is depicting something called as a polytropic process. It is depicting something called as a polytropic process. So for such polytropic processes, you will see if you draw a tangent, the slope of this, the slope, which is basically change of pressure per change in volume, will be negative. That variable which is coming on the top, the power, into pressure by volume. This is a very important thing. Many times, many questions have come in JEE Mains. What is the slope? So if you know pressure and volume and you multiply it by the power, you get the answer. Now it so happens that if you change the value of alpha, you get different processes in as such. So for example, if I choose alpha as 1, then I will choose alpha as, let's say, I'll start from 0 actually. Then I will choose it as 1. Then I'll choose it as gamma. Then I'll choose it as infinity. So what really happens over here? Observe carefully, guys. When alpha is 0, then the it will become P into V raised to 0 is a constant, which is as good as saying pressure is basically constant. This is nothing but an isobaric process. This is nothing but a simple isobaric process. When volume is raised to power 1, PV is constant. When P into V is constant, that means temperature is constant. This is isothermal process. When volume is raised to the power gamma, then such a process can also be written on as PV raised to gamma minus 1 is a constant. That is adiabatic process. And finally, when PV raised to infinity is a constant, that turns out volume is a constant basically. It becomes isochoric process. So changing alpha defines which process exactly it is. Very significant. From this, you can see for isothermal, alpha is 1, for adiabatic, alpha is gamma. So the slope, so from this, we can easily see the slope of adiabatic pressure volume graph is gamma times the slope of isothermal graph. Very, very crucial. Yeah, you see all these things happening over here. See all these things happening over here. All these are important formulas. Because slope for adiabatic will be gamma times of that, but for isothermal, alpha will be 1, so it will just be minus P by V. So for adiabatic, one extra gamma is there. So if you take isothermal slope and multiply by gamma, you will get adiabatic slope. Very important. Yeah. Cool. Now, finally, you get the formulas for work for all these scenarios, heat and all of that. Not a big deal. It's there over here only. I just kept it. But if you don't like this slide, I can give you one beautiful slide which you might like. So let me give you a beautiful slide. Don't worry, I'll keep this slide also for all of you. So the logic is over here, starting from isobaric to isochoric to isothermal to adiabatic to, in general, polytropic. Okay, so let's see what the graphs are and all of this, sorry, equations are. Starting off with the, what do we start? What is constant? That though anyways everybody knows. For isobaric, pressure is constant or volume is directly proportional to temperature. For isochoric, volume is constant, pressure is directly proportional to temperature. Isothermal, temperature is constant. So PV is, or P is inversely proportional to volume. In adiabatic, PV raised to gamma is constant, or you can say TV raised to gamma minus 1 is constant. For polytropic, PV raised to alpha is a constant. Okay, that's one thing. Now let's talk about delta U first. Change in internal energy. No matter which process, it's always NCV delta T, so don't break your head. So this is NCV delta T, NCV delta T. Be careful here, isothermal delta T is 0. So that's the only place this will come out 0. Actually, this formula is still valid. It's just that delta T is 0. Adiabatic, it's still NCV delta T, no brainer. This also is NCV delta T. Got it? So that's this one, delta T. Okay. Next, we will talk about work done. Yeah, work done. For isobaric, it is just P delta V. For isochoric, zero work because no volume change. Volume when increase, decrease, only work done is there. Isothermal, it is nRT, the constant temperature, into log of V2 by V1. Adiabatic, yeah. What is adiabatic work done? Yes, we completed most of thermodynamics, almost. Yeah. What is it, guys? Come on. nR delta T, final minus initial temperature, upon 1 minus gamma. And over here, same thing, nR difference of temperature divided by 1 minus alpha. That's all. So if you don't want to remember T2 minus T1, T1 minus T2, it's a headache. So just keep this in mind, delta T. That's all. So nR delta T upon 1 minus alpha or 1 minus gamma. Same thing. It's very similar looking formula. Okay. Then lastly, we get to heat. We get to basically heat Q. So it is NCP delta T, obviously constant pressure, isobaric. So CP will come. Here it will be obviously NCV delta T. Here heat will be exactly this because work is just directly going to convert into heat. So this will be the heat value. Okay, no difference at all. Directly as it is, nRT ln V2 by V1. Adiabatic, zero heat, no heat loss or gain. Lastly, over here, it is just the addition of this, and it will be NC for that polytropic process into delta T. That's all. That's the heat. If you notice, this is equal to this plus this. This is equal to this plus this. This is anyways this plus this. Here also, this is equal to this plus this. If you didn't realize why these two add up to 0, CV is R upon gamma minus 1. So this is negative of this actually. So both of them will cancel. Okay. Same with this and this added, you will get this value. Okay. So that's how you can do it. I'm so glad you finished 12 because of me. I'm so glad, man. So glad. Yeah. So this table also you can remember, not a big deal. So these are most of the questions where you will see from thermodynamics will come from these processes, these values, or the slopes, the graph concept, okay, or this cyclic process and the work done, okay, and the first law of thermodynamics. Most of them will come from here. So let's do some questions based out of it. First, let's say this is the question. It's given P cube V is a constant. Find C for that polytropic process. That's the question. Okay. Let's do this question, guys. Very nice question on your screen. Find specific heat capacity molar at that particular value. Okay. So first of all, this is no longer looking like a polytropic process. So first make it look like that. Take the cube root on both sides. So PV raised to 1 by 3 is a new constant. Now you can see this 1 by 3 is alpha. Now we can do the rest. Now how do I find polytropic process C? We know Q is equal to delta U plus work. Delta U is NCV delta T. Work done is NR delta T by 1 minus alpha. Q is NC for that polytropic process into delta T. As you can very clearly see, delta T, delta T, delta T, N, and N cancelled off. So we are left with polytropic process is CV plus R by 1 minus alpha. It is not mentioned what kind of gas it was. So let's say it was mentioned to us, it is a diatomic gas. For this diatomic gas. Now for diatomic gas, we know the value of CV. Yeah, CV for a diatomic gas is 5R by 2. So I'm just going to put 5R by 2 plus R upon 1 minus alpha. Alpha is 1 by 3 over here. So this will become 5R by 2 plus 1 minus 1 by 3 is 2 by 3. So 3 goes on the top. Yeah, 2 by 3, right? So 2 comes below. Is that right? Okay, so 2 is common. So 5 plus 3 is 8. So 8R by 2, which is basically 4R. So the value of C is 4R. Simple, direct, done. Oh, they asked very equal, good questions. Very good, Junior Capto 1, 2, 2, 3. All the best. So full 20 out of 20, I believe. Great. Next question. Heat supplied at constant pressure is this much joules. Then the volume changes from this to this. Then the change in the internal energy of the gas is how much? Okay, come on. Think which formula you are going to use, guys. Yeah. You want to find delta U, basically, the change in the internal energy of the gas. We know Q is delta U plus W. So delta U will be Q minus W. Pressure, this is given. Heat is also given. So work done, we know for constant pressure is P delta V. Oh, that's it, guys. Heat supplied is 1000 kilojoules. Okay, so I'll put everything in 1000. Okay, kilo means 10 to the power 3. Okay, minus pressure is 5 into 10 to the power 5. Change in volume 2.5 minus 1. All right. So this will become 1000 into 10 to the power 3 minus 500 into 10 to the power 3 into 2.5 minus 1 is 1.5. So this will become 5 into 15, 75, right? So decimal will go. So 750 into 10 to the power 3. So 1000 minus 750 is 250. So 250 into 10 to the power 3, but joules. So this is 250 kilojoules. So 250 kilojoules is option A. Yes, that's the right answer. First law and P delta V formula. Yeah. Great. Perfect. Amazing. Amazing. Let's go to next question on your screen. Here it comes. It says when an what is it? Ideal diatomic gas undergoes adiabatic expansion, the change in the volume is 0.5%. Change in the pressure is how much? Volume and pressure, how are they related? P V raised to gamma is a constant, and change in the pressure is asked. So pressure will be constant into volume raised to minus gamma. Using the concept of errors, we know the change in the pressure relatively constant does not matter. Gamma's positive value, positive gamma, into delta V by V should come over here. So if the left hand side is expressed in percentage, this will be also in percentage. Gamma for a diatomic gamma is how much? 7 by 5. Is that right? 7 by 5. So 7 by 5 will come here. Volume change is 0.5%. So 5 cancels, point will remain. So this will become 0.7%. Now will it be positive 0.7 or negative 0.7? It kind of makes sense to see over here that if my volume increases, to keep the product constant, pressure should decrease. So this is the modulus value. So actually it should decrease. Keep that in mind. So it should be negative 0.7. Yeah, it should be basically negative 0.7, which is absolutely the right answer. So both positive and negative values were there. Keep that in mind. Okay, cool. Yeah, very nice. Very nice. Amazing. 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 Shall we go ahead, guys, to the next question? Okay. The work done to increase the volume from 2 moles of a gas from V to 2V at constant temperature is W. The work done to increase the volume of 2 moles of same gas from 2V to 4V at the same constant temperature is how much? Constant temperature work done, standard formula, work is nRT log final volume by initial volume. So number of moles is same, temperature is same, final volume, what is it? 2V divided by V. So it will become nRT ln2. That is the first work done. And the second case, the work done will be temperature is same, moles are same, volume is 4V to 2V, from 2V to 4V, sorry. It will still become nRT ln2. This is the same as the old work. So new work is same as the old work. So hence B option is the right answer. Is that right, everyone? Perfecto? Understood? Clear? Great, great, great. Let's go to the next question on your screen. And this is, I think, the last question of thermodynamics. During adiabatic expansion, the temperature of 3 moles of a diatomic gas changes by 50 degrees. The work done is how much? Temperature changes by this much. And the work done is how much? Work done formula was nR delta T by 1 minus gamma, isn't it? Number of moles, is it given? 3. R, is it given? R. Okay. Change in temperature decreases by 50. So this is minus 50. And finally, 1 minus gamma. Diatomic gas. Diatomic gamma will be 7 by 5. So put 7 by 5 over here. Okay. 53 is a 150. So minus 150 R. 1 minus 7 by 5, that is minus 2 by 7. Negative, negative cancels. So it will become 150 R multiplied by 7 divided by 2. So yeah, 150 into 7 divided by 2. 15. 7 is 105. 105 divided by 2. Is that right? Perfect. Just see how much will it come out to be. 105. Yeah, no. Everything fine. Gamma is this much. Work done by the gas. Come on, guys. C says, Chad, what about others? When will the live end? Minus 2 by 5. Yeah, I did a mistake over here. That's what even I was thinking. None of the options were matching. Yeah, so this should be minus. This is what happens after a long class. So minus 7 by 5 over here. This is minus 2 by 5. Minus minus cancels. So it will become 150R multiplied by 5 divided by 2. 15 5s are 75. 75 divided by 2 is 37.5. So 375 R. 375 R should be option A. We'll check it out. Yes, it is the right answer. Absolutely. Okay. Yeah, great. So we'll do oscillations, but after a break. Right now it's 10:10. We'll take a 10 minutes to 15 minutes break and then we'll come to oscillations. Okay, fine. See you in a bit. Welcome back, welcome back, welcome back. Good evening. Yes, time for oscillations and waves. I hope you're back with your refreshment. And in case you had skipped dinner, I hope you had it. And those of you are watching it live right now, even if you missed the entire last 9 hours, you can still watch it now because every topic is independent of the other topics. So we are on to oscillations and waves. And before this, we have completed all the chapters of 11th standard. These are the last two chapters of 11th. The 12th standard chapters will be taken after a couple of days. I will announce it. Don't worry. Okay. Yeah. Ready. So let's begin with the class and yep. So we start with oscillations, and in the oscillation, when things go back and forth, there is a to and fro motion which is happening. There is a mean position which is also the average position, and then there are two other extreme positions. There are two other extreme positions. These are the places where the direction will change. So if it was going left side, it will go towards the right side. If it was going right side, it will go towards the left side. So direction changes at that locations. That's what happens. So actually velocity is zero, you can say, at those places. Whereas at mean position, the velocity is maximum. Now the difference between the mean and the extreme, that is the amplitude of that oscillation. So this is basically the amplitude of that oscillation, and there will be a period after which it repeats its motion. So it starts from here, goes here, comes back again over here, again the motion gets repeated. So it's called as the time period of oscillation. Okay, it's called as the time period of the oscillation, after which it repeats the motion, and one by the time period is called as the frequency of that oscillation. There is also a term called as angular frequency, by the way. Angular frequency, symbol being omega. That omega is 2 pi by time period, but 1 by time period is f, so 2 pi f. And one oscillation always corresponds to 2 pi radians in angular terms. So if you complete one oscillation in angular terms, it is one. So rotation, which is also 2 pi radians or 360 degrees. So angular frequency is how many radians you cover per second. Radians per second is the unit of angular frequency. These are some fundamental terms about simple harmonic motion which you should know. So SHM is a periodic motion which is also oscillatory in nature. In real life, there are many motions which are just periodic but not oscillatory. Like the motion of moon around the earth is repeated again and again, it's periodic, but it is not oscillating, it's not going just back and forth. There are some motions which are just oscillating but neither periodic. Like I might go right, then I did some time pass, I came left, immediately went to right, immediately went to left, then I did some time pass, stopped, did some time pass, then I came here. So I'm going back and forth, but it is not repetitive in a periodic manner. So that is also possible. So all different motions are there, but SHM is a periodic and oscillatory motion. Okay, keep that in mind. Great. Now, when you talk about SHM, simple harmonic motion, then the equation of such a motion is either a sine function or a cos function, right? So if you draw a graph of its position versus the time, it is either a sine or a cos function or just shifted by something. So you can just show it like this. Yeah. And yes, this height is exactly the amplitude. And if you go from one similar point to another similar point, like say for our example from here to here, that becomes exactly your time period. Okay, so this is your amplitude, that is your time period, which is also 2 pi by omega, angular frequency. This might not necessarily start from zero. If it starts from zero, then it's a pure sine, else it's been shifted by phi, where phi is the initial phase angle. So phi basically decides how much this sine graph will shift. So it is also called as the initial phase angle or just the phase constant. It's just when do you take time as zero? When you started, what was really happening? That is basically your phi, nothing else. Now, this equation is x is a sine omega t plus phi is always a periodic function. It's repeating, it is oscillating, positive, negative values, everything are there. But if you write it in the differential form, it looks something like this: d square x by dt square plus omega square x is equal to 0. So this is the differential form of rewriting the same equation, meaning if you take the second derivative of this, you will get omega square outside and rewrite the equation, you will get second derivative of x plus omega square into x is always equal to 0. Any such differential equation always has this equation as the solution, or this is always a SHM, simple harmonic motion, okay, which is periodic and oscillatory both. Okay, all right. Continuous mass distribution, I think I mentioned it, and like I didn't get you, like for gravitation and rotation means what kind of problem are you exactly talking about, Chad? Okay, now usually we discuss the spring mass oscillators in general, where for linear SHM, where you have a spring connected to a mass and you move it by some amount, let's say x. So there is some potential energy stored in it. The spring potential energy which is stored is obviously half kx square, where k is a constant, and the force which acts on it and the force which acts on it is proportional to x but opposite of x. So I'll put minus sign with k like a spring force. The force is linearly proportional to x but opposite of x, and the spring potential energy will be half k x square. Then that particular mass keeps on oscillating, whose time period is 2 pi root m by k. Okay, so if you take any mass and you find out that the force is proportional to x, it is a SHM. The constant of proportionality being k, the potential energy will be half kx square, and the time period of oscillation will be 2 pi under root mass by k. Yeah, as simple as that. So from this only you can also notice the value of angular frequency will be root of k by m, constant by the mass. Sometimes you might have two springs connected one after the other, something like this in series. When springs are in series, the formula is of resistors in parallel. So 1 by 1 of the spring constant equivalent will be 1 by k1 plus 1 by k2. So, use the formula like resistors in parallel, and then whatever is that equivalent spring constant, use that over here to figure out the new time period. But whereas when springs are in parallel, like the one over here, there's one spring like this, another spring is like this. So here, think of it in this manner. And now this is connected to a mass. Then you can replace both the springs with one single spring, but when in parallel, use formula for resistors in series. So just add the spring constants, you will get the new spring constant, as simple as that. Having said that, there is one simple rule which also you need to know. If a spring is cut into n parts, then the spring constant of each part is not k by n. A lot of people mislead through this. It is actually k into n. If it is cut into n parts, it is not k by n, it is k multiplied by n. Okay, all right. Yes, there is for IOQM Lewis Hamilton, there are Olympiad batches which we have. Yeah, so taken by separate set of teachers because that deals with complete different segment of examinations. We have IOQM batches, we have physics Olympiad batches, everything is there in Vedantu. If you're looking for it specifically, just put up a comment after the video. We can help you out with that. Like mass removed in a ring, so we get cavity problems. I think I did one problem, but in case you want that, okay, let me see how the flow is going. Based on that, towards the end, I will see. Okay. All right. Last thing over here is the energy of it. So the energy, kinetic energy is half mv square. Uh, Potential energy is half kx square. But if you add both of them, you will get half k a square, which is a constant. So kinetic energy is half mv square, potential energy is half kx square. Adding them gives you half k amplitude square, which tells total mechanical energy is conserved. So if this is the total energy line, kinetic energy will go up and down like this, like this. Kinetic energy is 0, maximum at the mean. At the other extreme, again 0, again maximum while going this way, and again 0, again increases, again reduces. Potential is exactly opposite of that. Yeah, it is 0 because spring is not extended. It stores maximum energy when at the extreme. When it comes back, loses all the potential, converts to kinetic, and again converts that kinetic back into potential. That's how it goes. Also, one point we missed was regarding the values of velocity and acceleration, how they change. See, if x is a sine of omega t, velocity, which is the derivative of this, will be a omega cos omega t, and acceleration, which is derivative of velocity, will be negative a omega square. Negative is important, sine omega t. Keep that in mind. Out of this a is the maximum magnitude of the x, maximum displacement, max displacement magnitude, which is also called as amplitude. This a omega is going to be maximum speed, and this a omega square is maximum acceleration, maximum acceleration's magnitude. Keep that in mind. Lastly, you can also write velocity in terms of x like this. Velocity is omega root of a square minus x square, and acceleration also you can write it as minus omega square multiplied by x. Both of these are valid. So you can use whichever whenever you want, depending on what is given and what is not given. If time is given, use these. If position is given and acceleration and velocity is asked, use these formulas. Standard. Okay. So these are again important formulas which you should definitely know. Lastly, for a simple pendulum, you will see the time period of oscillation is given by 2 pi under root L by G, or the angular frequency will be root G by L. And if somebody decided to write the equation of the motion, it will look like this. Theta is theta naught sine omega t, okay, something like this, where theta naught is the maximum angle which it displaces. So it is the angular amplitude on either side. That will be theta naught. That is angular amplitude of that motion. And this omega is this root G by L, because time period is root 2 by root L by G. You can also write it down like this, d theta by dt, which is angular velocity. This is angular velocity. Same like before, instead of amplitude, there is theta naught. So omega A, or A omega, instead of sine, now it will become cos. And same way, angular acceleration, which is second derivative of theta, will be minus omega square theta naught, and this will be sine omega t. Also, a special scenario of this is a seconds pendulum, where the time period is 2 seconds and the length approximately comes out as 1 meter. So when you put time as 2 seconds, the length of it comes out close enough to, 1 meter. Keep that in. This G can change if this pendulum is in a lift going up or down. So accordingly, you can change things. Keep that in mind. Okay. Now, in such angular problems, what also happens is the torque acting on that oscillating body is opposite to the displacement, and that constant of proportional is often called as torsional constant. This is called as torsional constant. This is called as torsional constant, and the same omega can be also written down as root of torsional constant divided by your moment of inertia. And the same time period, 2 pi under root moment of inertia by that torsional constant. Just like f is negative kx, here it is minus k into, instead of x, there is angular displacement. So same formula can be applied over here as well. No doubt about it. Okay, keep this in mind. Till this point, absolutely clear. Now this only gives rise to physical pendulum or compound pendulum, meaning, say for example, we have some body over here and it is hinged at this particular point. The center of mass, though, is over here. This is where the center of mass is, and this distance is, let's say, d. This is where that hinge is. So the body oscillates like this. Then for such a thing, the time period of oscillation is 2 pi under root I divided by m, g and d. Example, I tell you, say we have a ring and that ring has been hinged over here and that ring oscillates like this. Okay, the ring oscillates like this. So it is a ring like this. It goes like this, it's hinged on the top. So in such case, we know center of mass will be here for that particular ring, and the distance is nothing but r itself. What about the moment of inertia? You can figure it out. So moment of inertia about that hinge will be moment of inertia about center of mass plus m multiplied by how much ever you are shifting it by. Center of mass moment of inertia is mr square. You are shifting it by r, so it will become 2mr square. So now the time period will be 2 pi under root moment of inertia, which is 2mr square by mgd. So m into g into r. MMRR cancels, so you are just left with R by G under the root with 2 pi. So that's how you can use this for something called as physical or compound pendulum. Compound or basically of physical pendulum. Okay, fair enough. So physical compound pendulum, simple pendulum, total energy things, and also combination of springs and cutting of springs and simple equations of SHM. Okay, so these are the main things in SHM chapter. Mainly, let's do some questions on this so that you guys get an idea. So we have a body whose mass is 4 kilos and it has attached to a spring of force constant 64, executes a SHM on a frictionless surface. The time period of oscillation is how much? Time period is asked, K and M are given. So time period is 2 pi under root M by K. 2 pi is 2 pi, mass is 4, spring constant is 64, so 2 pi, 4 by 64 is 1 by 16, 1 by 16's root is 1 by 4, so 2 pi by 4 is pi by 2 seconds. So pi by 2 seconds, that is B option, absolutely. Everyone? Let's see how many of you got it. Clear. Very nice, very nice. Amazing. Option B. Let's do the next question on your screen. The spring is stretched by 0.2 meters when the mass of 0.5 kg is suspended to it. The time period of the spring when 0.5 kg mass is replaced with a mass of 0.25 kg is how much? Spring is stretched by this much when this much mass is suspended. So mass is this much, then what is the time period? Okay. So one thing, when you take a spring and you connect a mass, then the weight will be balanced by the spring force when in equilibrium. So Kx will be equal to mg. K I do not know. X value 0.2 meters. Mass 0.5. G is 10. So K will be 0.5 into 10 is 5 divided by 0.2 is 5 divided by 1 by 5, which is 25 newtons per meter. Okay. Now, when that 0.5 kg mass is replaced with another mass, so what will be the oscillation? So if you take that same spring and you connect a new mass, it will now going to oscillate. So that oscillation, the time period will be 2 pi under root, what have they asked? The time period, m by k. Now, we did the earlier part because we didn't know k, so we found out to be 25. Mass is 0.25. So this is going to be 2 pi under root 1 by 100. So 1 by 100 means it is 1 by 10. So it will become pi by 5. So pi by 5 seconds is 3.14 divided by 5. How much will it be, guys? I think it will be 0.628. 0.628 seconds. Just check this out. 0.628 seconds should be the right answer. Very nice. And how do I know it is 0.628? Yeah, because anytime you have to divide any number by 5, this trick you should know. You have any number, you want to divide it by 5. Let's say, for example, 7 by 5. You can write this always as 7 into 2 divided by 10, isn't it? So 7 to the how much? 14. So divided by 10. So think of 3.14 multiplied by 2 divided by 10. 3.14 into 2 is 6.28 divided by 10, which is nothing but 0.628. So this is a calculation hack which you should definitely know, especially when you are dividing it by the number 5. Yeah, simple. All right, let's go to the next question on your screen. The function sine square omega t represents a periodic motion, then the period of that motion is how much? Sine square. More of a maths question than physics, I feel. Yes, this is a good question. This is a good session, Harish. Definitely. So sine square, right? Sine square omega t. Okay. Sine square theta. What can I write in terms of cos theta? Remember, cos 2 theta was 1 minus 2 sine square theta. So sine square theta was nothing but 1 minus cos 2 theta by 2. So therefore, I can write this as 1 minus cos 2 theta, which is cos 2 omega t divided by 2, which is half minus half into cos 2 omega by t. So from this, we get to know 2 omega is the angular frequency, new angular frequency, and that angular frequency is always 2 pi divided by the time period. So 2 omega is 2 pi by t, and that is what the question is. What is the time period? So 2 cancels, so time period will be pi divided by omega. So pi divided by omega is nothing but B option, absolutely the correct one, B option. So this is a constant term, so ignore this, so don't worry about this. Constant term can be just ignored. Okay, you ignore this. This is like the amplitude, forget the minus sign, how does it matter? This is cos to omega t function. So whatever multiplies by t is the new angular frequency, which is 2 pi by the new time period. So the new time period is over here, 2 cancels. So t will be pi by omega. Got it? Okay, before Captain shares. Very nice, very nice, very nice. Perfect. Let's go. Next one. Particle is executing SHM. And what happens now is the ratio of the kinetic energies of the particle when it is at its displacement of a by 4 and a by 2 from its mean position. The ratio of its kinetic energies is asked. Okay, at two different places. Now, the moment I think about kinetic energy, I should think about half mv square. But I don't know velocity. Wait a minute. Velocity I know as a function of x. So, kinetic energy is half mv square. But velocity, remember it was omega under root a square minus x square. Sometime back I told you. So, square of this. So, indirectly I can say it is m omega square by 2 into a square minus x square. So from this, kinetic energy 1 upon kinetic energy 2 will be a square minus x1 square upon a square minus x2 square. x1 and x2 are the positions. First position is a by 4. Next position is a by 2. So a square will anyways cancel from numerator and denominator. So 1 minus 1 by 4 square is 1 by 16. 1 minus 1 by 2 square is 1 by 4. 1 minus 1 by 16 is 15 by 16. 1 minus 1 by 4 is 3 by 4. So 15 here, 16 here, 4 on the top and 3 here. So what happens next? 15 goes with 3 5 times, 4 goes with 16 4 times. So 5 by 4, which is C option, should be absolutely the right one. Got it? So sometimes it just takes a small breakthrough for you to figure out what the rest of the solution is. So think logically that, okay, different positions are given. From that, how do I get to kinetic energy? From position, if I get to velocity I can reach to kinetic energy because it's half mv square. Velocity to position, this formula, if you remember, it's straightforward. Else you will be stuck in a big loop. Yeah. All right. Okay. Very good. Very good. Very good. Amazing. Let's go to the next question on your screen, and here it comes. If a particle is executing SHM starting from its mean position, the time period of the particle is 1.5 seconds, then the minimum time at which the ratio of kinetic and total energy of the particle becomes 3:4. The ratio of the kinetic and the total energy becomes 3:4, and the question is time period is given, and at what time does this basically happen? If I know where the particle is, I can tell you the time. So how do I get to where from kinetic energy? Where means x. For x to be related to kinetic energy, I need velocities and x relation. Okay, so I got an idea. Kinetic energy is half mv square, but velocity I just told you was omega under root a square minus x square. Great. So this will become half m omega square, and this is a square minus x square. But wait a minute, what is m omega square? Because we know omega is k by m under the root. So omega square is k by m, which means m omega square is technically k. So m omega square is k. All right, I need this by 2 into a square minus x square. Why I'm doing this, I'll tell you. Okay, don't get confused between this K and that K. These are completely different things. This is kinetic energy, by the way. The ratio of kinetic and total energy becomes 3:4. So if I take the ratio of kinetic energy versus the total energy, it will become K by 2 into a square minus x square divided by half K a square. Deliberately, I did this conversion from m omega square to K because I knew beforehand that when I read the question that total energy will come and total energy has half K square. So somehow I want to get K back into the equation. So half K will get cancelled. So a square minus x square by a square. And this ratio is already mentioned to be 3 by 4. So 3 by 4 is a square minus x square by a square. If you want, use componendo, else okay, I mean, you can just cross multiply, not a big deal. So 3a square is 4a square minus 4x square. So 4x square is 4 minus 1 is 4 minus 3 is 1. So a square. So x square is a by 4 or a square by 4. Therefore, x is nothing but a by 2. So position is a by 2. So now let's use this fact that x is equal to particle executing starts from its mean position. That means x is a sine omega t. It should be a pure sine function because it starts from its mean position. So x value is a by 2 is equal to a sine omega. Omega is 2 pi by the time period into t. A cancels, so half is equal to sine. Time period is how much? 1.5 and then t. So whose sine is half? That is pi by 6. So whatever is there inside is pi by 6. So 2 pi by 1.5 into t is pi by 6. Okay, pi cancels. 2 is there, t is there. 1.5 is 3 divided by 2. So 2 goes on the top. This is 1 by 6. Great. Now 3 cancels, sorry, 3 and 6 cancels. 2 2s are 4. So 4t is equal to 1 by 3. Sorry, 1 by 2, my bad. So time will be 1 by 4 into 2 is 8. So 1 by 8th of a second, which is C option. Yes, perfectly right. Okay. So this is how you can solve SHM questions, guys. It's more of little bit mathematical mind you should have, because a lot of manipulations are needed. Formulas are simple. It's not about formulas. It's about manipulating those equations. So most of it is just general, simple algebraic trigonometric math. Okay. Yeah. Okay. Let's go. Next question. So actually you should have fun solving SHM if you love maths, technically. The equations of the displacements are y1 is 0.1 sine 100 pi t plus pi by 3 and y2 is 0.1 cos pi t. Then the phase difference between the velocities at t is equal to 0. See, they have complicated the question. I'll make it simple for you. Phase difference between velocities is the same as phase difference between even displacement and same as phase difference between acceleration. Whatever phase difference is there between velocity is also between displacement, is also between acceleration. There is no such change in that. So it's first of all a simple question. It's not between velocities, it's between displacements, because it is easier to understand. So a lot of people waste time finding velocities. It's a waste. Don't do that. Okay. Just think about displacements over here. So first equation is in sine. So y1 is equal to 0.1 sine 100 pi t plus pi by 3. This was the first phase constant. For the second equation, it is 0.1 cos. I don't like cos. I'll write it as sine. This is 1000 and that is pi. Aha, now things are different, guys. Omega. Omega is not the same. Keep that in mind. Omega is not the same. Is that right? Omega is not the same. This is pi, that is 100 pi. So now you need to be extra careful. Now, whatever we thought over here will have to be reworked, because this is okay as long as their angular velocities are same. But the moment angular velocities are different, then all of them will be moving at different speeds. All of them will be moving at different speeds. So now we have no other choice but to actually sit and figure out for velocity, because omegas are different. So that is the strange part about this particular question. Got it? So let's do that. No other choice for us. So velocity 1 will be derivative of this, which will be 0.1 multiplied by 100 pi into sine's derivative will be cos, and 100 pi t plus pi by 3. But time is 0. So if I put time as 0, so what will happen? 0.1 into 100 is nothing but 10 pi cos of 0 plus pi by 3. Cos 60 is half, so 10 pi multiplied by half. So it will just become, okay, just do one thing, just keep it like this. Don't have to do anything. So just put this as 10 pi cos pi by 3. Just leave it like that. This is velocity 1 at t is equal to 0. Don't have to substitute also anything. Okay. Now, for this guy, v2, velocity will be derivative of this. So 0.1 cos derivative is negative sine. So pi will come outside and sine of pi t will come, but put time value as 0. So v2 will become minus 0.1 pi and sine of basically 0 will come over here. Okay. Now I can't really compare cos and sine, so I will convert it into cos. So this will become, 0.1 pi into cos of, basically, because there is a negative sign, cos of 3 pi by 2. 3 pi by 2 is a better term. Cos 270 degrees is negative 1. Yeah, so now it is comparable. Now it is definitely comparable. Is that right? So this is also cos. That is also cos. Now we are allowed to compare. Till this point, absolutely clear, guys? Pakka? Yeah. Hmm. Okay. Hello, blog gaming. Now what will you do? Now what will you do? Now what will you do? Now just compare these numbers. Whatever is inside, right, that is the phase. That is the phase. So just take out the difference of the two. So delta phase difference will be nothing but 3 pi by 2 minus pi by 3. It's as good as saying 270 degrees minus pi by 3, which is 60 degrees. How much will it come out to be? 210 degrees. 210 is not there in the option. Don't get scared. Okay. Can we also do probably 360 minus 210? That will be the smaller angle possible. So 360 minus 210, that's going to be 150 degrees. So 150 degrees is the phase difference. Yeah. Yes, 150 degrees is the phase difference, but 150 degrees is not there in the option because technically radians wise, it should be nothing but, 5 pi by 6. It should have been 5 pi by 6. Yeah. So technically 5 pi by 6 is the answer, but it is not there. Maybe that number 5 was missing right over here in the C option. Is that okay? Is that absolutely clear? Why I'm saying this 360 minus 210? Because any angle in trigonometry is also 360 minus theta trigonometry wise. Doesn't make a difference. So sine cos will be the same thing. Yeah. So that's why 5 pi by 6 or even 210. But 210 is larger than 180. Usually phase differences are measured between 0 to 180 degrees. Okay. Clear? Awesome. So no need of these options, but if at all you had to put it, I would put the number 5 over here and then mark option C. Great. Let's go to the next question on your screen. A simple pendulum attached to the ceiling has a time period of 1 second. Okay. The distance covered by the lift when it is going down varies as this, where y is in meters, t is in seconds. Time period of the pendulum will be. If the lift is going down, that means acceleration, pseudo force, it will change the value of g, so time period will change. So first figure out how much is the acceleration of the lift. So velocity will be dy by dt, so it will be 3.75 derivative of t square with respect to time. So this will be 3.75 multiplied by 2 into dt, sorry, what am I doing, into 2t. Acceleration will be dv by dt. So it will be nothing but 3.75 into 2 into dt by dt, which is 1. So 2 times of 3.75, which is 7.5 meters per second square is the acceleration. Now the next part. The time period of oscillation is 2 pi under root L by G plus or minus A. Now when the lift goes down, keep that in mind. When the lift goes down, and this is the pendulum, which is oscillating, it's going down with some acceleration. The effective gravity is always G negative A. It's going up is positive, down is negative. Simple fact. So G minus A, that's all. So this will become 2 pi under root L by G minus A. A is 7.5. So this will be 10 minus, what is it? 7.5, which is 2 pi under root L by 2.5. What do I do with this? You might be wondering. Because L is not given. Don't worry. Something else is given to you. And that is, normally it has 1 second time period. So normal time period is 2 pi under root L by G. That one was 2 pi under root L by 10. So just from here, you can clearly see root of L is root of 10 divided by 2 pi. Root of L is root of 10, 2 pi comes down. So just substitute that over here, you will get the answer. So root of L is root of 10 divided by 2 pi. Okay, as it is. So this is 2 pi and root of 2.5. 2 pi cancels. So root of 10 by 2.5 is root of 4. Root of 4 is 2 seconds. So 2 seconds means D is the right answer. So some manipulation was required, that's all, because length was not given to me. So root of L, I got it and substituted root of L over here. That's all. Okay, that is definitely 2 seconds. Very nice. So I've done a lot of questions on oscillations. It's time for the final chapter of waves. And the lecture has been on for more than 10 hours. Yeah, 12th class will be done by Monday, Tuesday, or Wednesday. One of these 3 days. Today is Friday. Tomorrow, day after, I won't be in a position to take it. Already we have planned something for Monday and Tuesday. So let me see how I can manage it. And Monday also I have a class in my batch. So most likely it will be on Tuesday. Most likely, I'm guessing. Okay. Gravity for what? Gravitation or center of mass or what? Chad, quickly tell me, then I'll explain. Gravitation. Okay, ठीक है. Just 1 second. Let me save this file. This file saving is very important. If it gets lost, then gone. I will feel like crying. I'll just give up. Good one, Siddharth. Ferrari is so cooked that Lewis is watching physics. Wow. Okay. Just 1 second. Let me save this file. Okay, great. So let's say we go back to okay, this was solids. Okay, let's say we go back to gravitation only, right? And let's say that force related you are asking, right? That cavity and all of that. Got it, understood. So say for example, we take a question here only before going ahead. Okay, so let's say we have a solid sphere, and inside that we have one more solid sphere which has been taken out completely, like a cavity. This can be for center of mass also or for anything else. And now only this much part is basically remaining. And the question is, how much is the gravitational force or field because of this remaining part over here? Okay, let's say there is this line over here, and now you have placed some another mass, small m, and it is given to me that the original mass was m. Now you have removed something. What is the force between them? Let's say this distance is small r. Okay, it is already given. But the radius of that particular shell, that is given to me as capital. That is given to me as capital R. And initial mass was capital M. So question is, find the gravitational force acting on it. This can be also a question for center of mass also, equivalent. So how to do these problems? First of all, identify if it is linear, two-dimensional or three-dimensional. If it is linear, lambda, mass per unit length. If it is two-dimensional, sigma, mass per unit area, which we just did some time back. And if it is a three-dimensional object, so rho, which is mass per unit volume. This is a sphere, three-dimensional. So stick with rho, which is mass by volume. Simple. Now, what you can do for such cases, you can say this is equal to that big sphere minus that small sphere. That's all. Big sphere minus that particular small sphere. That's it. This big sphere minus this small sphere. Now, okay, the big sphere had that original mass of m, radius was r, but what would it be for that smaller sphere? What would it be for the smaller sphere? You can see the diameter of the small is the radius of the big one. So this should be basically r by 2. This should be r by 2. Very obvious. Okay. Now, what we can do now? Mass per unit volume is constant, right? So we can say density is mass by original volume, which is 4 by 3 pi r cube, is also the mass of that cavity divided by 4 by 3 pi r by 2 whole cube. Now 4 by 3 pi cancels, so m by r cube will be mass of that cavity. This will be also r cube. 2 cube will become 8. So r cube cancels, so mass of that cavity will be m by 8. So once we get that, we'll just put it over here. This is m by 8. And now most of the job is done. So if you look at the other mass from this center, how far it is? Okay, that other mass, how far it is from the center? Let's do that calculation. This is center to center distance, so that is already given as r. So I'll put r over here. But from this center to this mass, it is small r plus this. So it will become r plus r by 2. That's the catch. Okay. Next, this mass will pull it this way. This mass will also pull it this way, but we have to subtract them. So if this is F1, and if I call this as F2, this net force will be F1, not plus, but minus F2, because you're removing this cavity. So whatever force contribution was there because of this guy has been now taken away. So I have to take out that force away from that force by the entire sphere. That's all. So what is F1? F1 is nothing but G m1, which is m, into m2, which is small m, divided by distance, which is r square, minus F2, which is G, the mass, which is m by 8, into the other mass, which is small m, divided by distance square, which is r plus r by 2 whole square. That's it. Solving this, you'll get the answer. Understood? Yeah, 12th I'm not going to do today. 12th I'll be doing it on, what is it? Tuesday. Yeah. Cool. Great. Fair enough. So I hope this doubt is clear. How to find the mass for three-dimensional volumetric objects. Wow. Today I think I have written one book only. Look at this. This is just part 2, guys. There is part 1. I have saved it separately because I know my computer can't handle such a big file. So I have divided it into parts. So part 2 only is going like some crazy 200, 300 slides. Whoa. Okay, waves. Let's go to waves. Hmm. Thank you, Chad, so much. Good night. Thanks for the amazing session. Okay. All right. Yamuna, thank you for your concern, but I will not go right now. I want to stay awake till 12 o'clock with you guys. And I want to teach you. Okay, because your exams are nearby and we have to revise a lot of things. If I go to sleep, you will also go to sleep and you will not study. I think I should stay awake for you guys. Yeah. So we'll do this and then we'll all go to sleep. That's how the motivation builds up. You should always do whatever you feel we should not do.
Okay, come on, guys. Fire up the chat box. Yeah, Arivasu, thank you so much for being with me. Didn't go back. Means a lot, man. Thank you, Aditya. I'm so glad. Harni is also here. Yeah, yeah, we are going to complete this session. Thank you guys so much. Yo, fire up. Let's do. I know the brain is strained. I know we are exhausted physically, but mentally. I know we want it deep inside. We want to get into IIT. Yeah, we want to get into IIT. And you should always push yourself looking at some nice videos from IIT. If you cannot visit IIT, the FES, I mean, just search on the internet, guys, how IIT is, how life at IIT. You can just put life at IIT and see how it is. Oh my God, some girls and all. Okay, guys, this is not something what I was expecting though. Yeah. Oh, we have Tarun speaks. Long time back, Tarun used to be there with Vedantu. Yeah. Anyways, so wow, we have Sindar Puchai and so many nice videos. But yeah, you can have some look at some nice shots of how life at IIT is, and probably motivate yourself. Yeah, maybe sometimes it is distracting too. So that's how distraction begins. You start looking at this, and then you look at, okay, how is the room, how is it, and then one video leads to the other, isn't it? One video leads to the other, second video leads to the third, and now you are enjoying life at IIT without being in IIT, and then you are not preparing for IIT. Crazy. So let's begin the class, and here we are. And what does it say? So whenever you have a wave is basically a phenomena where energy gets transported from one place to another without the particles leaving their place and moving from the source to the destination. Like when I'm talking, the vocal cords are vibrating, that is vibrating the air around me, molecules. So the molecules vibrate. It's not like the molecule from my throat came out of my throat, it is traveling around, say it's going somewhere, and then it is coming onto your ear, and then you are listening to it. No, my vocal cords vibrate, they vibrate the molecules, this molecules vibrate the next molecules, that vibrates the next molecules, and that keeps on happening till the molecules near your ear vibrate. That vibrates your eardrum, and that's how you listen to me. So the energy went from my vocal cords to your ear without the particles from within going from a point to another point. That's wave basically. So if we talk about a transverse wave, the particles will vibrate perpendicular to the direction of the travel. Whereas, example, wave on a string. So if you take a wave on a string, the particles go up and down, but the energy in the wave is going horizontally or normally. And if you take longitudinal waves like the sound waves, the particles vibrate in the same direction as the wave travels. That's longitudinal waves. That's in the form of compressions and rarefactions for longitudinal. For transverse waves, it is peaks and valleys, which is troughs and crests. Okay, trough and crest is for transverse waves. So you have a wave like this, which is moving with some speed v, which is also called as the wave speed. And this wave speed is lambda into f, where lambda is the wavelength. So one crest to another crest, or one trough to another trough, one identical point to the next identical point on that wave immediately is lambda. How fast it goes up and down, that's the frequency, and how much it goes up and down, that is your amplitude. Okay, same logic for frequency, guys. There is nothing great about it. Frequency is 1 by your time period, and 2 pi f, which is also 2 pi by time period, is omega, which is angular frequency, which is always radians per second. Now you define, I think that is there on the next slide also. What is omega? Yeah, 2 pi f. Okay, it was there, not needed here. Omega is 2 pi by t, which is 2 pi f. T is the time period. F is frequency standard. Now, yes, wave speed is lambda into f, lambda into the frequency, how quickly it's going up and down. But you can also write it as omega by k, where k is your
new quantity angular wave number, that means how many radians are there per meter of that wave. So 2 pi by lambda is angular wave number. This is not wave number, this is angular wave number. Angular wave number. So it is also omega divided by k. Very important relationship. Now, what did I want to tell over here? Lambda into f, omega by k, wave velocity done, amplitude also done. Okay, fair enough. Awesome. Okay. These are basic parameters still here. Anything else which I need? What is that meaning of angular wave number? I'll tell you. See, what happens is when you take one complete wave, so when you take one wave, that means you have taken one complete oscillation, and one oscillation, remember, always corresponds to 2 pi radians. That's exactly what it means. So when I say the angular wave number is, for example, pi radian per meter, meaning if I go 1 meter, I'm only getting pi radians. Now pi radians means half a wave. So if I go 1 more meter, I will get extra pi radians and I'll get a complete wave. So the wavelength is basically 2 meters. And it makes sense. If you put k as pi, pi cancels, lambda will come out to be 2 meters. So that is what k represents. Angular wave number, because one wavelength always responds to one oscillation, which is 2 pi radians. Same way, one period also corresponds to exactly one oscillation, which is 2 pi radians. Now keep this in mind. The source of the wave, the source of that wave always decides the amplitude and the frequency. The medium through which it travels decides the wave speed, and together both of them decide the wavelength, which is v divided by f. This flow of logic should be very clear in your head. Sometimes I tell the medium changes, and you will think, what will change? If medium changes, speed will change. But frequency was already decided by the source who created it. So frequency will not change. So automatically wavelength will get changed if speed changes. The source changes in the same medium. So speed will not change. Frequency will increase. Naturally, wavelength will decrease, or something like that will happen. So many people get confused. What changes what? So lambda is the last person to be decided, the least priority. It's always the frequency and speed which gets decided, and lambda accordingly calculates itself. Is that absolutely clear? Yes, Arivasu, there was a long time back. There is a video of me and him very, very long time back. Correct. Yeah. Yes, Pawan, there will be a 12th standard video separately. Okay, great. Now, once you understand all these things, let's go to the equation of a wave, because inside a wave, the y value will keep changing as x changes or time changes, and the equation is given by this. Y is a sine kx plus minus omega t, or kx common and vt. It's okay. It's the same thing. Don't get confuse yourself. Forget this. Okay. It's not necessary that you have to use sine. You can also use cos or sine, doesn't matter. It's not necessary kx plus minus omega t. It can be also omega t plus minus kx. It doesn't really matter what order you write it. What you should remember is this. If there is a positive sign, it means that the wave is traveling in the negative direction of x. And if there is a negative sign here, then the wave is traveling in the positive direction of x. So it's exactly opposite. Keep that in mind. Okay. So very, very important. This is how a wave equation looks like. A sine kx plus minus omega t. See, so the value of how much y displacement is there. So what does this equation actually mean? Many people think. I'll tell you. So let's say this was your equation. So you move some x units, you get some value of y. This is your x, this is that y value. This y won't remain the same because as the wave progresses, this point will go up and down. So that's why y is a function of x and time both. And how it changes is given by this particular function. That is the meaning of a wave equation. Keep that in mind. Okay? It can be sine, cos, omega t plus minus or kx plus minus omega t. All right. Now, with this, we can do some questions based on that. Now, by the way, you can also get, some phase constant as well. So, you might sometimes have kx plus minus omega t plus phi. That phi is the same phase constant, which you can get phase constant. And if there are two waves, then phi 1 minus phi 2 will give you nothing but the phase difference. It will also give you something called as the phase difference. Phase difference. Lastly, phase difference can also resemble, let me go back over here. Okay, I'll write it down over here. So say for example, you have this wave and you take 2 points separated by a distance of delta x. These 2 points have two particles which are oscillating but not in the same phase. There is some phase difference between them. That phase difference is simply 2 pi divided by lambda multiplied by delta x. So any two particles on the wave have a phase difference given by 2 pi by lambda into delta x. Reason is simple. If the difference is lambda, the phase difference is 2 pi. One wavelength difference, both the particles go up and down with a phase difference of 2 pi. So if the difference of the distance is delta x, the phase difference is delta phi. So unitary method, if you use 2 pi by lambda into delta x, is going to give you delta phi. Okay, that's the logic behind it. So let's do some questions coming up on your screen. A wave traveling is given by this, where x and y are in meters, t is in seconds, then the frequency of the wave is how much? Okay, let's do this simple. So whatever multiplies by time is omega. So 10 pi is basically omega. Omega is 2 pi f. Pi cancels. So 10 by 2 is f. So f is basically 5 hertz. So which is D option, absolutely right. Let's say another question was made. What is the wave speed? Then you can say it is omega by k. Omega is 10 pi. Omega is 10 pi. K is nothing but 70 pi. I think this pi is missing. So it is nothing but 70 pi. So this will become 1 by 7 meters per second. That's it. Is that clear? If let's say wavelength was asked, then this particular value 70 pi will be k, which is 2 pi by lambda. Pi cancels. So 70 is equal to 2 by lambda. So lambda will be 2 by 70, which is 1 by 35 meters. So wavelength will be 1 by 35 meters. So that's how you can solve the questions. Okay. So from one single wave equation, you can find literally every characteristics about the wave. Okay. All right. Very nice. Is that clear, everyone? Perfecto. Let's go ahead then to the next question. Path difference between the two waves. Path difference between the two waves is how much? One of the wave is this, another wave is this. As you can see, both are sine. Omega is same. This is also okay. Here there is no phi, here there is phi. So from this, the phase difference is actually phi minus 0, which is actually phi. And we all know phase difference is 2 pi by lambda into delta x. So therefore, delta x will be lambda phi divided by 2 pi. This is how much is your path difference. This is length difference or path difference. Delta phi is your phase difference. So yeah, lambda phi by 2 pi, lambda phi by 2 pi, that is obviously C option. Yeah. 12th portion after few days, like I mentioned. Okay. Yes. Very nice. Let's go ahead. Let's go ahead. Now, what is the speed of a wave on a string? Just like I have told you before, in this particular case, the medium decides the speed. Keep that in mind. So, medium decides the speed of a wave. So, the speed of a wave on a string is decided by how much tension is there and how much mass is there per unit length. So, the medium. So, root of tension divided by mu. Okay, keep that in mind. So, this is the speed of a transverse wave on a string. Similarly, what is the speed of sound which is longitudinal? Longitudinal. Now, depending on the medium, you have different formulas. For example, if you want to find the speed of sound in a solid, then use the root of very similar. Instead of tension, there is Young's modulus, and instead of mass per unit length, you have density. Yeah, keep this in mind. This mu is mass per unit length, so it is m divided by L. This is your regular density. Whereas, if you want to find speed of sound in a liquid, then instead of Young's modulus, use bulk modulus and divide it by density. Lastly comes speed of sound in a gas. Ideal gas we take. It is nothing but instead of bulk modulus, you put pressure, and over here you put rho, but with gamma. And this can be also written down as gamma RT divided by M. This process of sound traveling in a gas is always adiabatic, and this formula was given by Laplace. This is called as the Laplace formula for speed of sound in an ideal gas. And the compressions and the rarefactions are always adiabatic in nature. That is why that gamma comes over there. Okay. So these formulas, please keep it in mind. Okay, great. All right. So let's see if we have some questions based on speed of sound. This one. Let's do this. The equation of a transverse wave propagating on a string is given by this equation. Then, if the mass of the string is 3 grams, then the tension in the string is uh, tension in the string is how much? 80 centimeters, I think, is the length, I believe. Okay, is how much? So 80 centimeters is the length of that particular string. I'm assuming that is what is given. Okay, or else it won't come out to be the correct answer. Yes, somebody answer, Surendra, guys. If somebody is asking such questions, please, you should, yeah, tell them the answer, isn't it? Okay. First, let's start with velocity of the sound is given by root of tension by mu, but tension in the string is asked, mass per unit length is m by L. Squaring both sides, V square will be T divided by m by L. Therefore, tension will be V square into m divided by L. Velocity I don't know, m I know, L I know. How do I find velocity? Velocity is omega by k. From here, I can say omega is 20, whatever multiplies by time. Whatever multiplies with x is k, so it is 5 into 10 to the power minus 3. So 20 by 5 is 4, and this will become 10 to the power 3. So put that over here. 4 into 10 to the power 3 is the velocity value. Square it. Mass is how much? 3 grams. So 3 into 10 to the power minus 3. Length is how much? 0.8. You can simplify it a little bit. Like 4 square is 16 into 10 to the power 6 into 3 into 10 to the power minus 3. Whole thing divided by 8 into 10 to the power minus 1. 8 and 16 goes 2 times. 2 into 3 is 6. Okay. Minus 1 and this -1, -2, 6 and -2 will become 4. So 6 into 10 to the power 4. Oh my god, I'm getting it as Newton. Have I missed something? Let me know, guys. Let me know if I missed something. My brain is not braining now. It should be 6 into 10 to the power 4. Hold on. X and Y are in centimeters and T is in time. I think that's where we have made a mistake. See, guys, over here only, there is a problem. Hmm. So I'll tell you what. Omega is 20, okay? K is not really this because this will not be radian per meter, this will be radian per centimeter. That's the problem. So this is 5 into 10 to the power -3 radian per centimeter. So per centimeter, if it is this much, so per meter, it will be divided by 100, I believe. Sorry, into 100, my bad. Into 100, into 100. So this will become 20 by 5 is 4. This will become 10 to the power -1. So on the top, it will become just 40. Now, if you substitute this velocity as 40 over here, let's see what do we get. This is 40 square, mass is 3 grams, so 10 to the power -3 kilos. Length is 80 centimeters, so which is 0.8. So 40 square is 1600 into 3 into 10 to the power -3 divided by 8 into 10 to the power -1. Okay, this will go on the top -2. Okay, there's 2 zeros here, 2 zeros negative here gone. So 16 by 8 is 2, 2 3s are 6. So 6 Newton should be the answer, which is C for Kepler Shreyas. Yes, it is 6 Newton. So the catch was here, the conversion of the units. If you miss that, you will get completely a different answer. Cool? Amazing. There can be more questions on this, something like this, where they tell you what is the ratio of speed of sound in oxygen to its RMS speed. To its RMS speed. Okay, that's a very interesting question. So, if you realize the speed of sound was root of gamma RT by M, and the RMS speed is root 3 RT by M. So if I want to take the ratio of the speed of sound by the RMS velocity, RT and M are constant, so it will be gamma by 3. Gamma, this is oxygen, which is diatomic, it will be 7 by 5. So I'll put 7 by 5 over here divided by 3. So this will become 7 by 15. So that ratio is root 7 is to root 15. That is the ratio of speed of sound upon RMS velocity. Sometimes those kind of questions can also pop up. Okay, keep this in mind. Great. So now let's go to the next thing, which is energy, which is being transmitted by a wave. So whenever wave is there, obviously energy will go, right? Energy will go and from one point to the other without the particles themselves going. So how much energy is going per unit time for a transverse wave, is half mu, which is mass per unit length, into omega, same angular frequency, into a square into velocity. Very, very different formula, very rarely used, but if it comes, if you don't know it, gone. So the power transmitted by a wave, simply put, is half mu v omega square a square. Every single time you will see the power, energy, everything is always proportional to the square of the amplitude. And this you have seen even in light waves. If amplitude doubles, intensity becomes 4 times, power becomes 4 times. So this is also true over here. So half mu, mass per unit length, into v, which is wave speed, into omega square into a square. But if you are talking about sound waves, then generally you don't talk about power, you talk about intensity. That means energy per unit time per unit area. That's the only difference. That is given by half rho omega square a square v square. Okay, so sometimes you don't like this formula, then you use intensity is half rho, and then I think you have just v square over here. Yeah, half rho v square. V is the speed, rho is the density. That's it. You directly get the intensity formula. Okay, so this is another way of writing intensity instead of writing it like this. Okay, instead of dividing it by area. So it's the same thing, but you are dividing it by area so that mu becomes rho. Everything else is the same. It's one and the same thing. You can rewrite all these expressions like that, but sometimes people don't like it like this. So it's okay. You can write it like this also. Okay, ignore that formula. Amazing. Now, having said this, let's do a question on this particular intensity part. Or power part. If a wave travels from a thin copper wire of radius r to 2r, find new is to old, number one, speed, number two, power, assuming the amplitude is half of initial. That is the question. Let's try to look at this question. So we have a copper wire whose radius is r, and now the radius becomes 2r. Now you are sending in a wave over here like this. The wave speed is going to change. First of all, what is the wave speed dependent on? It is root of tension by mass per unit length. I'll tell you one thing about mass per unit length. This is mass per unit length, right? So how about writing that mass as density into volume per unit length? Then what happens is that right? Mass is density into volume, not this velocity, this is volume. Volume is nothing but area multiplied by length. Length cancels, and I'm left with root of tension by density into basically the area. So what this tells me is now velocity is root of tension by density into area. Area is nothing but pi r square. So r comes out. So 1 by r root of tension divided by rho pi. That's your velocity. Clearly, this means velocity is inversely proportional to the radius given density and tension are constant, which is true because same wire is just being doubled. So tension is still the same. Okay, and density of copper will remain the same. It will not be different. So it is inversely proportional to the radius. So the new by the old velocity will be old radius by the new radius. So old was 1, so new is double. So 1 is to 2. will be the ratio of the speeds. So this is nothing but your speeds ratio. So the first part of the problem, I have done it. Till this point, absolutely clear? We did this? Perfect. Perfect. Okay. Now, let's do the second part, which is basically the power part. How do I do the power part? Let's think. The power formula is given by half mu v a square omega square. One thing is certain, omega depends on the source and source has not changed, so frequency will remain constant. Amplitude has changed, v has changed, so has mu changed. In fact, if you rewrite this equation, you will understand this is half mu, velocity is root of tension by mu into a square omega square. Root mu will cancel and it will look like this, root t mu into a square omega square. So this is as good as saying root of tension into mu. Mu is mass per unit length, okay, and into a square omega square. But mass is density into volume. Density into volume. Volume is area into length. And this is a square omega square. LL cancels, so it will become half root tension rho. Area is pi r square, and this is a square and omega square. Don't confuse between this a and this a. This is area, this is amplitude. Don't get confused. Okay. So therefore, my power will be root of r square is r. So r is outside, and a square omega square is also there. 2 is also there, and root of t rho pi is there. So clearly, power is proportional to radius, square of amplitude, and all these things. These are constants. So power is proportional to r a square. So the new power by our old power is new radius by old radius. So 2r by r. Amplitude has become half. So a by 2 by a. So it will become 1:1. It will just become 1:1. You can use ChatGPT, but I'm telling you, it is not always the best, but it will definitely help you. Not sure how much, but definitely better than what you would plan. Okay. Always the best thing is to be with a teacher who can actually guide you, because sometimes the ChatGPT data can be wrong, because it might just pick out data from multiple sources from different institutions, and sometimes the data is not updated, so you might get a wrong plan also. So that is the only thing which you should be little bit careful about. Okay, ChatGPT is just a better search engine, please understand that. Those of you who understand how machine learning works knows what I'm talking about. Okay, it's just that it's very good at search and presenting it. Right now it is not AGI, it is just AI. Okay, and this AI is more of iterations and better searching and just learning from what it has been trained. It cannot really think on its own and create a new thing. Although you might think it is creating a new thing, it is actually not. Okay. Last few topics, interference of waves. So whenever two or more waves interfere and they create a resultant wave, then they are superimposed and the new wave is called as the resultant wave. So if let's say this is the wave number 1, this is wave number 2, you add both of them, you will get the resultant wave. But not every time the amplitudes are same, it could be different also. So, things will be A1 and A2. Then that waves are said to be interfering. And how do I find the resultant? The logic is simple, using vector addition. So imagine there is a wave whose amplitude is A1 and another wave whose amplitude is A2. They are clearly not in the same phase. That means their crests and troughs are not really aligned. So there is a phase difference between them. Then whenever you want to combine them together and get, these are the interfering waves, you want to get the resultant wave. which will have a new amplitude A. That new amplitude is given by, just like vector addition, guys. Yes, treat the amplitude like vectors, A1 and A2. This is, let's say, A1, this is, let's say, A2. You will get the resultant like this. This is the resultant wave's amplitude. And yes, the angle between the two vectors will be their phase difference. This is delta phi. So A1 square plus A2 square plus 2A1 A2 is into cos phi. Root of that is resultant wave's amplitude. Yeah. Yes, ChatGPT is very well trained for sugarcoating things. Yeah, way they are does not sugarcoat. It tells blatantly, boss, not possible or possible. I don't know whether it's good or bad, but yeah, that's the thing. Now, if both the amplitudes are aligned together, then the phase difference is zero. Okay, phase difference is zero or even multiples of 2 pi. Okay, or even multiples of pi, my bad. So like 2 pi, 4 pi, 6 pi, 8 pi. That means both the vectors are in phase. So the amplitude of the resultant will be maximum. Such a thing is called constructive interference. Maximum amplitude. Whereas if the vectors are oppositely aligned, that means crest with trough, trough with crest, then the vectors are having a phase difference of pi, 3 pi, 5 pi, odd pi basically. So 180 degrees, they are said to be out of phase. Then the amplitude which you get will be minimum because the resultant will be the least. Makes sense. Vector subtraction kind of thing. Okay, A1 minus A2. Not actually vector subtraction, it's addition, but with opposite vectors. So that is destructive interference. Now, lastly, what about the intensity or the power? So if this has power 1, this has power 2, this has resultant power P or intensity I, then the resultant intensity or power is P1 plus P2 or I1 plus I2 into 2 root I1 I2 or P1 P2, depending on what you are calculating, power or intensity, into cos of phi. As simple as that. So that gives you the formula. This is also there in light waves, but also there in 11 standard. So this is the main construction and destruction interference that you should know, or any phase difference. What is the amplitude or the intensity? It's basically vector addition of the amplitudes with the phase difference as the angle between the vectors. Let's do some questions on that maybe. And here it is. Two waves are represented by these equations. Okay, you can see omegas are different. Then the time interval between two successive maximum intensities are, oh, we have come to beats, my bad. 1 second, we'll go to that also later on. First, let me do a question on this. If y1 is equal to, say for example, 6 sine 100 pi x minus 40 pi t, and y2 is 8 sine 100 pi x minus 40 pi t plus, I don't know, maybe pi by 6, then the amplitude of resultant and its frequency is how much? Amplitude of the resultant and its frequency is how much? First things first, frequency. This frequency will be the same, whatever is over here, it will not change. So 2 pi f will be 40 pi, it will never change. So f will be pi pi cancels, 40 by 2, which is just 20 hertz. Frequency never changes. Keep that in mind. Even wavelength will not change. Main thing is this, which is the amplitude of the resultant, which is root of a1 square plus a2 square plus 2a1 a2 cos phi. Okay. What is the first amplitude? First amplitude is 6, next amplitude is 8, next is 2 into 6 into 8 into cos of phase difference. What is that phase difference? Phase difference is pi by 6. Pi by 6, we can take it as pi by 3 so that we get some good answers instead of all these nonsense. So let's put it as pi by 3, guys. We'll get good values. With pi by 6, I will not get such good values. Okay, so I'm just deliberately putting it as pi by 3. No harm. Okay, so this will become cos of 60, which is nothing but half. Okay, 6 square, 36, 8 square, 64. 2 cancels, 8 6 are 48. So 36 plus 64, 100, 148. Root of 148. So it will be basically 12 point something. So this is the resultant amplitude. So maybe 12.1 or 12.2, almost like that. Got it, everyone? Okay, we have just completed 11 hours on this stream. All right, amazing. It's 12 o'clock almost. Great. Next question coming up on your screen, and here it is. If a wave with intensity I interferes with other wave with double amplitude and path difference lambda by, let's say, 4, then resultant intensity is, then the resultant intensity is how much? That's the question. Let's try to do this. Now, what happens over here is you have wave number 1, wave number 2. First amplitude is A, the next one is double of the amplitude. Intensity of the first is I. Intensity is proportional to the square of the amplitude, so it will become 4I. Keep that in mind. Okay? Yeah. That's the first thing we got. What is the intensities of both the waves? Next thing, phase difference, path difference is given. So delta phi is 2 pi by lambda into delta x. So it will become 2 pi by lambda into lambda by 4. So it will just become pi by 2. That is your phase difference. Last thing now is the resultant intensity. It is I1 plus I2 plus 2 root I1 I2 into cos phase difference. I1 is I2 is 4I plus 2 root I multiplied by 4I into cos of pi by 2. Now I plus 4I is pi by, but whatever happens here, this is 90's cos, which is obviously 0. So the final intensity is 5 times of I. That is the answer. Got it? Very good. I'm so glad you cracked KEEM and you have got the Government Engineering College seat in Kerala. I'm so glad, Afzal CS6440. Very good. Yes, Harshin, it's 00.00. 12 o'clock. Amazing. Great. Now, the last thing over here in interference is the phenomena of beats. Beats. So when you have two waves with nearly the same frequency, almost F1, F2, okay, let's say for example, the wave of this is A1 sine omega 1t and this is A2 sine omega 2 into t. Then when you add both of them, the resultant wave looks something like this. It becomes small, then it becomes big, then it becomes small, then again it becomes big, and again it becomes small, like that. So it becomes maximum, minimum, maximum, minimum. So between minimum to minimum or between maximum to maximum, that is called as the beat period. And this phenomena of identical frequencies, similar, not identical, being added is called as beats. So maximum, minimum, maximum, minimum. So from one maximum to one maximum, one minimum to one minimum is called as the beat period. So we get the beat frequency now. So the beat frequency is 1 by that beat period, 1 by that beat period, and that exactly comes out to be just the positive difference of those two frequencies, f1 minus f2. And if you are talking about omega of that beat frequency, that also comes out as omega 1 minus omega 2 modulus of that. So that is the beat frequency. That means how frequently you are hearing those loud sounds between those faint sounds. That is the meaning of it. A very similar question is there over here. This is usually done with tuning forks and all of that. So imagine there are two tuning forks like this of these waves. You can see 250 pi and 260 pi close enough to each other. Then the time interval between two successive maxima or minima, it's exactly beat that they have asked. Time interval between two successive maxima is the beat period. So first figure out the beat frequency, you will get the answer. So beat frequency is f1 minus f2, but f1 and f2 are not given. Pi means omega is given. So what I can do, f is nothing but 2 pi, sorry, it's nothing but omega 1 by 2 pi, and this is nothing but omega 2 divided by 2 pi. So 1 by 2 pi comes outside. I'll take the bigger minus smaller. So it will be 260 260 pi minus 250 pi. Yeah, one is 260, one is 250. So these values that you see, that is nothing but your omegas. Okay, substituted that. So it will become 10 pi divided by 2 pi, which is basically 5. So that is in hertz. So we want the beat period, which is 1 by beat frequency. So it will be 1 by 5, which is 0.2 seconds. So 0.2 seconds is option D, of course. Yeah, it's option D. Okay, guys, clear? Oh, nice. Yesterday only you did this experiment on tuning fork. So this is also true for tuning forks. Okay, directly you can use these formulas. Now let's go to the last part of today's lecture, and that is your standing waves. So what are these standing waves? Let us discuss it. When you have two identical waves, that means same energy, same amplitude, but the only difference is their direction. They are both going in the opposite direction. Then when they interfere, the energy is neither going from left to right nor from right to left. Rather, it has got stuck, it's got trapped, and that wave formation is then called standing waves or stationary waves. There is nothing stationary about it except for energy. The waves are still animated, they keep going up and down, but the energy is trapped and stationary. So that's why the name stationary waves. Now, what happens, how the waves look like is something like this. So you will see once you combine both of them, once the wave might be like this, after some time it will probably look like this. I'll draw it properly. After some time, maybe it will look flat. After some time, it might look like this. After some time, it might just be like this. After some time, flat. Again, after some time, like this. Again, like that. So it keeps moving like this. So you will see that it is not your regular traveling wave. The wave is continuously going. Rather, it is going up and down like a skipping rope. Now, each of these regions over here that you see, they are called as a loop or a lobe, whatever you want to call it. And you can also notice that there is exactly one wave over here, and a loop or a lobe lengthwise, naturally, it is half of that wavelength. So that loop or lobe is lambda by 2. So a loop or a lobe is lambda by 2. So the wave keeps going up and down. It is not traveling, it is stationary, it is trapped energy. These points which you see over here, what are they called? Yes, they are called as nodes because they have zero or least amplitude, whereas these places over here, here, they move maximum. So they are called antinodes. They are called antinodes. What's the main difference between traveling wave and standing wave? Yes, energy is not moving, it's trapped in a region. But you will see that within a loop, all the particles go up and all the particles come down simultaneously. That's not the case of a traveling wave. One particle is going up, another particle is following it, then this is coming down, still this might be going up, then this will come down. So in a traveling wave, the particles need not be always going up and coming down, but in a loop or a lobe of a standing wave, they all go up and come down simultaneously. So there is no phase lag or phase difference between these particles. Second thing, each particle moves up and down differently, which was not the case for traveling wave. If a particle goes up till A, this particle will go up till A after some time. Phase difference is there, but amplitudes are same. But here, this will have maximum, this will have medium, this will have none. Amplitudes are different for every single particle. So very big fundamental differences which are there. Yeah. Yes. Good morning, everyone. Now, the equation of the standing wave, as you can see, if this is one equation, omega t minus kx means it's going right side, omega t plus kx means it's going left side. So if you add both of them, y1 and y2, you get 2a cos kx sine omega t. Now out of this, keep in mind, this part is the amplitude. You can see with x, the term will change. So if x is 0, x is 1 meter, 2 meter, 3 meter, how much is the amplitude keeps on changing. This is that part which is the oscillating part. Sine omega t, duck, 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 it will oscillate. So if you take any particle, it will keep on oscillating. How much it oscillates is given by this term. Okay, is that clear? Yeah, perfect. Now, how do you create a standing wave? Now, very simply put, what you do is you take a string and you make it go up and down. A wave is generated. The wave begins to travel. On the other side, what you do, you can create a reflector which reflects those waves. Either it could be a fixed end or it could be a free end, doesn't matter. You have this wave, it is going like this. It's a free end, like that. So the difference between a fixed end and a free end is if you have a crest traveling to a fixed end versus that same crest traveling to a free end. This is incident. After reflection from a fixed end, crest will become a trough, whereas here it remains as a crest when it reflects from a free end. That's the major difference, okay, between a fixed end reflection and a free end reflection. So when it reflects from here and you are still generating the waves. So what happens eventually, you have your waves which are filling it up over here. You have your fixed end over here. Now you also have the waves which are getting reflected back and coming this side. So you have one set of waves coming like this. You still are generating over here one set of waves going like this. Two waves in opposite direction. You will definitely now get, after some time, a standing wave pattern. So we'll now get basically a standing wave pattern over here. But the standing wave pattern is such that always the fixed side will have a node. That's very, very important. This part will definitely have a node, no matter what you do. But for the free side, if you are doing it over here, eventually these waves are going to reach the free end. and now they will be reflected. So once they start to reflect, maybe like this, it's writing it like that. They are going like this. So one set of wave going like this, another set of wave is still going like this. What you will eventually see is basically on the free side an antinode. Yes, you are going to basically see an antinode on the free side. So to create a standing wave on a string, keep on generating the wave, let it reflect and come back. So now you have two waves going in the opposite direction. So they will definitely create a standing wave pattern like you would expect for a standing wave. Now there are multiple possibilities in this depending on what kind of string you are using and what kind of ends are there. So let me tell you simply fixed or free. What are the possibilities? So one possibility, both sides are fixed, or both the sides are free. Fix or free. In such cases, fixed should always get a node, free should always get a antinode. That is for sure, there is no doubt about it. So what happens is, possible options of oscillations look something like that. So you might probably get just one lobe over here like this, or you might probably just get two lobes over here, or you might just get three lobes over here like this. Here you might just get half a lobe here and half a lobe here. Half a lobe here and half a lobe here. Or you might just get something like this, or might get something like this. Looks like DNA structures. Yeah. So these are the possibilities. You can have many more such possibilities. Now the thing about this first diagram is the wavelength is maximum, so frequency is least. So that is the least frequency possible. So that is also called as the fundamental frequency. So this is called as fundamental. This is called as fundamental. This is the next possible thing, and this is F2. This is the next possible thing. This is F3. This is also called as the first harmonic. This is called as, sorry, not first harmonic, my bad, second harmonic. This is called as the second harmonic. This is called as the third harmonic. The fundamental is also called as the first harmonic, naming wise. And these frequencies in general, if you see, Fn is going to be n times V divided by 2 times of the length. L is the length of that wire. This length of that wire is basically L. That is fixed. V is the speed of wave on the string, root of tension by mu. N is which harmonic number are you talking about. So this is the generic formula of that. Very simple and straightforward. There is another way of writing it in terms of overtone. So this is fundamental, forget it. This is called first overtone. This is called second overtone, and so on and so forth. So basically, second harmonic is first overtone, third harmonic is second overtone, fourth harmonic is third overtone, and so on and so forth. So sometimes they talk in overtones. So OT stands for overtone. Sometimes they might give the problem in terms of harmonic. So for fixed on both or free on both, the answers are the same. because their numbering, nomenclature, everything is the same. No doubt about it. Okay, great, great. Now, what happens when one side is fixed whereas one side is free? Let's have a look. So, let's take that situation as well over here. Let's say this is fixed and this is free. Fixed should be node, free should be antinode. There is no doubt about it. Fixed should be node, free should be always an antinode when the waves get reflected. So what happens is over here, possible options, node and antinode, right? So this is one possibility. This is another possibility. This is another possibility. Yeah, and so on and so forth. Now, the wavelength is the largest here, so the frequency is the least. This is F1. This is slightly higher wave frequency because smaller wavelength, more smaller wavelength, more frequency, and all of that. Yes, this is the fundamental. This is the fundamental. This is then the first overtone. This is the, sorry, this is the second overtone, and then the third overtone, and all of that. But frequency wise, this is not second frequency, third frequency. That is a common mistake. In fact, in general, the frequency will be odd times V by 4L. So F1 is having the odd number as 1. Yes, the odd number over here, the odd number over here is 1. The next odd number is 3. The next odd number is 5. So if F1 is V by 4L, the next frequency will be 5E by 4L. So the second frequency is absent, rather the third frequency is present. So this is F3. Then next is basically F5. Next is basically F5. So only odd harmonics are present. So this is actually first harmonic, this is third harmonic, and this is fifth harmonic. So odd harmonics are present, even harmonics are absent. That's the funny thing about fixed free end. Now, how to decide harmonics and overtones? Let me give you a simple example to make you understand that. Say, for example, my least frequency possible is 20 hertz. Next is 40, next is 50, next is 60, next is, or maybe it is 10 over here, and next is directly 100. Imagine these are the possible frequencies. Chumma, I'm writing it. Okay, all these are in hertz. Now, let's talk about harmonics. Harmonics means first take the least frequency. Which is the least frequency? 10. How many times the least frequency is your actual frequency? So 10 is 1 times of 10. So this is first harmonic. 20 is 2 times of 10. So this is second harmonic. 40 is 4 times. So this is fourth harmonic. 50 is 5 times. So this is fifth harmonic. This is sixth harmonic. And this is 10th harmonic. In between, nothing is there. So leave that. Seventh is absent. Third is absent. Eighth is absent. Ninth is also absent. That is how you give harmonic numbers. How many times? The fundamental. Overtone. Overtone goes perfectly sequentially. The least frequency is always called fundamental. It's not given overtone. This is fundamental frequency. This is immediately the next. So this is first overtone. This is the next one. Just pure numbering, labeling, serial number. Second, this is third. You don't even have to look what is there over here. Fourth, and this is fifth. It goes serially. So this is just a serial number after fundamental. This is the multiple of the fundamental. That's all. Understood how overtone versus harmonic is decided? Very good, CV. Proud of you. Amazing, amazing. Great. So these are the formulas, antinodes, nodes, everything we're done. Okay, main theory is done. So it's also true for organ pipes, you will see. So the same logic. Yeah, I will not repeat the same thing again. So if you have an organ pipe like a flute or a musical instrument, so it's possible that either you have a closed end of the pipe or an open end of the pipe. The same thing happens for a closed side. You will always end up with a node. For an open side, you will always end up with an antinode. But there is a small thing about these things over here for organ pipe. This antinode is slightly outside. Yeah, the antinode is slightly outside the actual end. That is called as the end correction. That is called as the end correction. And this end correction is 0.3 times the diameter of that pipe. 0.3 times the diameter of that pipe. So the antinode is slightly outside. So the effective length that you take, will be original length plus the end correction, plus this end correction. So all these formulas which you see, which has L, so instead of L, you will take L plus E. That's all. L plus E. Okay, keep that in mind. Great. So maybe we can do some questions on this. Few questions only are there. Oh, yeah, there we go. All right, let's do. In a closed organ pipe, the number of nodes formed in the fifth and ninth harmonics are respectively. What do I mean by closed organ pipe? First of all, think about that. A lot of people think a closed organ pipe means both sides are closed. That is wrong. If both sides are closed, how will the sound enter inside? It just means one side is closed and the other side is still open. This is a closed organ pipe. If it says open pipe, then it is open on both sides. So closed organ pipe does not mean closed on both sides. It means closed on one side. Open pipe means literally open pipe from both sides. Is this difference clear? Never make this mistake again. All right. So having said that, number of nodes formed in the fifth and the ninth harmonic are fifth harmonic. Only remember this is closed open, so only odd harmonics are present. Only odd harmonics are present. So if you are talking about fifth harmonic and then ninth harmonic, first harmonic will be something like this. Then next harmonic, third harmonic will be like this. Then next harmonic will be like this. So this is first, this is third, this is fifth, then you will have seventh, and then you will have ninth. So in seventh, you will have 1, 2, and 3, and then like this. 1, 2, 3, and like this. 2, 3, and like this. Next will be 1, 2, 3, 4, and like this. Yeah. So these are your harmonics. Now just count the number of what? Nodes in the fifth and the ninth harmonics respectively. This is fifth, 1, 2, 3. In ninth, 1, 2, 3, 4, and 5. So 3 and 5 is what third option says. 3 and 5 is what the third option says. So that is the answer. 3 and 5. Is that okay? Everyone? No, it's not 5 and 7. It's 3 and 5. Directly you can count it. All right, everyone. Pakka? Shall we do one more question? Yeah, IIT questions will be doing later on, ISER aptitude. All right. The frequency of the fifth harmonic of an closed organ pipe is equal to the frequency of the third harmonic of an open pipe. And the length of the open pipe is 70 to the length of the closed pipe is how much? Okay. So let's see one by one. Closed organ pipe, meaning closed on one side. So closed on one side, means closed on one side means it's like this. Fixed, free. Closed, open. Where is it? Here. Closed, open. Exactly. So, for this particular closed organ pipe, the frequency closed will be odd times V divided by 4LC. Now, since it is given fifth harmonic, already the odd number is 5. So, this will become 5V by 4 times of LC. Okay. Next, let's look at the open organ pipe. Open means open on both sides, free on both sides. So, the frequency of the open pipe is just N times V by 2L, but this is open. Now, it is clearly mentioned third harmonic. Yeah, it's clearly mentioned third harmonic right over here. So, N will be 3 and this is V divided by 2L. It's also mentioned next that both the frequencies are equal. The frequencies are equal, so I can just equate both of them. So, V and V will anyways get cancelled. So, 5V by 4 into length of open pipe is 72. Closed organ pipe they have asked is 3 into V divided by 2 into this is 72. V will get cancelled. So, therefore, my LC will become 5, 3 comes below, 4 is there as it is, 2 will go on the top along with 72. Come on, do the math quickly and tell me. 2 by 4, 2, 72 by 2, 36. 36 divided by 3, 12. 12 5s are 60. So 60 centimeters, which is option A. Yes, option A is the right answer. Perfect. There we go. Directly. Yeah, that's it. And we have come. There was a break planned. I had planned. The funny part is I had planned to end this by 7:30, but it is not possible, guys. So as you saw, because we had to do literally everything, and I feel this was a very good 11th standard complete revision. If you want the 12th standard revision to be done in this manner, okay, you can definitely write a comment. Only if you write a comment, then on Tuesday or maximum by Wednesday, I will be conducting a session. Want it? Please mention need 12th revision exactly like this. All right. Do not forget to like and subscribe. Thank you so much. Now, Captain Shreyas Sir will sleep. So shall you. Okay. Bye bye. So this was a 11.5 hour marathon. I believe everybody loved it. Thank you so much, guys. Bye bye. Take care.